So now I'm gonna learn Node.js, and I think I'm gonna do the test after that because I didn't do the test. And once it gets late here, I'm probably gonna turn on the camera, but for now, I think I'm just gonna leave it like this because it's better. I'm just erase my history. And I passed the jungle test. It wasn't that hard, to be honest. After all that studying. If I have time, which I probably not, because there's a lot of things to study on Node.js. But if I do have time, I'm gonna study Redis and then Bash scripting, which I also haven't done the task. And seems like something useful to know, because eventually I'm probably gonna use Linux at some point. And then Spark. One of the concerns I have with the chain data stuff and trying to go that route is that I'm choosing a too complicated path in the beginning because I don't know how hard it's gonna be to use that data to make money. So that's one of the reasons why I'm thinking about this other approach, which it seems that it might be a lot easier because I know that there are a lot of people that are not that smart and don't have a lot of information and make a lot of money. And the only thing that they do is work really hard, which I also do. So I might be overcomplicating things by focusing only on the chain data stuff, but it's always a question in my mind because I know in order to build anything of value, you need to think long term and build something, focus on one thing and build something. But it might be too difficult in the beginning to make money from chain data. So that's the reason why I'm thinking about doing this other stuff with affiliate marketing, because maybe that way I can work on freelancing or something like that, get the money, invest on paid advertising, and then create funnels for products of other people and try to make money that way. Because I don't need a lot of money in the beginning. And then once I have that something going on, then I can just combine both this stuff that I do with chain data. And that way I just have more and more data. And I think everything is related to the end, to the long-term vision, which is to use the data to create machine learning models of social structures and trying to find the closest approximation of the Nash equilibrium over the distribution of power across life in general, so that we maximize our probability of surviving in relationship to the growth of exponential tech, which gives exponential power, which is likely to corrupt the social structure because it lacks balance between expansion and contraction. So everything is related with data and analysis on that data. So yeah. So I think the best approach is try to figure out a way to combine, always try to combine both opposites of perspectives, and as many opposites you can incorporate into something, the higher the chances that the system is gonna be good. And that's the reason, uh, the challenge also why I'm constantly rethinking what I'm gonna do, if I'm gonna pursue this path or the other paths, because it's never really clear. And I think, yeah, a combination of both of these things is gonna be good, to maximize short-term and mid-term probability of making money. So I don't have to find a job, and I can focus 100% on the machine learning thing. So, but at the same time, I have to work on the other stuff, because I think that definitely has the highest potential, but it's a lot harder to do, the chain data stuff. So I'm not sure right now what path I'm gonna go with. I, actually, I'm thinking about doing both, but I'm not sure the proportions yet, and it's something that I'm debating constantly with myself. I think this is a very big topic, so I'm gonna jump to I think I'm gonna erase this as well. It's not really clear. I probably wrote this down fast because I was doing the challenge, the tests. So I'm gonna study this later after I do a couple of them. Try to get the ones that are easier out of the way first. I'm gonna just write this down because it's probably not worth it to spend a bunch of time on this. Even if I fail the test, I don't really care about this that much. I think if I ever need this, I'm gonna figure out in the moment when the moment comes. This is probably not that important. Oh, I
For
forgot
beginners.
to
I'll give a link to the full
put
playlist
the
in the description
volume
below.
on
Today
the
we're going to look at the
videos.
file system Common Core module for Node.js. It allows us to create, read, update, and delete files and work with directories on the server. And that's because Node.js is a JavaScript runtime that actually runs on the server instead of in the browser. Now I'm going to click docs at nodejs.org because nodejs.org is the source of truth for information about Node, much like MDN would be the source of truth for information about vanilla JavaScript, as well as HTML and CSS. Currently, the stable version that I have installed is 14.17.5. As you view this tutorial, the versions that are stable may change. So go ahead and click on whichever version you have. And now you can see we have Node.js documentation. Today we're looking at the file system module, so I can click that right here. And there are many things you can do with the file system with directories and different files. So amongst all of those things, what I usually do is press Control F. I'm on Windows, and then I type what I'm looking for. And we're going to start out by reading files. So when I type read file, I can see the fs.read file, and it shows the structure here for what I want to call. And then you can click it and get details about that. I just wanted to show you how to find the different documentation on Node.js. And now let's get started in Visual Studio Code as we work with the FS, the file system Common Core module. I've got Visual Studio Code open with an empty index.js file. I've also got a files directory here in the file tree, and you can see a couple of starter text files, a lorem text file that has a lot of text in it, and a starter text file that just says, hi, my name is Dave. We're going to start by importing the FS Common Core module here, and we use CommonJS imports for that, and so it's just require FS. After that, let's go ahead and read that starter file. So we need to specify the file, and it's in files, and then it's at starter.text. From there, we have a callback function that has error and data that we read, and so we'll say if error, we need to throw the error, and otherwise, let's log the data to the console. Now, if you remember, the console in Node.js is in the terminal, so I'm going to press Control and backtick to open a terminal window. We can also do that from the terminal menu. Now, here to run our little node file in index, we just type node and then index. We don't need the JS. And let's go ahead and take a look at this data from starter. And notice after we read the data, it's presented as buffer data. So that's what we get right here. If we want to be able to read the data, we can put a toString method afterwards. I'll save, and I'll go ahead and call this again. And now we can see, hi, my name is Dave in the console. But instead of toString, we can also put in a parameter here that says the encoding, or defines the encoding. So we'll say UTF-8 before the callback as a parameter. And now let's go ahead and run it again, node index in the terminal. And once again, we get, hi, my name is Dave. Now notice the throw error here. According to the node documentation, if we get an uncaught exception, we need to go ahead and catch that. And I'm just going to paste this in. If we have an uncaught error, we should exit. So we listen for this uncaught exception using process. Now process is one of those values that Node has available to us. We don't need to import it. It's already there. So we're listening for an uncaught exception. Then we pass in the error to the callback here, and we're just logging the console error. There was an uncaught error, and then we put the error there. And then we exit the application. And this is direct from the node documentation. So let's go ahead and throw an error on purpose. I'll just look for a file to read that doesn't exist named hello. And once again, we'll call node index. And you can see we get an uncaught error. And here it is. There's no such file or directory. Now let's change this back to starter so we can keep reading the data that exists. And I'm going to put a console log statement underneath. And this is to demonstrate that read file and node in general, the functions or methods you'll find from Node, will be asynchronous. And so we're logging the data here, but we're also logging hello here. And Node has the ability to say, I'm going to process this, but let's go ahead and tackle the rest of the tasks in the program. And when I finish reading the file, I'll get that data to you. If you're familiar with async await, this should be a familiar concept. But let's go ahead and save this, and let's see which we get in the console first, hello or the data. And we get hello, and then we get, hi, my name is Dave. So Node said it would read the file, but it went ahead and processed this console log statement, and it actually was logged to the console first. And then when Node completed reading the file, it logged the data to the console. Instead of hard coding the path like we see here in read file, there is a better way. And let's pull in the path module to do that. So we have path, and then we use require, and we're requiring path. And the reason is the slashes sometimes, if you're familiar with different operating systems, sometimes backwards, sometimes forward, there can be some problems, not always, but there can be when you hard code file paths like that. But if we use the path module, we can eliminate this problem. So let's use path.join. I typed in JSON, there we go, join. And then we need to specify first the directory name. And that's 2 underscores first. And remember, that's a value that's always available to us in Node. After the directory name, we'll say the files directory to attach on to concatenate to that directory name. And then we need to say the actual name of the file itself. So now we've got starter text. So if we supply this instead of hard coding a file name, it's a much better approach. Let's go ahead and save and run this one more time. And everything still works as it did. And now we know how to read files and catch an error. Let's go ahead and copy the read file. And underneath this console log statement, I'll paste this in and we will write a file. But it's just a little different. I can change just a little bit of the copy and paste. So instead of read file, we've got write file. And this path here will change the file name because we're going to write a new file. This will be reply.txt. Now we don't have to specify the UTF-8. That is by default now. We will have a callback, and the callback will only have an error. We're not reading data, we're writing it. So if we have an error, we'll throw the error in here. Instead of data, we can just say operation complete, or more specifically, let's say write complete. And we can save this, and now let's go ahead and run this code. And we got an error. Oh, and that's because I forgot to specify exactly what we're writing to the file. I'll just say, nice to meet you. And then we have our callback. Had things out of order. So again, path name, content we're going to put in the file, and then the callback. With that saved, let's run it. And there we go. We've got hello, hi, my name is Dave, and then the write is complete. Let's look at the reply file we created, and it says nice to meet you. I'm going to copy all of this write file operation down one, and then we can change it to append file, which is updating a file, adding more content to it. We'll go ahead and create a different file here, and that is to show you that append file. We'll go ahead and create a file as well if it doesn't exist. So let's just call this test, and we'll say testing text or something like that here. And other than that, it is basically the same syntax as write. We'll save this and go ahead and run the code again. And we got write complete and append complete. And then notice, due to the asynchronous fashion of Node.js, the read completed last this time, and we have hi, my name is Dave after the other operations completed. In the file tree, we now have our test file as well, and it has the testing text in it. So append file, worth noting that it will modify an existing file and can append content to it, but it will create a file if it doesn't exist. So due to the asynchronous nature of Node.js and these different methods we're calling here from read file, write file, and append file, if we wanted to modify the file that we created, such as reply, it would be better to put append file, I'm going to cut this, and put it inside of the callback of the write file operation. That way, it would definitely create the file, and then we would be ready to append to it, instead of wondering if we would possibly create the file first with append, and then write over it with write file. So here, let's change this to reply.text that says nice to meet you. Let's give a couple of line breaks, and then say, yes, it is. And if we save that, I'll go ahead and delete the test that we're no longer using, and our reply, because we will create it once again. So we've got reply, and then we will modify reply with append, and it's inside of the callback of write file. Call node index in the terminal, hello, write complete, and then we got the read operation completed, and then the append completed. So if we look at reply now, it says nice to meet you, and yes, it is, in the order we expected. Now, as you might imagine, if we wanted to do something to this file after we added more content, and we wanted to make sure it happened in the order it needed to, such as renaming the file, then that would need to be in the callback of the append file. I'm going to go ahead and copy append file, and then inside of the callback, I'm going to paste it and change this append here to rename. So we can rename the file, and we're grabbing the reply file, and then we're going to replace this parameter with what we're going to name it, and we'll just call this new reply. And then, of course, it has a callback with an error as well, and then we can put rename complete. Now let's go ahead and call all of this in the terminal with node index. And it does happen in the order we expect. We got write, append, and rename. And you can see this time the read operation completed before the others. Once again, asynchronous. So we don't know which will happen before the next. But in this way, we're controlling it because we're putting the append inside the callback of the write, and we're putting the rename inside the callback of the append. Let's go ahead and look at our new reply. And it does have the content we expected. Now, if you work with JavaScript for a while at this point, you would be saying, yes, this is nice, Dave, but this is starting to look like what is called callback hell. And yes, it is, because we're putting one inside the next, and they're all inside the callbacks of the other. So we are controlling the flow, but at the same time, we're able to avoid this in vanilla JavaScript using async await. And now we can look at how to avoid it in Node by doing the same. I'm going to comment all of this code out. And up here, we can get rid of the console log hello as well. And then at the top, where we have fs, we'll switch this to fs promises, and let's attach .promises to our import here. So we are now importing the file system promises instead of just fs. Now I'm going to create a function. I'm going to call it file ops for file operations. This will be an async function. And then inside this function, we can use try catch. So here we'll have our catch for any errors. And now inside here, I'll just say console.error and pass in the error. Or we could throw the error, but that's actually what's happening here. And we're catching them, so it will not be an uncaught error. And then inside the try block, I'm going to define data and set that equal to before that, await fs promises dot read file. And now we need to specify our file path. And that's what we have here. Part of why I saved that, so I can just copy it up. And I'm going to hide the file tree momentarily so we can see a little more. After that, we can still specify UTF-8. And then we don't need the callback here that has the error in the data because we're using await and we're catching the error down here. So this should be just fine now. Now once we have the data, let's go ahead and log the data once again. And I didn't remember my semicolon after that, being a little inconsistent. Okay, so we have file ops. I'll delete the read file operation. And now here, we're just going to call file ops into action. We'll have node index in the terminal. Oh, and I didn't save the file yet. There, I'll save the file. Hopefully we don't have unexpected results now. And node index in the terminal. And we got hi, my name is Dave, the data that we expected to get. Let's add another await in this process of file operations. Let's say await fs promises. And now we will write a file. And this file is going to be promise write. So we'll have the same type of path once again, which I can just copy and paste. But we'll just call this promise write. And after that, we want to pass in the data that we just read. And now I'm going to copy down once again. And after we write a file, let's go ahead and append to the file. And now in the append area, we'll just say, nice to meet you. Well, let's put a couple of line breaks here with backslash lowercase n, so 2 line breaks. And one more copy down. And now let's rename. And we're renaming promise write, so we'll just copy this once again. And instead of content now, we need to put the new name of the file, and this will be promise complete. And we can save that. So you can see we're taking the data from the starter, then we're writing a new file called promise write, then we're appending to the file, and then we are renaming the file. And finally, let's go ahead and copy these 2 lines once again and put them right here. And now we'll call this new data. And here we want to read the new file, which is promise complete. And then we'll go ahead and log that data as well. So you can see there's several different operations happening here. We are reading data from a file, then we're writing it to a new file, then we're appending to that new file, then we're renaming that new file, then we're reading the new file and logging the data from that file. So I hope that's not confusing. I just wanted to show all the operations that we have gone over and then use them in an async await fashion. So here's node index. And here was the original content. Hi, my name is Dave. But then the new file has hi, my name is Dave and nice to meet you. And let's go ahead and look at the file tree. There it is. And we've got promise complete right here that has hi, my name is Dave. Nice to meet you. Let's go back to the index and let's add one more thing right here. I'm just going to copy this one line and above it, I'll paste it again. And here, instead of write file, I'm going to say unlink. And after that, we don't even need to pass in data because unlink is actually a delete. So we can delete this original file that is called starter text. There it is. And now that we have it being deleted, and I can get rid of the space here as well. So we're reading the file, logging the data to the console, and then deleting that file, then creating a new file. And we can get rid of promise complete here again. And we'll get rid of the reply. We're not using that anymore. And let's make sure we save the index and we'll call it into action. Once again, we got the same in the console, and we have promise complete over here, but no more starter text. It's gone because we deleted it with the unlink right here. And this is also available without fs promises, as the first examples I showed, that were just fs and then read file, write file, and so on. Unlink is what you would use to delete a file. Okay, now I'm going to create a new file over here, and I'm just going to call this stream.js. And if we have larger files, sometimes it is good to not grab all of the data at once. It could be too much, just like moving a large pile of sand bucket by bucket, or moving all the water in a swimming pool bucket by bucket, rather than attempting to grab everything all at once. So this could be more efficient and a little bit easier on the application if we do this. So let's say const fs, and once again, let's require fs, not fs promises, just fs. And here, I'm going to define rs, and we're going to set this equal to fs.create read stream. From here, I'm going to specify our files / lorem.txt. Once again, you could use the path module, would probably be a better option. I'm just doing this quickly, so I'm hard coding that in. And now putting in the encoding, and this is UTF-8 once again. So we created a readable stream and we specified the encoding in the options. Now let's go ahead and specify a writable stream. This is going to be ws.create write stream. And now what do we want to write this to would be the question. So let's call this from stream. Let's call it new-lorem because it's our lorem text, so that works. So we have new lorem. And really, we don't need to specify anything else here. We already specified what was being read is UTF-8, so we're good there. And I did make a mistake here. I need to make this fs, not ws, because this is getting this from the fs module, the create write stream. That's why it didn't help me out when I was typing it. Okay, so once we have that, we need to listen for the data coming in from the stream. So here's our readable stream. We can say on. Now we're listening for the data that's coming in. And here, let's say this is a chunk of data, or a data chunk, if you will. And inside here, we could console log the chunk, or we could just write to our writable stream and pass in that data chunk. So let's do that, and I will save. And now let's go ahead and run this. So we'll type node stream. And notice now we have new lorem as well, and this will be a large file of lorem, probably about 1,000 lines. Yes, so it did it very rapidly, but once again, an example of a large file, just a test example. It could have much larger files, but in that case, when you're working with a large file, this is much more efficient. Now, speaking of efficiency, I'll go ahead and comment this out. There's even a better way to do this. Instead of the listener, just take the readable stream and use pipe, and then you can pass it to the writable stream. This will accomplish the same thing, and piping is more efficient than the stretcher with the listener here. I'm going to save this, I'm going to delete the new lorem file, and now let's go ahead and run our stream once again by typing node stream in the terminal. And you can see we once again got our new lorem text file, and it has all 1,000 lines of lorem text. Okay, I'm going to create one more new file in the file tree and call this dir.js, which is short for directory. Once again, let's go ahead and define fs at the top and require it. And after we do that, what I want to do is create a directory with fs.mkdir, which stands for make directory. And we'll have, let's just call it new. We're specifying what we want to call it right here. And then there's a callback that has an error. And this is the same as we've seen previously. So if error, we can throw error. Now I won't go ahead and copy and paste the uncaught error handling code in here that I showed you earlier just to save time. You can use it the same way. So if we have an error, throw an error. And if not, we create a new directory. So we'll just log directory create. And we can save this. Let's go ahead and run our code. So here we'll type node.dir, which is our new file, dir. And directory is created. And now we can see here is our new directory. Now earlier in the tutorial, we threw an error on purpose because we attempted to read a file that did not exist. Well, we can check to see if files and directories exist or not, so we don't get those errors. And we also might want to check in this regard to say if the directory already exists, let's not create it because we don't want to write over what we already have. So we can use the exists sync method. And let's start out with if, and then we'll say if it does not, and not would be the exclamation mark, fs.exists is exists, yes, it exists, sync, and then we'll say the same folder slash or the same directory, /new. So if it does not exist, then go ahead and do what's inside of the if statement. And we'll put that right there. So we can close that out and close this out and save. And now let's see if we create the directory when we run it in the terminal. And no directory was created because it exists. So this says if it does not exist, create it. So let's go ahead and delete the directory. And now let's run this once again. And now create the directory again because it did not exist. You might find checking for file existence fairly useful before you attempt to delete a file if it exists or not, or before you attempt to even rename a file or copy a file. Several things that you want to make sure the file exists. Likewise, you can check directories in this regard. Now let's go ahead and write some code that deletes the new directory. Okay, let's copy this down, highlight everything, and bring it down here to line 10. And now let's check to say if it does exist. And this is the folder. We're going to remove the directory, and that is rmdir for remove directory. So this would be a zero-sum game here. If it does not exist, create it. And if it does exist, remove it. So now let's say directory remove, and we'll be able to tell by the console, but in the file tree, we should not have a directory when these operations are complete. And the directory was removed. It already existed, so it wasn't created, but it was removed. Let's go ahead and run it again. And now it's created and removed. And so it's still not in our file tree, but we can see both operations completed. Hey, thank you so much for giving this video a like if it helped you get started with Node.js. Also, thank you for watching and subscribing. Could you help me my channel? Uploading files to a Node.js REST API can be very useful, and the Express file upload package has nearly 1 million downloads per month. However, when I check the documentation for multi-file upload support, it suggests that I create one HTML input on my page for each file that I wish to upload at the same time. Well, I've made a few changes, and for the Node.js file uploader that we create today, you'll be able to use only one input to select multiple files. And after we select those, I'll click submit, and we have a success message, and you can see the files have now been uploaded to our Node.js server. Hello and welcome. I'm Dave. We'll be learning how to upload files to a Node.js REST API server. I'll provide links to example source code and all resources in the description below. This is not a beginner Node.js tutorial, so just a reminder before we get started that this is more of an intermediate to advanced level tutorial. You'll surely understand more of what I do in this tutorial if you completed my Node.js course for beginners first. Okay, I've got VS Code open and we're starting with an np project folder. I've already got the terminal window open as well, and I'm going to assume you have both Node and npm already installed, as I'm also assuming you're not a beginner. So now I'm going to type npm init to start our project, and then press -y. So it won't ask us all those questions in the beginning. And then after that, we need to install a couple of dependencies. So npm I, and then express, and then a space, and then express -file upload. I almost typed download. And we'll get both of those dependencies installed, and that was quick. Now we want one dev dependency also. So I'm going to type npm I and then nodemon, as nodemon will restart our app anytime we save changes to it. And so then -D, so it's installed as a dev dependency. And now it's already installed too. So let's close the terminal window and look at our package.json. Under dev dependencies we see nodemon, and then under dependencies we see express and express-file upload. Now up here we have the name of our project, which is node file uploader, and then it has tut after it, so that is just because that's what I named the folder. That's short for tutorial. I'm going to change the main value here from index.js to app.js. So inside of the script's curly braces, let's put start and a colon, and then we'll have node space app.js and a comma. But after that, we'll also put a value for dev, and here we'll use nodemon app.js and a comma there as well. And then we're finished with our package.json. Let's go over to the file tree now and create a new file, and we'll name this app.js. Now I'm just going to paste in some code and we'll go over it. But this is basic code that you should have when you start basically any server, except for the file upload that we're using specifically today. So we are importing in express here, which requires express. Then we're importing in the express-file upload middleware and naming it file upload. Then we're also importing the path module from node, and that's just require path. After that, we're defining our port, so we use process.env.port or 3500. So we'll be running this on localhost 3500 today. Then we're setting our app equal to express, and then what's usually at the bottom of our file is on line 9 here, and I can give it some space, but it's app.listen, and then we provide the port value, and then the callback function right here is just logging server running on port and listing that port. So we could start our server right now. It wouldn't do anything, but it would say it is running on port 3500. Now just underneath the app that we defined, so I'll put this on line 9, we're going to define a route for our index.html, basically the default web route here at the slash or the root of our application. And it gets the request and response. We don't need to send a next into it. And then we're just going to send the file, and we're using the path module here called path.join, choosing the directory name, and that's a value that is found in Node, and I do go over that in my course for beginners. And then you've got the index.html, which is the default page. So that's what we're going to need to create next. So back to the file tree, let's create a new file, and we'll name this index.html. Now I can type an exclamation mark for the end abbreviation and get a basic outline of the page already. Now we can just put our title in here, which would be node.js file uploader. And after that, inside of the head, I'm going to paste some CSS that I've already made, and we're not going to use separate files. I'm just going to stick all this inside the HTML file. There's not a lot of CSS though. After that, we can create the body of our page. I'll put an H1, and inside the H1, we'll just put the title once again, node.js file uploader. I should mention, of course, these resources will be available in the description, so if you specifically want to use the CSS I put in here, which is not much, you can either pause the screen now, or of course access that repository and get the CSS from there. But I'm not going to go over each line of the CSS. Okay, after that, we have a form, and the form does have an action attribute instantly, but we don't need the action attribute today. We're just going to use an ID equal to upload form, and then we need to set the encryption type. It says here, or ENC type. I think that's encryption, but I have to look that up to confirm that suspicion actually. But we want multi-part -form data, and then inside the form, we're going to put our input. Yeah, in there, not input. The type is going to equal file, and after that, we'll give this an ID and set it equal to my files. And then after that, we want to use this for images today. So I'm going to say accept equals, and then we'll put image slash and an asterisk. And this, as far as on Windows, which I'm on, is when you open up the window of the browser files, it's only going to show you this type of file first. You can manually change that once you have that window pop up, but it's going to only display the image files, which should help somebody out that wants to upload images. And then we put in the multiple attribute here. And it doesn't have an equals value, we just say multiple, and then we can close out the input. After that, let's just put a button, and let's say the button says submit. We can save that much, but I want to put an H2 and an H3 afterwards that we can write some data to. So we'll just leave those empty for now, an H2 and an H3 there. After that, now this is just going to be vanilla JavaScript. I'll just put a script tag, and we'll put our vanilla JavaScript right inside the script tag. And I just want to do this vanilla JavaScript, have this all in one repository, so it's all in index.html file because our focus is on the Node.js code today. However, in the future, if you want me to make a React front-end form to upload images with the backend we're creating today, I can do that as well. So let me know in the comments. Here, let's just define our form and set this equal to document.get element by ID, and here we can choose our upload form. After we do that, let's define a function called send files. Now this will be an async function because we're going to use fetch here in vanilla JavaScript. And now inside this function, I'm going to scroll so we have some more room. Inside the function, we're going to get an object, and this object we'll define it as my files. We'll set this equal to document.get element by ID once again, and this will be the ID my files. So that's the input itself. And then afterwards we say .files. And now we'll have an object that has all the files that the user has selected. Now we need to define our form data. So we'll say form data equals new form data. And after we create the form data, we need to bind or append the file data that we selected to the form before we send it, because the express file upload package expects to get that in form data. So what we'll use here is object.keys. We'll pass in my files, which remember is the files we're getting from the input, and it is an object. So we'll say for each, and we'll have a key. So for each key, we'll take the form data, and we'll call append, and we'll have my files, and we'll say .item, and we'll take the key, and then get the name. So this will end up being the key for the file as we send it to our Node.js backend. And then we'll actually send the file itself, which we refer to as my files .item. It's just the key and not the name property attached right there. So this is actually going to be the key for the file object, and this is the object itself right here. So now that we have looped through that, we're ready to send this to the Node.js backend. So we'll create a response, set this equal to await fetch. Now this will be the backend here for our dev environment. So it's http://localhost port 3500, and we're going to create an upload endpoint. And after that, we need to put in config object for fetch. So this method will be post, and after that, we'll have a body, and it will be the form data we created. We're going to scroll for some more room again, but we know after fetch, we're not using Axios here, so now we actually need to get the JSON from that response. So let's just say const JSON equals, and we await response.json. Now from here, we can just log this to the console, so I'll do that. But let's go ahead and put this on the page where we have this empty H2 and H3 also. So I'll scroll back down. Now I'm just going to paste this in quickly. So what we've got is the H2, we're selecting that with our cursor selected, and we're setting the text content of the H2 to status, and it's showing the status property from the JSON that we have. And likewise, we're doing this for the message with the H3. So now we created our send files function, but we still need to call it. So I'll scroll just a little more, and underneath that, we need to listen for the form submission. So we'll say form.add.listener, we're looking for the submit event, and there's the event. And now inside this, first thing we're going to do is event.prevent default, so it doesn't reload the page, and then we'll call our send files function and save. And now we're finished with this file. And as I complete this vanilla JavaScript, which I've been working with React for a while, some of the things that we take for granted in React make it so much easier at times than vanilla JavaScript. But this shows how to do this. And of course, I could could make this into a React front-end project in the future. We're now ready to go back to our app.js. So now inside app.js, we need to create our upload route. So this will be app.post, and now we'll look for /upload, and after that we'll put a comma, and this is where we put nowhere, and we do have some nowhere, and that is the file upload nowhere. Of course, you could put app.use up here and use it on all routes, but we don't really use the file upload nowhere on all routes. So let's just use it on our upload route, which makes sense. And we can pass options in here. Unfortunately, many of the options that come with express file upload are just for those single files or one at a time, as it showed using more than one input. And so I found that some of the things like the file size limit and things like that only apply to the first file when you do it with one input. So we're going to create our own nowhere handle some of that today too. But here we'll put create parent path and set this to true. After that, we can put a comma and add some more nowhere if we want to. But after we get through all that, let's get the post down here. So I'm on the right line for everything because this is where it actually ends the post. After all that, I need to put a comma. You know where we're at, and now we call our function here. So we have request and response. And at this point, let's just get the files. So we'll define files. We can set that equal to request.files because that's where they'll come from. We're using this file upload nowhere. Let's just say console log, and we'll log the files. And we could get a response as well. So let's just return a simple response here. We'll say res.json, and we're expecting a status and a message. So status right now we'll just say log, and then for a message we'll also say log. And we can say this. And before we add any more, we're ready to go ahead and at least try out the server and see if our front end is working or if we have any errors there right now before we add the extra nowhere and before we actually write the files to the server. So remember, this console log will actually show in the NodeJS console and not in the browser console. So control and backtick. Now let's type npm run dev to start our application with node on, and now it's running. We can close this again if we want to, or we can open it back up so we see that console log statement. So let's drag this over and all down shift so it logs to that window. And we've got our front end page right here. So I'm going to choose a file, and I've got a couple of image files here. I can choose one or even two or however many I want to, and we'll see if they log when we submit the files. And they sure did. So look, we're looking at the actual object here that Node receives, and it's already been processed, of course, by that express file upload nowhere. So here's the key, which is the name of the file as well, and it has a name property. It has some data there also. We have the size, encoding, temp file path, a truncated value, an MD5 value, and a move function, which we will use. So the express file upload nowhere does a couple things we really like. It gives us that move function. It handles creating the file folder when we need to, and that's the option we put in, although we're not writing it yet, so it's not doing it. And it's overall just handling these files and putting them in request.files property as well, just like we need to. So it's still worth using. We're just going to change some of those options because it doesn't support those when we use only one input. Okay, let's drag this code back over to full screen. We're going to need all that, and let's create a new directory over here, and we'll call this nowhere. Now inside the nowhere folder, let's create a file. We'll call this files payload exists.js. And what we're doing is taking some logic that you may see in an example all in one big function. We're extracting some of this from, say, a big function like we would have here in the upload route, because we could use this on more than one route in the future. Say we had a separate route that was going to upload PDF files or Excel files for work or whatever is needed. We would want to just write this once instead of write it for every single route. So with this nowhere, now we'll say const files payload exists and set this equal to what you expect request, response, and next. And then inside the function, we're just going to say if there are no files, essentially which is request.files, we're using that exclamation mark to say the opposite of that. Then we're going to return, we'll say res status 400, which is a bad request. And then we can put our value here inside the JSON. I'm going to press Control B real quick, I have the file tree for just a little more room. And then inside the JSON, we'll have a status, and here we'll set that to an error, and then we'll have a message, and here we'll say missing files. So that's all this nowhere is really going to do. It's going to see if we have supplied the files or not. And if we don't see any files, it's going to send an error. Otherwise, we'll call next and move on to the next nowhere. After that, we need to remember to go ahead and do module.exports and set this equal to our files payload exists at the bottom. And we're finished with our first nowhere. Okay, let's go back to the file tree and create a second nowhere. This is going to be called file, not files, just file size limiter.js. At the top of file size limiter, we're going to find a couple of constants. I'm going to create this one called MB and set it equal to 5, which is going to represent, okay, so I'm going there actually. This is going to represent 5 megabytes. And that's going to be our file size limit. Let's now find file underscore size underscore limit. I'm using all caps on these because I'm going to refer to them as actual constants. Here, this will use that megabyte value, and then we get times 1024 times 1024, and that will create that 5 megabyte number, and we want files to be any larger than that. Okay, now we can start the function itself. So we'll say const file size limiter equals function with request, response, and next, as a good nowhere function should. And then we'll find files with const files, and we'll set that equal to the request not files. After we get that, let's define a empty array, so files over limit, and this will hold the names of any files that go over the limit we have set. So now we need to determine which files are over the limit. And once again, use object.keys. We'll pass in the files. We'll say for each key. And now inside the function, we can say if files, and we'll refer to the key, and then we can get the size property that we have. So if that is greater than our file underscore size limit, then we want to issue the response, or at least we're not issuing the response yet, we're actually just showing the name of the file that's over the limit, so we can report all files that are over the limit. So this files over limit dot push, and then we need to pass in files and the key, and then we'll say dot name. So we get an array that has all the names of the files that are over the limit. And now we can send our response if files over limit has links. So if the array has any items in it, this is where we'll send a response. And underneath that, we would call next. And just so I don't forget, underneath all of this, we still need to have our module.exports and set this equal to file size limiter. Okay, so inside of this if now, I'm going to paste in some things that I'm just probably too picky about. I'm trying to have good grammar inside of my error message essentially. So I'm creating an error message here, and this is sometimes the perfectionism that I fight in my own life, I guess. But what I'm going to do is know whether I should use the word are or is inside the sentence. And so I'm saying upload failed, and then we're passing in the array and setting it to a string. So if we have one or more file names here, and if it has more than one, we're going to use are. If it only has one, we use the verb is. After that, we also have the value of the constant above, saying how many megabytes. And then we're using replace all because if there is a list of files, then we're having spaces between them without commas, so I'm replacing a comma with a comma space. After all of that, then I realized that okay, maybe there's a comma and we need word and then of course if there's a list of 3 or more, I need to keep some of the commas. So this just grabs the last comma with this regex, so it's word and. So that's probably me just being too picky. But after all that, we just need to return our response, and that response goes right here at the bottom. So I'll have one extra line, and we save it to get a 49. But there we go. We're returning a status 413 that says the file or a file is too big, and then we have the status is an error, and we just need to pass in the message since we've got a message variable and a message property. We don't need to say message, we just put in a message once, and we'll pass that in. Back to the file tree, we have one more nowhere to create, and this is going to be file ext limiter. So it's file extension limiter.js. Now this one is just a little different because it will receive a parameter, and we did this with a verify roles nowhere in my Node.js course as well. So this is constructed just a little different because of that parameter. So first let's bring in the path module, say require and get path. After that, we'll start defining a function. It's file ext limiter, and this is going to equal a function that receives an allowed ext array, so an allowed extension array. And now inside this function, which will be called immediately when the Node.js app loads, it will return a function to be called in the path, which is nowhere. So that's request, response, and next. And then inside this function, we can refer to that allowed external array that is passed in, and that is closure. That is this file extension limiter will have executed and already closed, but the function that it returns will still have access to this allowed extension array that is passed in above. It's in the lexical scope of this function. Okay, so inside here, we need to once again get the files first. So we'll say const files is going to equal request.files. After we do that, let's define another empty array, and we'll call this one file extensions and set this equal to an empty array. Now we use object.keys again, pass in files for each, and this is for each key. Here we'll say file extensions.push. I'll back this up to push directly. Now we'll say path.ext name, so we get the extensions from each file, and then we'll have files, and of course key, and then .name. So we're grabbing the extension from each of the files inside that file object. So now we'll have an array of the file extensions. After this, we need to determine if the file extensions are allowed. So let's say are the file extensions allowed. Let's define a variable called allowed, and here we'll compare the arrays. So we have the file extension array versus the allowed extension array. So we'll use file extensions.every. So we want every one of these to be true as a result. We'll pass the extension, and now we'll say allowed ext array. There we go. Includes, and this would be the extension itself. Okay, after that, we'll know we'll either have a true or false. Either they're all going to be true or it will be false with the every here we're calling on the array. So after that, we can say if it is not allowed, then we're going to send a response, and otherwise, of course, we're going to call next. Once again, while I'm here, I need to add that module exports at the bottom. So module.exports, and I'm in the wrong place. It needs to be after that code array. So here we go. Module.exports equals file ext limiter. There we go. We can get the space between those two, and now we just need to handle our response here. And this response is going to go right here inside if not allowed, and here I can press Alt Z to get this code to wrap so we can see a little better. So our message now is once again upload failed. We're passing in the allowed extension array to string, so it tells the user what extensions were allowed. Only those are allowed, and I'm doing a replace here with commas again as well. And this is a 422, so it will be a little different, and we'll test out that error message as well. Let's save this file and jump back to the app.js. Okay, I scroll up to the top, and now just underneath where we import the path, we're going to paste this in so we see all 3. But what we've got here is an import of our files payload exists, and we're requiring one in the nowhere folder and getting that nowhere. We're doing that for each one of these nowhere that we created, and now we can put them below inside of the route here for our app.post, our upload route. So after the file upload, and before this function that we have at the very end of the route, we want to put these other nowhere. So we have files payload exists and a comma. Now the next one is the file extension limiter, and here this needs to receive that array that has the files extensions we will accept. accept. So we want .png, and then we'll also accept .jpg, and we'll also accept .jpeg. Sometimes JPEG files have that extension, so we'll accept any of those. So notice this has parentheses here. It's a function that is being called immediately, but remember, it returns a function, and then that function that it returns is the middleware that was set in the route. Okay, the final one is the file size limiter, and we'll put a comma after it because it does not receive any parameters. So now we've got all of our middleware added to the upload route. Let's save our app file. I'll quickly press Control in the backtick to make sure that we're still running. And yes, we're still running here on port 3500. You can see node mon restarts after each change. So I'll go ahead and close this out. Let's drag this over to the left again, and I'll reload this. So now let's check out our error messages. The first one would be for the files payload exists. So if we don't submit any files, we get an error, and we're missing files. So that works. Now the extension limiter. So now let's choose files again. Notice, let me drag this over where you can see all of it. Notice that this might be really small, but it's only suggesting image files right now. But I can change this and choose all files, and I have a mislabeled PNG here that is .pnk. So I'm going to select that and submit. And now it says upload failed. Only PNG, JPG, and JPEG files are allowed. So that middleware is also working. Now let's try the file size limiter. So I'll open this back up. I chose Galaxy here. You can get any of these images from Unsplash, is where I got some of these space images. Ones with stars always seem to be larger than others, at least I've noticed. So if I submit Galaxy, it says upload failed, Galaxy JPEG is over the file size limit of 5 megs. Now let's see this with more than one. Let's select all three of these and see if that message effort we put in pays off. So now we have upload fails, Galaxy JPEG, comma, space, Starforce JPEG, and stars JPEG over the file. So that extra code in there for the grammar is working out okay. So everything's working with our middleware. So the next thing we need to do is just write the files to our server. I'm going to drag Visual Studio Code back over to the full screen, and now we're ready to write the files right here underneath where we're logging the files to the Node console. I think I'll scroll for just a little more room because we'll need it. So I once again use object.keys, and we'll pass in the files, and I will say for each key, and inside we'll have our function. The first thing we'll do here is define the file path. So const file path is going to equal path.join, and then we get that directory name variable from Node. We're going to have the files directory where we store our different image files. We can name images if we want to, but we're going to files for the example. Then we'll get the files.key, or not .key, bracket key, .name. There we go. So that will be the full path. So this will have the directory path, the folder, and the file name. Now that we define our file path, we can call the files, whichever file it is, files, and then key in brackets. And now, remember, our middleware express-file upload has attached a function we can call, and it is the mv function. And we just pass in the file path, and then if there's an error, we can handle that here. And at this point, we won't do much. We'll just say if error return, and now let's go ahead and get a status of 500, which would be a server error. We'll go ahead and attach some JSON onto that. So we can say status error, and then we'll go ahead and add the message that is expected, and we'll say, oh, we don't need close, we'll just pass in the error. Now I'm going to press Alt Z to wrap that code. It's getting just a little long, and now we already have a return statement here, but let's say something different than log. So if it reaches this point, it's going to be a success, and our message will change. So what we can do here is once again do object.keys and pass in the files, and then say to string. So it just takes that and makes a string of all the file names. So we have a success, and we get a string of all the file names that we have successfully loaded and saved. But we'll also want to watch over here because it should create a file directory if we successfully upload those files. So let's once again open the terminal and let everything is running now on port 3500. So node mon has kept it going. I'm going to drag Visual Studio Code over to the left. We'll keep our eye on the file tree as well. I'll reload this page, and now let's just choose some files. So I'll choose the two that I know will upload. They're not over the file limit. And I'm not sure you can see those on the screen. Maybe I'll drag this over and do it again. Here's the two I'm selecting. I'll click open, and now I'm going to click submit. And yes, we now have a files directory here. We've got both of the files uploaded to the server. Success. Everything's working as it should. So I hope this has helped you understand how you can add a path to your REST API, possibly the REST API created in my Node.js course. But either way, whatever Node.js REST API you have, you can now add an upload path, and you can upload the types of files that you want to. We use images as an example, but it doesn't have to be images. These can be PDFs, can be Excel files, text files, whatever types of file you want to look for. And we've extracted a lot of the logic into our own middleware, so we can reuse this on different paths that we create inside our API as well. Remember to keep striving for progress over perfection, and a little progress every day will go a very long way. Please give this video a like if it's helped you, and thank you for watching and subscribing. You're helping my channel grow. Have a great day, and let's write more code together very soon.
I think I might watch this video here as well that I was watching before about cookies, just so I can close this tab.
Hello and welcome. Hi, my name's Dave. I currently
Don't like having a lot of tabs open.
Hello, and welcome to 7 hours of Node.js tutorials and instruction. This video is made up of 15 tutorials for learning Node.js that build upon each other much like the chapters of a book. You will build projects and learn fundamentals of Node.js, the Express.js framework, and MongoDB.
Hey guys, welcome back to the series of Node.js. So in this lesson, we're going to use our very first Node core module, and that's the OS, short for operating system module, and we'll use it to find out some more information about the environment that you're using. And whilst we're looking at the environment, we'll also take another look at the process object and see some of the other things you can do with that, and a couple of other extra things that tell us the directory name and the file name of the currently running program. But to get started, we actually need to import that operating system module into one of our files. So let's create a new file and do that now. I'm just going to call this one system.js, but feel free to call it whatever you like. And to import a module, the standard way to do it is to use the require keyword. So we can write something like this, where we're creating a variable called OS and actually storing the result of the module inside it. So this will give us the ability to access any properties or calling functions that are available in the OS module. And if your text editor supports it, just by typing the variable name followed by a dot should give you all of the properties and functions that are available to you, so you can scan through these and have a look at what you can do with the OS module. So to start off, let's find out a bit more about the user that's actually running the Node.js program. And we can do that by calling a function on the OS module, which is simply use info. So if I save that script and then run it, you'll see information about the username and the home directory of the person running the same script. And there's also some additional information like the user ID and the group ID, which if you're running a Unix system, actually tell you the correct group and user ID. But because Windows doesn't have this concept of user IDs and group IDs, it's -1, so it's not massively helpful for Windows users. So let's have a look at some of the other functions that you can call on the OS module. There's another function called platform, which if I run through now, indicates I'm using a Windows operating system. And obviously you'll see something different if you're running Mac or a Linux machine. But another useful function you can call is release as well. So if we just run that now, you can see I can get the specific version of Windows I'm actually running these Node.js programs on. There's also one other fun thing you can do with the OS module, which is to find out how many CPUs that you're running on your machine. And the CPU function actually tells you about each CPU that's installed on your machine. And realistically, I've only just got one CPU that has multiple cores in here, and so it lists it out in this array and gives you some nice information about it. So then the CPUs available isn't super relevant, especially since JavaScript is single-threaded, as it only really uses one CPU at a time. But you can see that the OS module gives you some interesting information that you can make use of if you're writing a program that requires knowledge of the operating system and platform that you're using. So the key thing you should take away here is that to import a module, you simply use the require keyword and reference the name of the module in a string within those required parentheses. Okay, so before we finish the video, let's look at a couple of practical things that you might need to do with the environment you're working with. So this isn't actually part of a module. So this isn't part of a module. There are two variables available, the IR name and file name. They can tell you about where the Node.js program is running. So here you can see running the system.js program again, we get the directory name and also the file name of the program we just ran. So this is useful when you're working with paths and other files on the system, and we'll look at the next lesson when we look at the file system and path module. So one final thing about working with the environment that you're in, sometimes you want to access environment variables that are set up on your computer, and we saw that in a previous video where we looked at the env property of the process object. So here you can see all of the environment variables that are set up on the computer, but what about if we want to actually create our own environment variables that store some sensitive information? So it's common practice to store things like usernames and passwords as environment variables on the computer so that they're not stored within your codebase. So we can create new environment variables simply by saying export and then the variable name, so let's say database password, and assign some value. And this command might differ if you're using different command prompts, but certainly if you're using bash or git bash, this is the way to do it. So now if we were to run our system.js program again, scrolling through the results of process.env, you can see now we've got a database password stored in there, so we can then extract that and use it within our Node.js programs. So that should cover pretty much everything that you need to know about working with your environment and getting information about the system that you're working with. In the next lesson, we're going to look at working with files and the file system module.
Hi there. So in this video, I'm going to show you how to use Node.js operating system module. So after the end of this video, you'll be able to acquire details such as operating system value, platform, free memory, and total available memory of operating system. So make sure that you have Node installed. To check whether you have Node installed or not, simply type in Node on your command prompt. Okay, and you can exit with this. Now open the text editor, save the file with name sample.js. Once you do that, create a variable name OS and call for require OS. Okay. The second thing you should do is write console.log and then type in OS type, and then simply use /type OS.type. And this is a method, so make sure you use it that way. Next is console.log, and then we will call for platform. So we want to check which is this platform. So in case of Windows, it will be Windows NT, or it will also specify 64-bit or not. Okay. So we type in platform method. Then we have console.log, and here we type in total memory. Then we also have os.total mem method. Okay. Plus we can also call for what bytes. Okay. Now let's just check for free memory. os.free-mem. And after this, just use plus, and then call for bytes. Finally, save your program, then open command prompt, and then type in node and then name of your file. Okay, if there are any errors, then we will take a look at them. Okay, and immediately it is printing out with OS type, which is Windows NT, then platform Win32, which is not going to be accurate because I'm on Windows 7 64-bit edition, so this information is not that accurate. Then you have total memory in bytes, 4 GB is correct, free memory says 2 GB, which is fine, and that's the information I have collected using OS module. There are a few other parameters that you can throw in and get the data. So this was a short video on how to use OS module of Node.js.
This is और आज की वीडियो में बात करने वाले हैं ओएस मॉड्यूल के बारे में। ओएस मॉड्यूल नोड.js का एक इनबिल्ट मॉड्यूल है जिसकी हेल्प से आप ओएस स्पेसिफिक इन्फॉर्मेशन निकाल सकते हैं, जैसे कि सीपीयू, मेमोरी, नेटवर्क इंटरफेसेस एंड सो लेट्स गेट स्टार्ट। दिस इज द ऑफिशियल डॉक्यूमेंटेशन ऑफ ओएस मॉड्यूल ऑन node.js.org। तो जो ओएस मॉड्यूल है वो बहुत सारे कांस्टेंट और फंक्शंस प्रोवाइड करता है जिसकी हेल्प से आप ओएस स्पेसिफिक इन्फॉर्मेशन निकाल सकते हैं, जैसे आर्किटेक्चर हुआ, सीपीयू हुआ, वीएम हुआ, होम हुआ, होस्ट हुआ, प्लेटफॉर्म हुआ, नेटवर्क इंटरफेस।
Side attribute change that Chrome had done in their 80th version, and I explain how it is actually a great change, and it might actually prevent almost all cross-site request forgery attacks, and down there reference the news video that I made. However, it looks like Chrome 80 has finally been released, and people start being complaining, they're confused, website owners are confused. are confused because their website started to break, right, because of this change. So I thought I'd take a few minutes just to explain what is actually happened by actually explaining what is the same site attribute by example. So I have hosted a website and I have the source code here. So I'm going to try all the attributes starting with same site strict, same site lax, and see the behavior, and same site none, and finally a cookie without the same site attribute, which is this has been the change that Chrome has done. If you're interested, stay tuned. All right, so here guys, I have a website that I have built on Express. What this website does is there's a login post request. If you make that, I'm going to set from the server will set a cookie to your browser, and if that cookie is set, you will be able to access the image that I have set here, which is like an image. If you don't give me that cookie, you will get a 403, which is a forbidden. Let's describe this behavior. Okay, so this is the website. I called it same site.ed. It's just a free website domain that I got, and I pointed to my router, which points to port forward, which points to my Mac, which points to which points to the Express, and all that jazz. We talk about how do you do all that stuff in many videos on the channel. Check them out. Okay, so here's what I have. I have a button called login, which will send that post request. This is an HTML page, and when I do that, the cookie will be set, and the current configuration that I set will be the same site strict. So let's explain what exactly that does. So I'm gonna go ahead and log in, right? And if I log in now, I go to application. You can see that I have a cookie, it's secure, and it's a strict, same site strict. What does that mean? Well, as long as I am in the same site, .dns.net, the same website, if I refresh, as you can see, the refresh to actually retrieve the image has succeeded and gave me the image. Previously, if you notice, the image was broken because I didn't have a cookie. So that's the behavior, right? And if I go ahead and actually...
I'm going to calculate the time here to watch all these videos. It doesn't look like it's going to take too long, so I'm probably going to watch all of this, and then continue to study the Node.js stuff.
Kill that cookie, right? And I refresh again, the image is not broken. That's the image tag that I have in my HTML page. So it's referencing that actually it's the same domain. So that's not bad, right? Okay, so let's log in again. Okay, and refresh this page. Okay, now I can view the image. The strict property here doesn't apply to the same domain that I'm viewing here. But if I go to another website, which is like outside I hosted on my GitHub page, right? So I have here a web page hosted on my GitHub page, and it's an HTML page with an image tag and an URL. The image tag literally just tries to view the image, which is obviously failing because I don't have the cookie yet because I didn't refresh. But the second one actually just, when I click on it, it will navigate to the actual image. Like if you go back, you can see the source code here. You can see that this is the image, goes to the image, and this is just actually trying to display the image. All right, so if I refresh, despite me actually logging into the website, the image is broken because that is a property of the strict. And the reason is this image is broken despite me having the cookie on the same site domain is because the requests that have been made to actually bring the image has the browser decided not to send the cookies to that website. So if you don't send the cookie, obviously the web server will not recognize you. If it doesn't recognize you, you don't actually get the image. That's what's happening here. So with a strict property, browsers do not send the cookies if you're trying to visit them. And they also do not send the cookies even if you actually click on a link that goes to the same site. So if I click here, that image will be also broken. See, that's called top level navigation, where we have forbidden. That's the error. Right? If I copy that literally and just paste in another URL, that works because that's a different behavior, right? That's you actually going the same site, right? The website that you're visiting is actually the same website. Here, it's a little bit shady. You're on a website and you try to go. Obviously, that's not a very nice user experience. I'm clicking on a URL and you're not even allowing me to go to that URL with my cookies. Imagine this is Facebook. If you're on Pirate.org and there's a link to Facebook, you click the Facebook link, it will completely direct you to Facebook, and you will get your login credential, and Facebook will recognize you because the cookies were set. All right, let's try the other property, which is let's do lax this time. Okay. Obviously, we need to relog in again, right? So let's kill my cookies that I have here. Because now it says strict, right? My cookie is strict. I don't want a strict cookie. I want to kill this. Refresh. Obviously, I need to go again. And when I log in, you can see now it's lax. So what does it mean? Same behavior if I'm in the same website. You can still visit it normally, right? But if I go to this guy and I refresh, I still don't get the image because the cookies will not be sent if you're in another domain, right? Because you're requesting from another domain. If the cookie is set as lax, the browser will not send it. So that's a similar thing to the strict, right? But if you're clicking a link that actually does a top level navigation, that actually changes that thing, guess what? It works because the cookies have been sent. Actually, have been sent. And let's actually confirm that. Okay? If I click on this guy, you can see that this is the request that I made. And if I go to the cookies, we actually have sent the cookies, right? Sweet, so that's lax. Lax is a little bit relaxed, you know, right? So you can click links that completely changes the website, but you cannot retrieve strips, images, pretty much anything from a website other than the actual, that is your domain, right? If it's set as lax, okay? So that's also broken. Okay, let's try the none. The none option here, same site equal none. Well, you'll notice that's the most unsecure way, I guess, of things. Yeah, so let's clear out my cookies here, and then refresh. All right, now let's log in again, and you can see now same site is actually not. So that's the third property. So what does it mean? Well, here, same thing. Right? I'm in the same website, so it's very safe to actually send the cookies because you're literally in the same domain. You're posting image from the same domain. That's absolutely fine. Let's go to the shady website. What is that? Look at that. The image was actually loaded despite me being from another website. So what happened here is when I made the request to actually retrieve the image tag, which is actually a GIF request, right? The cookies were sent. So if the cookies were sent, that means the server recognized it. That means the server returns the actual image. So you can do it. So that is where same site equal none. You can view resources directly and make GIF requests, not just image, right? GIF requests, post requests, pretty much anything, right? Like that, okay? So you can actually make requests from that website despite you being in another domain. That's where most cross-site request forgery attacks, right? If you have like, if someone forces you to visit a website that made a GIF request or even a post request that, I don't know, transfer money from your Bank of America account, and Bank of America, you were already looking at Bank of America browser. If that cookie was set to same site equal none, the browser will actually send the cookie, and Bank of America, if they were done, they were using captcha, they will actually successfully transfer the money to anyone's account by the act of just merely visiting a page, which is extremely dangerous, right? But Bank of America, if they're banks, they don't just accept and post requests. Even if it was you, right? They make you do this two-factor authentication. Obviously, guys, if you visit the actual thing, the website will also work, right? Because we also send the cookies in that scenario. All right, the final cookie attribute, which is the actual Chrome change what they did. The absence of same site. What does it mean if the same site didn't exist? Before, prior to that, same site, if you don't have the same site attribute like this, it was treated like this, like as if what we saw, where requests will always get sent, the cookies will always be sent. Okay, but Chrome 80 changed that so that if you don't have the same site attribute, they will treat it as lax, which is the second property we talked about, where the image will not load, right? But if you click on a link, we will send the cookies. So let's actually prove that. I have Chrome 80 here. Obviously, let's build the cookies, refresh, login. You can see that we don't even have a same site property. There's nothing, right? That's what I don't like about this, right? Chrome should actually tell me that, by the way, I'm treating this as a lax, right? But they don't tell you. It's just implicit. Maybe there's a property I forgot to see. Okay, now if I log in and refresh this thing, I'm logged in, obviously. If I go to my website, refresh. Cookies will not be sent for the resource to request the image, so the image will not be visible. And you know why, right? Because it's exactly like that. Prior to Chrome 80, that image would have displayed if I don't have the same site attribute. Okay? And if I click that link, obviously this will work, as you see. Right? All right, guys, that's it for me. I want to just clarify because I got a lot of questions from you guys just to explain this thing. Because I made a lot of video about same site and cookies, and I made these news, so I started getting questions. Hey, what happened here? What should we do? So that's what happened, right? So you know what's going on now. If you're also setting cookies, make sure today, if you want that behavior, to set it as same site equal none and secure. You have to do it this way if you want scripts to execute, or if you're referencing something. Especially authentication. This is really weird with authentication, right? Things like I don't know. Yeah. So that was the answer to the same site attribute. Hope you enjoyed this video. I want to make a dedicated video because this is like a really in-demand topic now. I wanted to clarify all these ambiguous things. Hope that makes sense, guys. See you in the next one. You guys stay awesome. we are all entitled for some privacy. And if I ask the website to please delete all my cookies, I do not wish to be tracked, the website should honor that and stop tracking me. However, some media companies found ways to recreate your cookies even after you delete them, so they can keep tracking you and keep selling you ads. These are called zombie cookies. Zombie cookies are cookies that are recreated after being deleted. They are like a zombie in that regard. Can't be killed. Well, unless you stab them with a wooden stick. Wait, I'm thinking about it. But zombie cookies are especially used by malicious websites who want to always track their users regardless of their cookie size. They use other method of storing metadata permanently on their computer, so that they use that info to recreate the cookies. In this video,
So maybe I will skip this one. That is 1 hour. Otherwise, I'm gonna spend too much time on this thing. And I already studied this one.
we will discuss how good old cookies work, and then we're going to talk about how zombie cookies work. We're going to talk about a little bit about the implementation, show you the source code, and how actually you can write zombie cookies. I don't want to go into detail that obviously this is bad practice, guys. Don't use this video. This is for educational purposes. Otherwise, the video will be demonetized. If you're new here, welcome. My name is Hussein, and this channel we discuss all sorts of software engineering by example. So if you want to become better software engineer, subscribe and hit that bell icon so you don't miss any videos in the future. If you like this video, give it a like. That's it. Let's just jump into the video. So I want to start by actually showing you how normal cookies work, right? So I've written a website here, and I'm going to show you how normal cookies behave. All right, so here I have a website I have authored locally on my machine. It has some index page, it has some server-side code, and especially when you're first page, it says, hey, I don't know who you are, please log in, okay? And then when I log in, I say, look up my name, right? And then I say, okay, I'm gonna get back that the cookie has been set. The next time I refresh this, the application knows who I am. Okay, and this is very simple logic, guys, right? We have all done applications like that. And the way we detect that is by using cookies, essentially. So when I logged in, I created something in the backend, and the backend asked my browser to create a cookie for me. And every time I refresh, I check, does this have a cookie? If it's a cookie, try to read the name, and then display on the page. Let's see the cookie that I've been created here. If I go to the application, I go to under cookies here. You can find that there is a cookie, user, and then the name will provide it. Simple enough, right? So this is how cookies work, right? So every time I refresh, we're gonna use that value. But if I said clear, delete all cookies. Once you delete all cookies, and you refresh, the website no longer know who you are. Okay, that's basic stuff, right? So if you go back, there's no cookie obviously, and the website no longer knows who you are, right? So let's show you how zombie cookies. I've written a very similar version of this application, and this is called the zombie cookies version. And what I'm going to do, I'm going to log it as I need a name, Abbas, okay, or Jafar. Okay, no problem. So now I logged in. The website knows who I am. My name is Abbas Ali. All right. Now if I go to the developer tools, click here, and you can see there's a cookie. All right, no problem. Let's go build this cookie, right? And then refresh. What? How do you still know me? I just deleted you. How do you still know me, sir? How do you still know me? What? I swear I deleted that, guys. I deleted this thing. Okay, I'll try again, maybe. What? It was recreated again. You get the idea? Still, the website somehow knows who you are. Okay, all right. I am going to go incognito. Sure, they will not know me there. Okay, let's just go incognito. That's what I thought. They don't know. Wait, what? They still know who you are, even incognito mode. Nasty, very nasty, sir. That is very nasty. How are you able to do that? Huh? How are you able to do that? This is what I talk about. So what I'm using essentially here to simulate this is one implementation of zombie cookies. There are a lot of implementations of zombie cookies. And what I'm using here is essentially a concept called e-tags, which is the caching mechanism in the HTTP platform and the protocol. And we talked about that in another video. I'm going to reference here what are e-tags and what do they do and all that stuff. Right. So if I make a request here, so here's the request to show you how this is happening. You see this request 304.95. This is all because of this. I was able to do that. And what happens is the first time ever you visit the page, it gives the browser back an e-tag. Think of this as a cache to that particular page, so that what happens is with every subsequent request, the browser sends that e-tag to the server. It's very tricky because this is supposed to be used for caching. So every time you send that e-tag, the server takes it and checks with its hashed version of that page. If it changed, it gets a new version. If it doesn't change, it tells you, hey, nothing changed. But that's a trick. You just created some sort of identity, and those guys, the evil media companies, just the evil ones, are using this to identify you. All right. And even if you don't send the cookie to the server, just sending that, they will look up to a database or something in the backend, and they .u389.160.1C1C1FBD is actually Abbas Ali, all right? And they will say, okay, go ahead and recreate that e-tag. So that's essentially how it works. Okay. E-tags, the only way to simulate or implement zombie cookies, obviously not, guys. Look at how much storage mechanism we have here. We can use WebSQL. Some people use NextDB. We talked about it there. NextDB. You can use session storage, local storage, anything really to persist on your client, and use some JavaScript to tell the backend that, hey, these are my cookies, so I can track you. Okay. So evil will always use all of that. So how can I really know? How can I know if I'm using zombie cookie? How can I really get rid of that? Well, to know, you can check obviously all these kind of storages. But if you want to absolutely get rid of any way to be tracked, is to clear everything, right? And I'm talking about images, right? Anything, caches. This is what I show you. Like, so if you go to setting, you go to clear browser history, go to advanced, you gotta check everything here. And don't leave anything, right? Delete everything, essentially. Clear all of those. And what you're gonna do is essentially get rid of all possible ways that the browser caches your stuff and obviously, right, can be tracked as a result, right? So that's the best way. Clear everything, guys. Let's just jump and show you the building. All right, so I'm gonna show you two approaches to the cookies. There's a file here that I created called normal cookie.js, and there's a zombie cookie.js, two server files. Okay, now let's go through just how a normal cookie application looks like. And this is how it looks like. You're gonna acquire the application, which is Express. I'm using node.js here. And essentially, if someone requests this to the root page, which is what we did, we're gonna send an index.html file. If someone requests the login page, we're gonna send back nothing but set, just a message, and then we will send this particular, which is a smart header that tells the client to create a cookie with that username, which has been given to us. Okay, we gotta go through the index.html page code now to actually complete the picture, and then I'm listening to port 88.1. Okay, so that's how a normal application looks like. Okay, the index.html page is very simple. Essentially, there's I have a div element here which shows, hey, I know who you are, all this kind of thing, and there's another button here, button login, and then I'm gonna get that document. If there's a cookie, then I know who you are. Okay, if there's a document.key, I know who you are. Go and just split, give me that user, and then hey, I know who you are. Okay, then I hide the button, the login button, because you don't really need to see it, right? I know who you are, you don't need to login. And if there's no cookie, then that button will show up. After which the user might click on that button, login. I create an event here. I'm gonna ask you a question, prompt. This is a browser JavaScript thingy, which will do that prompt who you are. Give the user, and then we will use the fish API. I'm gonna reference the video. We talked about fish. We talked about even cookies, right? I'm not gonna go through details on the cookies itself because we have almost a course, 40 minutes course on cookies. So go watch that if you're interested. And what we want to do is here is just use the same URL that the user visited. And I designed this because I want to use the index.html page here. And then login and then send the user here. Okay? And obviously just alert. And that's it. I will call that method essentially, right? Which will set the cookie. How? And if you clear the cookie, obviously that's clear, right? But here's what happens here if you do the zombie version of thing. What we're doing here is having a global variable. Think of this as a database, okay? I just stored it in a stateful manner in the same memory. But what I want to do is just simulate a storing of that e-tag, right? So same thing, you get the page, and then here's the difference. What we want to do is first give me the e-tag, and you can always add an e-tag if you're caching. Okay, this has nothing to do with zombie. It's just something you're always gonna see. If none matches the e-tag, if we got the e-tag, good. Okay, if there's a cookie sent to me, then probably everything's okay, right? If there is a cookie that got sent to me, I mean, the cookie had been pre-created before, that's pretty good. I'm going to get that cookie, get the user from the cookie, and then I'm going to link the e-tag with that user. And that's the trick here. And that method is just think of it as storing a new row in the database with the user and the e-tag. Now I know the e-tag, I know which user belongs to which e-tag. That's the trick. If there's no cookie, no problem. I know the e tag because we always have an e tag, right? Query the database for e tag, give me the user from the e tag. Okay, and then I get the user, and if the user's there, guess what? That's the method that we send the normal. If there's an e tag, go ahead and send it back and send cookies, and then create the cookies on the client. Right, and that's the trick. That's the statement that did all of that. Obviously, load is just normal, and that's basically create and get, right? Because it's just literally an insert statement, and this is like a select statement, right? All right, guys, and I'm gonna leave you here, guys. If you enjoyed this video, give it a like, and all right, guys. So Firefox, mighty Firefox is following on Chrome's footsteps and implementing the same site cookie attribute, which we talked about, guys, right here if you're interested to know more about that topic. What is same site? What does it do? What are these different free attributes, non-select, like what does each one of them know? I explained that in details with examples with Node.js and showing the different behavior in each one of them. And now browsers are going all aboard with the same site cookie attribute. So guys, if you don't know, the same site cookie attribute was introduced around 3-4 years ago, and it was for the longest time optional. And when you don't specify this attribute in your cookie, it's going to be treated as none. And for the longest time, when it's treated as none, that means the browser will always send the cookie to your website, even if you were in another website. I think this is called third-party cookie, which is, to me, it's a very confusing name. It is my cookie, yes. I'm executing from a third party. I don't know, I just found the name third party is very confusing to me. Could be just me. But essentially, that's the idea. Your cookie, if you're in piratebay.org, and there is a link that says, click on that link, and essentially that link goes to Bank of America, and you have cookies to Bank of America. The act of clicking that link on piratebay.org will navigate you to Bank of America, and guess what? Bank of America will know it's you because you sent the cookies. That's how same-site cookies work. That's the none behavior, and that's also the lax behavior. When you click and you navigate, that will actually send the cookies. The strict behavior is even if you're not on Bank of America and there's a link that goes to Bank of America, that will never send the cookies, right? So some people prefer strict for that, just to be more secure. That's essentially what the same-site attribute. So now the change in Firefox specifically, I think the latest release August 4th, a few days ago. Now any cookie that does not have the same-site attribute, which used to be treated as none, that means I'm going to send the cookies no matter what. If you're displaying an image from another site and that image requires cookies, I'm going to send the cookies, right? If you're making a post request or a GET request, I'm always going to send those cookies. Now the absence of same-site will be treated as lax. That means certain calls will send the cookies, certain calls will not, right? Because we would help on cross-site requests as calls to load images in frames, right? If you're loading an image, loading a frame, or loading, you can make a call to a fetch command, you can make a post request, also we block with cross-site universal sharing, but regardless, that will not send the cookies, right? So images will be broken, some authentication mechanism will be broken to you, previously you used to rely on, today's no longer working, right? The only time the cookies will be sent if the user navigates to the URL from external site. If you, for example, if you're clicking a site, right, clicking a link, or it's a redirect, right? That the server turned it to a 3, redirect, the browser redirects, automatically, the browser will then redirect, and in this case, it will send those cookies, right? So I instruct you to watch those videos if you're interested in more about same site. But yeah, we're reaching a more secure web, babes. This is beautiful, right? So yeah, it's actually been implemented in 1975, but now it wasn't beta for the longest time. 50% of data for Firefox, but yeah, guys, it's out there, it's there, and they obviously like call to action over developers, stuff will start to break. Oh, look at this. You can turn this off. Were we able to do that in Chrome? I don't remember. Look at that. They allow you to turn it off if you want to. Oh man, they provide all the test. Kudos for NDN and Mozilla. I love that. I don't remember Chrome doing this sort of thing. They give you an example. Verify that all rows are green. Look at all that stuff. They give you all the test. This is beautiful. They give you a test. Awesome. So you can turn this off if you want to. So like by default, it's now true, right? None secure, none requires secure by default true. So this is it. You can turn these off if you want to, right? And essentially, as a result, will be you will treat the same site as none by default. Which to me, it's not secure. I don't think it's a good idea, to be honest, right? Especially if your website, if you're authenticated with your website, and I load a malicious links that goes to your website and execute post requests to your website, and I give you a link to my website, I will be able to execute post requests on your behalf, but just by the fact of you visiting my website. Kind of creepy, isn't it? But yeah, I don't think it's a good idea. I don't think people should enable this. I should leave it the default secure. The other idea is for developers on the back end, us, same site cookies at the server, set them by default. If you don't want that behavior, set them to none, right? So explicitly set same site equal none. Otherwise, if you don't want it, I prefer same site equals select. But that kind of breaks some authentication. You guys might understand, but that doesn't work for your use case. Alright guys, that's it for today. Firefox kicking butts. I love it. I love it. The web is more secure now. Same site cookies, definitely a good idea. I'll see you in the next one, guys. You guys stay awesome. Good night. Third-party cookies as a name always confused me, guys, for the longest time because I just don't see it in the software. You don't see it in the browsers. Yeah, I get you. This is a third-party cookie. You don't see it. You just something you have to understand, which is something I get confused about. Something's not in the software, and we talk about it. Like, what is this thing? Right? So this video, I want to talk about third-party cookies. And technically, we mentioned them. We give them an honorable mention in the same site videos. Check this video out if you want to learn more about it. But third-party cookies are very, very interesting, and I will discuss that within the context of the browser. So in this video, I want to kind of go through what happened when you actually go to a website and you have some cookies on the website. And what happens if there is another request that goes to another website, and just run through that stuff and where are the cookies in this case. Let's just jump into it. Guys, if you're new here, my name is Hussein. I discuss back engineering in this channel and other software engineering like this one. Topics that are interesting. If you like this stuff, subscribe, give it a like, and share with your friends. And let's jump into it. So third-party cookies, the definition of the third-party cookies is cookies that are set on your browser from other domain than the one you are currently visiting. That's very interesting, right? Because if I go to HusseinNasser.com, right, let's go to this example. Let's see my website, HusseinNasser.com, my blog. I type in the browser HusseinNasser.com and I hit enter. What that will do, it's going to do the TLS, it's going to do the mail, it's going to do the TLS, and then I'm going to send the GET request. If I have visited that HusseinNasser.com prior, and there are some cookies associated with HusseinNasser.com that will be taken from my browser and sent along my GET request in the headers section. If this is the first time, nothing will be sent because there are no cookies. Let's assume this is the first time. I go and visit the page. The request reaches the server, and maybe I'll do some processing the process. Reach the server then processes this request and responds back with the same HTML page. And in the process of responding, the HTML page will become the body, obviously that's the content. However, in the header section, there is a possibility where this website needs a cookie. So the server decides that most of the time. And that's where the sit cookie header is set with that HTML tag that we says, hey, by the way, here's your content, here's your index HTML tag. And I want you to set a cookie for that particular site. Yes. And let's say the cookie is, I don't know, some random number, whatever, a:1. So now the sit header will have this value, a:1. And the browser will receive that response and says, okay, here's the content, HTML, let me render that. And oh, where's the header, sit header? Let me add a cookie for HusseinNasser.com named a with a value of 1. Awesome. Now the browser will start processing the HTML page and say, oh, you want to go to HusseinNasser.com/image.png. Sure, that's a good request. Let me turn around and make another GET request to HusseinNasser.com/png. I'm about to send that GET request. And guess what? Wait a second, go to HusseinNasser.com. I am in HusseinNasser.com. I am visiting the site. Hey, do I have cookies for HusseinNasser.com? Guess what? We do this time. It's a:1, a:1. Let me send that cookie in the GET headers and send it to the server. Beautiful, beautiful. The server will respond, we get that cookie, and there's some stuff that knows. The server now knows, hey, the same client is sending the same cookie. So this is a way of tracking the not just authentication, a lot of cookies using for all that stuff. That's how you cookie. Let's continue parsing because that's not the URL. The parse, and here's a beautiful image. But guess what? This image is on yahoo.com. I don't know who's Yahoo anymore, but yahoo.com/image.png. Change the name. Image1.png. Wow, I just changed the name. Okay. Yeah. So now there's an image that we want to pull from another website, another one. And I am not currently in the same domain currently. This is a completely different domain. First of all, can I make this request? Is the course policy, cross-universal sharing, allows me to make a request to this request to this domain. if your content security policy allows it, which we'll talk about right here, content security policy, right? Am I allowed to fetch an image from anywhere other than myself? Am I allowed to execute a script or pull a script from my site that is not me, or this website? Is there something is in the content policy or not? So ask all these questions. Let's say we don't have any content security policy. It's all just like, yeah, there's no security whatsoever. All right. So now I can make that request to yahoo.com/image. So do I have cookies set for yahoo.com? That cookie, if it exists, in this case it doesn't, is called a third-party cookie. 7 minutes to talk about third-party cookie, guys. Yeah, you can watch a 1 minute video or just watch this 7 minutes long on third-party cookie. I know, I'm slow. I like to take my time and explain these things. It's just the way I learn. You might disagree, but anyway, let's continue. I don't have any cookies, my friend. So let's say I get a request to yahoo.com/image1.pinch, and then my server, yahoo.com, will receive that get request. It says, oh, that's a delicious request, delicious. I need to track this vague because this site doesn't have any cookie. We need to track him. We need to set some cookie. Let's set a cookie called y=1 because y for yahoo. And now we're gonna respond back with the image, and here's what the server might just say, F you, right? I'm not gonna respond with the image 404 or 443. You can't forbid it. But here's the image. Take it. But set cookie header. Here's another header. Set cookie y=1. Set that dang cookie in your browser. So the browser now. Let's see if I can request. Here's the image. Oh, yahoo.com wants me to set a cookie in my browser for yahoo.com and so yahoo.com. But wait a minute, I am in HusseinNasser.com. That's called a third-party cookie. Because it's just the same cookie. It doesn't make any sense, right? If you go to yahoo.com in a completely different tab, y=1 will be sent. And that, in that case, is going to be called first-party cookie. But here, it has been cross-referenced, cross-site. It has been referenced by another site. Yet, it is called a third-party cookie. Yeah, because I am not in the site. And those things are used absolutely for tracking or for authentication or for showing the likes for Facebook.com. They're used everywhere. I need to know you're not Facebook.com, you're just HusseinNasser.com. I want to show, for example, whether someone likes this page or not. So you add this plugin that points to Facebook.com, right? And does the exact same thing. It will send that request, it will respond back with the cookie, and the next time you load the page, it will send the cookie to Facebook.com or Yahoo.com, and it will now recognize you essentially. That's how it works. Let's continue with Yahoo now. So we'll set the y=1 value, and now I set it. But Yahoo.com y=1 is a cookie that is in the browser. It's there, but it is set by a cross request, right? It's not set by actually me visiting, right? And now I will refresh the page again. Let's say these are the only pages. If I refresh again, HusseinNasser.com, immediately I'm going to send a=1 to a=1 because hey, I know you now. So you can change the behavior on the server side. Oh, now we got a=1. I'm going to change the behavior. You can change the complete website based on this stuff. You can start loading, you can start tracking, right? So hey, a=1, we just see that this is the same, just send me the same cookie. We get a respond back with the same content, let's say there's nothing changed. Pause. HusseinNasser image, the binge, we send a=1. We go to yahoo.com, we want to send a request to yahoo.com/image1.png, and we send that get request to yahoo.com. And guess what? We send with it y=1. Yep, queen. And that's what Google changed. Same site property. If that cookie said same site =lax, then the browser will not send the cookie y=1 to yahoo.com. If it has the same site property =lax, then it's not going to send it. If it's strict, definitely it's not going to send it, right? Because there's like a, yeah, we talk about the difference, right? There's a change in navigation or it just makes a cross request. So it's not gonna send. If the same site property in that cookie does not exist, then we're not going to send that cookie. Let's right. Let's say it's the exact same thing. I'm cleaning HusseinNasser.com. First time visiting it. But going to yahoo.com, right, start processing the page, yahoo.com, send that request, I don't have a cookie, yahoo.com will receive that. And the yahoo.com, if it starts replying back with the cookie, hey, send me that cookie, and make the same site, let's say it doesn't exist, the same site attribute of that cookie. So if it receives back, here's what Google changed. Chrome and Firefox is following this now. Now, if you refresh the page again, that cookie has been set. But guess what? Y=1, but there's no same site attribute. So by default, if there's no same site attribute, it's going to be treated as lax, and as a result, it's not going to be sent. So if you refresh the page, you go to hey, I'm about to send a request to yahoo.com, but I'm HusseinNasser.com. I have a cookie for yahoo.com. Should I send it? Nope. Why? Because it doesn't have the same site attribute. That means it has it essentially be treated as a lax, and lax means do not send that cookies if it's a cross request. That's what it means. Just don't send it. It is going to be sent only if it's an actual URL and the user chooses to click on that damn URL, which causes a top level navigation to go to yahoo.com. And in that case, going to yahoo.com/png, image1.png will send that y=1 cookie. And as a result, you'll be organized. I think it's a great change. Same site. However, what can Yahoo do to continue to practice? Very simple. All they have to do, yahoo.com, they go there, and when they want to send the cookie, they add a beautiful attribute called same site, none. And none is basically the original behavior where we essentially always send the cookie, even if it's cross-site reference, as we talk about. How do you guys like that animation, by the way? I know there are animations, and people give me a lot of beef because of this. Just don't know how to do animations, right? Alright guys, so that was the same site, that was like the third-party cookies, and guess what? I just learned those goddamn things are going to die in 2022, but I don't know anything about that. Google's going to completely destroy this. Now there's a workaround. You can set the same site =none, the ads, anything that basically makes a request that's not to your website. What's going to happen to that? That's going to be a different video in detail talking about the death of third-party cookies. That's a third-party cookie. Alright guys, 16 minutes to talk about third-party cookies. Alright guys, I'll see you next one. You guys have them. Goodbye. What's going on, guys? My name is Hussein, and I want to talk about the same site cookie because despite me discussing this property for like 3 or 4 or 5 videos, I still every day I find out new things about the same site =lax, same site =strict, and all these properties and these special rules and governance with regard to this property and what is the application for us engineers when it comes to this property. So I talked about same site, guys. If you want to learn about this thing in general, go watch this video right here. But I learned something new today thanks to some of you guys actually send me messages. Hey, do you know about this? Do you know about same site? There's like a case when the cookie is less than 2 minutes ago, it has different contract compared to others. Like what? So let's discuss this. So guys, very very quickly, same site attribute. So when I visit this website, for example, any website like chromestatus.com, right? Any cookie that has been set for chromestatus.com will be sent with my attempt to hit enter, right, or visiting the site, right? If the cookies exist assigned to this domain, it will be sent. However, the act of loading that website also makes requests to other cross-site requests, right? So cross-site domains other than Chrome status. So for that, these cookies that are going to another website implicitly without me actually doing anything about it, magically making requests, let's say for Google Ads or whatever website going making requests from this domain, cookies for those third-party domains that are hidden, kinda, are called third-party cookies. We talked about that. And if those cookies, the same site property controls whether you want to send those cookies to those third-party sites that you're not in. You're not in chromestatus.com. You're not in this major top-level domain. What do you do for those cookies that you're going to like from other requests? And very specifically, sending GET requests or idempotent safe requests will be is different than sending post requests and non-idempotent requests. So let's talk about that a little bit. So if let's say the property lax, right, which means that you are allowed to send the cookies as long as the cookie first of all exists on the other side, right, and the cookie is marked as lax. If it's marked as lax and you're making a GET request, like you're loading an image, you're doing a fetch command or XHR and doing a GET request, that's absolutely fine. The act of you making the call to the other website that is not the website that you're visiting right now will send the cookie, right, for GET requests essentially. And if you click on a link like this, go to some other site like this, for example, WebKit, the act of clicking that link with your choice will also send the cookies for WebKit.org if they exist, right? So if you have cookies for WebKit.org and you click on that link, you're gonna send those cookies to WebKit.org, right? With, however, post request, right, whether they are executed immediately when you load the page or whether they are like as a script code, given that the content security policy is not violated, then post requests are not getting sent in case of lags. That's just the rule. We only send lax cookies, let's say, when you're doing a GET request, not when you're doing a post request. However, there is an exception to the rule, as usual. So let's do this and then explain. Chrome will get an exception for cookies sit without the same site attribute. And we talk about that. If you're not sending the same site attribute, it's treated as lax. But there is a code here. And less than 2 minutes ago, such cookies will be sent with non-idempotent post request. So if you have just set a cookie for another site within those 2 minutes, and you make a post request from this website to the third-party website, then the post request will be sent because those cookies are just fresh cookies. 2 minutes. I don't know why 2 minutes, but I'll explain my theory of why this is an exception, right? And obviously, it says the support for lax plus post will be removed in the future, so pay attention to this, right? So post request to third-party sites, cross-site sites, will send those lax cookies if they are created within 2 minutes. And I believe the reason for this is for single sign-on sites, right? Because most of the single sign-on, if you go to a website, it makes a post command to a third-party website, which is a single sign-on Okta or whatever, right? And then it actually sends that post request, and if that request succeeds, it checks out, do I have a cookie here, right? If you had a cookie set, but you have already signed in, then you will be basically immediately get back the cookie, right? You get back the result from the post command that says, okay, you have signed into that website, you're good. So what we're gonna do is change the user experience, so now you're logged in. So we're gonna redirect to the proper site and set the appropriate top-level cookie, and we're gonna recognize you as a single sign-on, right? If that post request to the third site, which is Okta or whatever, fails, let's say, oh, I don't know you, there's no cookie, then the site will say, okay, let's redirect you to Okta.com. So let's say, let's redirect to Okta.com, you can put your credential, you can hit enter, that will set the Okta top-level cookie, and then you redirect that back to the page that you want to sign into the service, and then we will execute that post command again, right, to Okta. Says, oh, am I actually signed in? And the act of doing a post, if you're doing things like lags, and within 2 minutes, which is we are, right? That was very quick. Right? Probably took 2 minutes. So if you took more than 2 minutes, actually, not really, that's not right. But if you come back and just execute that post request, that will send your cookie, your Okta cookie, and Okta will recognize you, and then obviously the site will change, right? This is what caused first before this thing. This was causing a havoc because the infinite redirect when it comes to single sign-on, right? Because you visit the page, you send a post request, but that obviously post requests are not originally wasn't allowed for same site, remember? Same site lags. So we will not send the cookie to Okta. You'll be redirected, you will log in, and then you will send the cookie for Okta, which is already there, the cookie was already there. But you go back to your original site, and then you try to make that post command again, and the browser will never send those cookies because they were same site lags before those 2 minutes, before this exception. And you end up with this infinite loop scenario. So those 2 minutes, I think, were added as a kind of a hack to avoid all this, right? The other option is just change as a developer, back-end developer in Okta to set the same site equal none, right? Which is very dangerous in my opinion. So I think the Google team and the Chrome team doing this hack is actually better, so that Okta can still set their cookies as lax and enjoy the security that comes with lax cookies. Plus, there's like teeny exception when it comes to post, right? Command, and it's only within 2 minutes. So if someone hacked and managed to do a cross-site request forgery or cross-site scripting, they will not be able to hijack that cookie, right? Because it usually happens after the 2 minutes, right? So yeah, I think we're good here. So that's the idea of this for this change. So guys, just pay attention that this is going away. So if you're relying on this as a front-end engineer, as a single sign-on engineer, you're working on this, pay attention that this will go away, and don't freak out when it does. So I'm gonna make another video when it does. There's not much information about this as of today. Now, this is the only page I found discussing this, but if I find more, I'm gonna let you know, guys. And that's it for today. I just wanted to make a video discussing this. So there's this website called This Plate that basically prints pictures, covers into a plate, metal plate, so you can put it behind you, you can film them, stuff like that. Right? It's very nice. So I heard about that from different YouTube videos. I was interested, so I went to thisplate.com, hit enter, and first thing came to my mind, I wanted to search for kimchi. I wanted the Samurai X This Plate. So I found a few. I didn't buy any, and then I closed the site. The next thing I went to my Instagram, and I've been bombarded with the same pictures This Plate ads with the same pictures that I picked from the site in Instagram stories and pictures and the ads right to show up. So I was wondering, how did This Plate communicate with Instagram to transfer that knowledge? Obviously, I was surprised, but you shouldn't be surprised these days. But I'm interested from the technical perspective because it's a tech channel, it's a software engineering channel. So I will discuss what I think happened. So when I went to display.com, I was logged into Facebook because it's my own machine. And I didn't open this in incognito window or anything like that. So I was logged into Facebook, so I had a cookie with Facebook. That was my theory. If I went to display.com, I believe what happened here. Display had a request to Facebook ads, this is in this case a third-party domain, to send whatever I searched to Facebook as a request. So Display, they don't know who I am because I didn't log into Display. They don't know anything about me. That request says, hey, someone just searched Kinshin on Display, Facebook, and that just sends that request magically. Display technically.
It's crazy how much information they have on everyone, and every day it gets more and more, especially Microsoft. You pretty much probably track everything that you do on the computer. That's why I want to move to Linux, but the issue is that then it's really hard to stream because Linux is not very good for streaming. But eventually one day I'm probably gonna think about that. I think I'll probably have 2 computers eventually. One for streaming and the other one for personal stuff. But I'm not sure if it matters anymore because they already have a bunch of information on everybody at this point, so probably it doesn't matter that much.
List Facebook and communicate that information back. So now, when they send that request to Facebook, as a GET request, as a pull request, doesn't matter. If I had a cookie with Facebook.com, and that cookie is set property same site equal none, that request from Display as a major site to Facebook.com will be sent. That cookie that identifies me will be actually sent to Facebook alongside the information that says, oh, someone just searched Kinshin on Display. So now Facebook knows that me, Hussein, actually searched for Kinshin actually on Display. So he's interested in this anime. So now they just know the knowledge. Very simple. Now let's just bombard them with ads. So they can serve me ads in Instagram. They can serve me ads because Instagram owns Facebook. Right? They can serve me ad there. They can serve me ad on Facebook themselves. So they can serve me ads everywhere because they know that they got the knowledge that I'm interested in this. Not only search Kinshin, I actually interested in this particular one, the one I clicked in, because that's the one that gets bombarded to me on Instagram stories. If it's the same one I actually clicked, there were like thousands of them, but the one that I actually clicked on got recommended. So now my thoughts is now, does Display, the website, know me? Well, if I visit them again, they probably do because they stored it in my local storage on browser. But if I went as an incognito, they definitely don't. Because I don't believe Facebook will communicate this information back to Display. Otherwise, it'll be breach of privacy. I don't think they have privacy, I'm quite sure. But yeah, I don't think they will share my name with Display. That will be bad. I don't think that information is communicated back. But I think Facebook will say, hey, rest assured display that we're going to target your beautiful customers in a very micro manner. That's going to be, it's sneaky, I got to admit, but as software engineers, you got to admit that's a little bit smart. The technical part of it. I don't condone the whole tracking, those things like that. But that's the world we live in. What do you guys think about this? Did I miss anything? Do you think there's another loophole that Facebook found where I'm interested in? Let me know in the comment section. I'm going to see you in the next one. Bye.
Go. I'll be right back. Be right back.
In this lecture, I'm going to show you how to get information about the current operating system. So back in node documentation, in the list of modules, if you scroll down, you can see this OS module. Let's have a quick look here. So these are the methods that are available in this module. For example, we have free mem, which returns the amount of free memory on this machine. We also have total mem, which is the total memory. We can get information about the current user. We can get the uptime of this machine, and so on. So let's use a couple of these methods here. So if you scroll down, you can see this is how we load this OS module. Just like loading other modules. We call the require function and store the result in a constant called OS or anything. So back in VS Code, I'm going to delete all the code here and define a new constant OS and set it to require OS. Now we can call total mem method or free mem or other methods. So let me declare a variable and store the result here. And similarly for the free memory. And finally, let's log these values on the console. So console.log, single quote, we add total memory, and append this total memory here. Now, we can simplify this expression by using a template string, which which is available in more recent versions of JavaScript that we refer to as ES6 or ES 2015, which is short for ECMAScript 6 or 2015. That's the specification that defines what features are available in JavaScript. So every year, ECMA defines new features that should be added to JavaScript, and as you know, different browsers implement different set of these features. But the V8 engine that we have inside of Node, that's pretty up to date, and it implements a lot of new features of JavaScript that is defined in ECMAScript. So in ECMAScript 6 or ECMAScript 2015, we have a feature called template string, which helps us build a string without concatenations. Let me show you how that works. So console.log. Now, instead of a single quote, we use the backtick character. Backtick is the character before number 1 on your keyboard. So here we add some static text, like total memory.
Another thing that I realized that before I was doing analysis on dependence data frame, and then the computer crashed in the middle while I was streaming. And I thought it was because of CPU processing, but it's actually not. It's because of the memory. So that's something that I'm thinking about as well, of buying a new memory RAM. Because I only have 16 gigabytes and big data frames crash. I think a 50 gigabyte data frame requires around 15 gigabytes of memory. So yeah, that was the reason why the computer crashed that time. I just remembered that.
Now we'll add something here dynamically. So we use $sign and curly braces to add a placeholder for an argument. In this case, our argument is this total memory variable. So you can see with the template string, we don't have concatenation. Okay, now I'm going to duplicate this line and change total to free. And here let's add free memory. Okay, now we don't need this first console log. We're done with this. Let's go back to the terminal and run this application. So node app.js, and you can see the total and free memory on my machine. Now what is interesting here is that before Node, we could not get this kind of information using JavaScript. JavaScript used to run only inside of a browser, and we could only work with the window or document objects. We couldn't get information about the operating system. But when using Node, our JavaScript code is executed outside of the browser, or as some people say, on the server. With this, we can get information about the operating system, we can work with files, we can work with the network. For example, we can build a web server that listens for HTTP requests on a given port. I'm going to show you all this later in this section. Hi guys, it's Mosh here. Thank you for watching my Node tutorial. I just wanted to let you know that this video you've been watching is part of my complete Node course where you'll learn everything about Node from basic to advanced topics. If you're serious about learning Node, I highly recommend you to enroll in my Node course because this is much faster than jumping from one tutorial to another. It saves you time. Plus, you're going to get a lot of exercises that will prepare you for the real world. And also, at the end of the course, you'll receive a certificate of completion that you can provide to your current or future employer. So if you want to enroll, click on the link in the video description. I hope to see you in the course.
Okay, so this afternoon, I'm going to be talking to you about service scaling in Node.js. So there are a couple limitations with the way that we have our basic Node.js apps right now, and we can actually address these pretty easily without having to install anything. So this is actually built into Node. You can do this into pretty much this afternoon if you want. It's really easy. So let's just talk about a couple of limitations that we have so far. So here's your project, your Jackon. It's awesome. Everybody wants to, come look at it and have all these different tons of HTTP requests coming all of a sudden. And you're going to handle it. So because you only have by default Node single threaded, it's asynchronous, but you can only handle so much at once. Second bottleneck, you have some really computationally expensive endpoint. Your API is doing a lot of mid-range processing or something, some other algorithms running, and it's going to hold up a lot of different HTTP requests that are coming in because it's waiting for this to return because it's blocking. So this is another bottleneck that we should address. And the third bottleneck, maybe it's literally a bottleneck. On your server, it just goes down. You can't do anything about it. You got to restart the whole thing. So that takes time. So we can actually address this issue as well. Well, actually, maybe if it's all on one machine, maybe the situation doesn't actually, you can actually resolve it. We can't tell you. But abstractly, if the version, if your server goes down, there's a way to build some resiliency into your programs. So here again, so the bottlenecks we have. On request, by default, we have a single threaded process. That's going to block when it's a lot of issue processing it. Notice pretty well with concurrency, since it actually found out a lot of other basic IO operations are slow. It puts in that loop, and that's handled by some threaded database possibly. That's like the JavaScript level, you still got a single thread, which again, in computational endpoint, you're going to run that limit. So, and server threaded. When a single thread, single process goes down, there's no backup for it. Again, just to reiterate, we have a single thread process, but we have these nice expensive laptops here that we spent a lot of money on. We bought all these 8 cores, and we want to be able to take advantage of it. Because if you actually run a node process and you fire up your activity monitor, you're going to find actually that only one of your CPUs is running that full.
That's one of the reasons why I kind of want to learn Rust more. It seems like that Rust gives you a lot of power, because I was looking at a library for reading data frames that is called Polars, and I think the guy built that library on Rust, so it would be interesting. It's the same with C++ as well. Both C++ and Rust are languages that are related to the system, that can communicate with the system at a lower level. I think everything else is built on top of those languages, and understanding them and understanding how the computer actually works with these languages is probably very helpful in order to be able to become better at the other languages. So I think I'm gonna watch the videos on Rust and Golang after I'm done with Node.js and the other stuff as well. But obviously I won't dive too deep into it because I don't have enough time. But I'm definitely curious about them and I wanna learn more about them, especially Rust and Go. Yeah, Rust first and then Go. And Go because Ethereum I think was built with Go, so it seems that like it could be very useful. And then Rust is also used on Solana, so it might be useful as well to learn more.
If it's continuing churning. And again, it's not like web apps servers necessarily are like just grinding away like 100% CPU power because you're mostly processing HTTP requests. You're not doing anything crazy like a big compute, but you might. So it's just something to be aware of. Right. So let's just talk really quickly. That's my little animation. Concurrency versus parallelism. And it's a little bit of technicality, but technically correct is the best kind of correct. So here we have two processes. On the left, we'll see them running concurrently, as Node actually does, and just in general, like any multiprocessor, since I'm not going to put a date, that's going to be wrong, but for a very long time, they've all been single-threaded anyway, but they all run concurrently. And because you're running multiple programs on your computer, even though they can all be single-threaded, there are many programs running at the same time. And versus parallel on the right. So the difference is that, again, concurrency means that many things are running at in the same period of time, while parallelism means that two things can be happening at the exact same moment. What that means is that, for example, these little dots represent some instructions for this particular program, right? So here we have maybe the CPU runs the first two, and then it decides that, oh, okay, I can run the next two of the second program. I'll run that one, and I'll just like switch back and forth. And you won't really notice necessarily a difference in that two programs aren't literally running at the same time. Whereas in parallel, we're actually getting what each clock cycle of your CPU is running two instructions or multiple instructions at the same time. And these don't even have to be on the same computer. Like this could be two separate computers, like two laptops or a cluster of servers, for example. And that's the way it's been done for a long time. You just buy more computers, buy more servers. All right, so let's get to it. First way to scale up application to deal with HTTP bottlenecks is with this cluster module in NPM. Not NPM, I'm sorry, Node, which you don't actually have to go to NPM for. So we can just use the cluster module again. And it does this, what it's actually going to do is basically just copy your server. Just take a program and just make a bunch of copies. And there's going to be one process that's called master. And it will just, by default, use a round robin scheduling algorithm, which just says, like, it'll do the first one, HTTP requests come in, like, it'll just say the first one does the first one, the first worker, the second one does the second worker, and just down the line and so on, it'll just loop back around. And it does okay for what you want to do. So let's just see in the code what that looks like, if I can get this to not explode. So here it is with here's a basic Express app on the left, where you just have, again, with no cluster. It's basically what we do in every other app. We've done this, in this bootcamp, where you have, you just hit some endpoint here, like on line 12, just simulate some work, just like do some stuff, and then send it back, just, process a bunch of routes. Pretty basic. And in our cluster, what we're doing is actually we require this cluster module. And then here, what we're doing is just going to say, oh, if the cluster is the master, it will do this cluster.fork and fork off a number of CPUs. And you can query for that by using OS parameters or just type it manually. You can put as many as you want, but really there's not really any benefit to scaling more than what's actually physically available. And then if you're a worker process, you basically are just the HTTP server. So you're just going to do basically everything that was in the single-threaded app. So why do you want to do that? So here's the demo of that situation, right? So here, let's do run a cluster. Here's our single-threaded server, just like servers listening. Great. So I'm going to be using a HTTP benchmarking utility called Siege. So it'll just simulate a bunch of concurrent connections coming in. So just running 100 concurrent users. I might already prepare a script, so save typing. Just run for 10 seconds. You probably want to benchmark longer than 10 seconds, but essentially it's like, all right, that's kind of the performance we get for, say, your basic node server, right? So now if we do npm run with the cluster, okay, we can type cluster, there you go. Okay, 14 CPU. So now we can see that it's actually copying that server and just writing copies of it. Now over here, if we do the same test, 10 seconds, oh my god, getting my time. There you go. You can see the performance difference in having a single one on the left, where the transaction rate we're getting 448, and transactions per second on the left on the single threaded, whereas with 4 of 8, you can get almost like over 3 times performance. And so, you have to look at your specific app and actual benchmark your actual app, but you get a lot better throughput on, well, not throughput technically, but yeah. I'm trying to get the other two real quickly. Okay. Play. Right, so here's our other second bottleneck is computationally expensive endpoints, where you just have some huge calculation here, and it might not even be like necessarily frequently hit in your API, but once it hits it, then it's slowing everything down behind it, and it just holds up like everything on your server if you have the compute on your HTTP server, as we're in our naive case. So to fix that, we're going to use something called child process, and what that does is, where is it, fork? I'll show you the one that with fork. So basically, here's a slow computational endpoint, and here on this line, to save time, I'm not going to show you the normal version. It just struck me that there's the normal version of this, and so we see what we just call the fork function with the computation that we wanted to run. So instead of doing it on that, we just start a separate process. So let's get that. Run. No fork. No forks. Okay, so sorry, I know I'm out of time, but I just want to show you this last thing then. URL. I'm dancing. Okay, so that's with forks. Okay, now forks. Okay, let's do it with URL file. Same. You guys can have to class about details of the actual benchmark, but at the same time, let's do it. 10 seconds. So you can see on the left, once it hits a computational endpoint, you only have one thread handling that. You're only processing 54 transactions, where on the right, you're able to process over about 400. So it's really easy to do. I was going to do a demo, but I'm out of time right now. To show that actually, just like the author workshop, literally just put it in the cluster, just like fork it off, and you can get the same like kind of performance if you benchmark that. Server availability, again, there's I'm not going to demo it, but you can use the same cluster to listen a registered event listener for any workers that kind of just crash unexpectedly, and when you detect that, you can just spin off another worker or forking off another worker so we can continue to handle your HTTP requests. So to go more faster than that, probably just buy more hardware, use a front-end server that faces the internet, like maybe Nginx or Apache or something that does something maybe more sophisticated. Take advantage of multi-core. You can use child processes to call native libraries if you have more computationally expensive endpoints, whatever you want to do. It's going to depend on your use case, but there are options for you. So let's just leave it at that. But thanks.
All right, how you guys doing? Ready for some party? All right, let's get disappointed first, maybe. So who's here? You're either in this room to learn a little bit of Node or to be pissed off about what I'm going to say, right? So who's here to learn Node? All right, perfect. So the talk title is You Don't Know Node, and if you don't really like the talk title, blame Dave, because he picked it. In reality, the more correct term is you probably don't know most of Node. And I actually stole this talk title from my good friend Azat Martin, and if you don't know Azat, if you don't follow Azat, you should definitely follow him and follow all his good work on Node. Here's my beef. Most educational content about Node teaches Node packages. And there's probably nothing wrong with that because you probably need to use Node packages. But those Node packages actually wrap the Node runtime. And when you run into problems, you're most likely running into problems in the stack, in the Node.
I think I'm gonna go back to studying these topics here, and then after that, maybe after a few of this, I'll go back to those videos.
So what's going on, everybody? My name is
I think I will do this stuff today and tomorrow, and then after that, I'll go back to studying to improving chain data, and I'll start with the blocks probably. And as I work on the getting the blocks, the information from the blockchain, I'm gonna also try to incorporate data analysis on the getting user data on the site. I'm gonna try to implement that. Yeah, but I think today and tomorrow is probably enough to look at all these topics. I think I'm gonna put Rust and Golang as well. Just watch the videos. If it's not, then I'm just gonna stop wherever I stop at, so I don't waste too much time.
Okay guys, so welcome back again. So in this video, let's talk about child processes that are baked inside Node.js. So for those of you who don't know that Node.js processes are single-threaded, but what if you want to harness the full power of a processor? So for that, we have the child processes, and there are 4 ways to instantiate a child process. Firstly, we have the exit method. Secondly, we have the exit file method. Thirdly, we have the spawn method, and lastly, we have the fork method. So in this video, let's talk about the first 3 processes, that is the exit file, and the spawn method. And the fork method, we'll be looking at in the next video with a very practical example. So let's see that how to use these child processes and what are their use cases. So as we see here, I've created a new npm project, and I've created a few files here. That is the exit demo, the exit file demo, and the fork demo, and the spawn demo.js. So basically, we'll be writing all the code related to the exit in the exit demo. Exit file would be inside exit file demo, and so on and so forth. So now let's close this package.json file and let's start working on the exit method of the child process. So firstly, what we need to acquire the exit method from the child process. So we'll say const something equal to require child process, simply like this, and then we need to extract the exit method. So we can simply extract it like this. And now what we can do with this exit method is that we can run a command inside our shell, and we can get output back inside our terminal here. And for that, I'm going to use a very simple command that is ls-lh to list all the files present inside the current directory with human variable types. So let's use this method here, that is the exit method. So here we need to provide in the command as the first argument, and the command would be ls-lh. And this would list us the files in human variable byte format. And then we have a callback here with error as the first parameter, and then secondly we have the standard output, that is the output coming from the console, and then thirdly we have the standard error if there is any error printed out inside the terminal. So now first let's handle this error here, that is in case there is an error executing this command, that is the command might not exist on your system. So we check it. So if error, then what we simply need to do, we need to simply log inside the console. So console.log, and we use brackets here. So error, and here we can display the actual error using the template string. So error not message, something like this, and then we can simply return from this callback function like this. Secondly, we need to check if there is a standard error, that is the command has been executed but there is some error inside the terminal. So that error is the standard error, and that's the difference between the error and the standard error. Error comes when the command is not found or the command has missing arguments, while the standard error is the error coming after the command has been executed. So now let's check for the standard error. So std error like this, and here we can use the same thing, that is we simply need to log inside the console. So let's simply paste it here and let's change this error to standard error and this thing here to standard error directly like this. And now finally, if everything works fine, we can simply log out the standard output that is coming inside the terminal after executing this command. So here we can simply make a log statement to console.log, and here we can use the backtick, so standard out, and here we can directly print out the standard output like this. So now let's save this file, that is exit.demo.js. So now let's execute this file, that is exit.demo.js using node. So we'll say node exit underscore demo.js, and as soon as we execute this command, we'll be getting the output inside the terminal. So we see here, that is here we are seeing the files that are coming from the standard output inside this console here, and it lists all the files that are these files present in the current directory in human variable byte format, as you can see here. But the problem with this exit method is this, that all the standard output is taken into buffer and then it is printed out in the console here. So if we write here a command which has a huge standard output, that is a huge output coming inside the terminal, then we won't be able to use this method, that is the exit method. And I'll demo it to you by using the find command, that is I'm finding all the files inside my root directory. So now let's save this, and now if we simply do node exit.demo.js, we'll be getting an error here that says standard out max buffer length exceeded. It does not mean that this exit method is pretty useless. It is very much useful if you want to use small commands like the pwd command, that is to print the current working directory. So if I use this command, I can get the output back here very easily, and we see that it is coming out as a standard output, and we see that the current directory is a directory. So it is pretty useful in utilizing small commands, that is you can create a directory using this exit method and you can use the files and so on and so forth, but not for commands which have a huge standard output. So for that we'll use this spawn method, but we'll be doing that later on. But first let's see that how we use the exit file method of the child processes. So now let's go to this exit file demo.js, and firstly here we need to require the exit file method from the child process, so it can be required like this. It is like child process, and now here what this method will do, it will take in a file name and then it will execute that file as the name suggests. So here we need to provide in the file name, and then here we have the callback function with the same arguments, that is the error in case there is some error, then the standard output, and then the standard error like this. So this should not be here. So now we can do the same things as we did in the exit demo. So let's copy this piece of code because it's common for both of them. So let's copy and let's paste it here. So if there's an error, we are simply making a log statement of the error. If there is a standard error, then we are simply again making a log statement. Otherwise, we are simply printing out the standard output. But now here we need to provide a file name that is an executable file. So for that, what I'm going to do, I'm going to create a new executable file. So let's create a file here that is fetch some file.sh. I'm simply creating a shell script here. And now let's change the permission of this some file.sh to be executable. So I'm doing chmod +x, and here we can provide in the some file.sh to make this file that is some file executable. And now this is an executable file, so we can use the shebang here. So shebang bin bash like this, and here I'm again going to use the same command, that is ls-lh, to list all the files in the current directory. So now let's save this some file.sh and let's go back to our exec file demo.js, and here we can provide in the path of that file. So here we can provide in the path like some file.sh, simply like this. So now let's save this file, that is exec file underscore demo.js. So now let's execute this file, that is exec file demo.js using node. So node exec file demo.js. And again we see that inside the terminal or inside the console we are getting the output from the standard output, as we can see here. And now if we change this file, that is some file.sh, and now let's change this ls-lh and let's simply print out the current working directory. So let's simply use the pwd command here. And now if we again do this thing here, that is node exec file demo.js, we are going to see the standard output, that is the current working directory here. But now let's use the same command which we did in exec demo, that is the find command, because it gives us a huge output in the standard output. So let's see if it works here. So let's again execute this file, that is exec file demo.js. So again we see that we are getting this error here, that is the standard output, that is the error here, that is maximum buffer length reached. So now it is clear to us that is we cannot use these methods, that is the exec and the exec file. So for that we have a solution, and that is the spawn method of the child process. So let me comment this out and let me uncomment this. And now let's close this file and this file. So now let's open this spawn demo.js file, or the spawn underscore demo.js. So firstly here we require the spawn method from the child process. So we'll say const something equal to require child process. And now here we can extract the spawn method, so we can simply extract it like this. And now here we can create a child process using this spawn command. And firstly, I'm going to simply list all the files inside the current directory using the spawn method. So here we'll say const child equal to spawn. And here we need to provide in the command name. So the command name is ls, but there is an argument to this ls command, and that is the -lh. And those arguments we provide that inside an array here. So we can provide the argument like this, that is ls, and then the arguments inside the array. And whatever command you are using, you can simply provide in the arguments here inside this array using comma separated values. So now here we have created this child process using this spawn command, and now we need to listen on the standard output, on the standard error, and then on the error itself, and then finally on the exit event of this process. So now we need to do a little work here. So child.standard out, that is on data, that is the data coming from the standard output, and here we have the data itself, and here we can simply make a log statement again. So console.log whatever the standard output is coming, so std out, and here we can print out the data using the template string like this. And now we need to listen for the standard error, so we again say child.standard_error.on, and here we have the data, that is the data from the standard error, and then we have the data itself like this, and then we can simply again log it inside the console. So console.log standard error, so std error, and then we can simply print out the error using the template string using this data thing here. And then we need to listen for the error event on this child, so we can say child.on. Here we have the error event, and then we have the error itself, and then we can simply log it inside the console, that is console.log using the template string. So error would be this error, so error.message like this. And now if you want, you can also listen for the exit event. So we can say child.on, and here we have this event, that is the exit, and then here it takes in two things, that is the code and the signal. So if there is some code, then we can say console.log process exit with some code, or let's put it like this, and the code would be this code. And if there is some signal, then we can simply log it inside again. So console.log process killed with signal, and then we can print out the signal code itself. So this would be signal here like this. And finally, if everything works fine, we can simply make a log statement that done. So we can simply say done, and we can use this emoji here, that is the check mark. So we can use this thing here. So now that's all what we need to do to spawn a child process. So now if we save this spawn demo.js, if we run this file, that is node spawn demo.js, we see that we get a list of all the files inside the current directory. And finally, after printing out the output, that is after the standard out when the process exited, we get this thing here that is done, which means that the process
Hey guys, this is Dooley. In this video, we are going to essentially start a new series of videos where we will talk about the child process module in Node.js. So this module will allow you to start new processes while running your program. So what does that mean? When you call node and you provide a file that you'd like to run, what you're effectively doing is starting a new process, and this process will make available some resources, an environment for your program to run, and your program can use these resources to do its task. So what this module essentially allows you to do is to start.
So we all know that Node.js is single-threaded. This means that a Node.js program
these new processes by calling specific programs that are already in your computer. You can do that by using a command. You can do that by using a file, or by using some node program that you have in some directory somewhere. And while calling the functions to start these new processes, you can provide arguments and options for these child processes to know where they're going to run, what sort of resources is going to be available to them. You can start these new processes synchronously or asynchronously. So we will look into the different functions that you can start new processes with, and see what the difference is between them. Okay, so here we have 4 functions you can start child processes with. These functions are asynchronous, meaning that the parent program will not be waiting for these child processes to terminate before the parent process terminates. Okay, so the child process that spawned, there's exec file, and fort. So these are the 4 functions you can call asynchronously to start a new process. These are the synchronous versions for spawn, exec, and okay, so here we have 4 functions you can start child processes with. These functions are asynchronous, meaning that the parent program will not be waiting for these child processes to terminate before the parent process terminates. Okay, so the child process that spawned, there's exec file, and fort. So these are the 4 functions you can call asynchronously to start a new process. These are the synchronous versions for spawn exec and exec file. So what that essentially means is that your program is going to wait for that process to terminate before the parent continues with its execution. These are the events that the child process can fire, so you can listen for these events on the child process. So it's also an event emitter, so keep that in mind. So these events are close, disconnect, error, message, in edit, exit. You can look at these explanations here, but we will look into them in more detail in the videos, in the future videos that we'll do on this. These are some functions, child disconnect, that kill, that send, and we will look at these also in the future videos. And here we have some properties, which is child connected, channel, PID, which is a process ID. You have the standard in, standard out, and standard error. These are the streams that will be in that child process. And the standard IO, that's an array that essentially contains those streams that we just talked about, standard in, standard out, and standard error. But you can also add additional streams to this array in case you want your child process to have access to it and do something with it. All right, so this is an introduction to the child process module. In the next video, we will essentially start talking about the child process that spawn. And with that function, we are going to see how we can start a new child process with a specific command, and we'll see how we can have it do stuff for us on our computer. All right. I'll see you in the next video. Bye. Hey guys, this is Dooley. In this video, we are going to continue talking about the child process module in Node.js, and today we'll focus on the spawn function, which will allow us to simply create new processes by providing a command, some optional arguments that could be flags to this command or just arguments to that command, and optionally provide an options object, which will sort of tell the child which directory it should be started in, what sort of variables or environment variables are available for it to start with. What sort of relationship it's going to have with its parents, whether the parents can send message to it or it can send message to its parents, and whether the streams, the STD IO, the standard IO stuff of the parent will be shared with the child and so on. Okay, so I have here pulled the child process object from the child process module, and I also have an object here I call progs, which essentially has as properties, 3 commands that I'd like to play with in this video. All right, so the best thing you can do with this one function is simply create a child process by simply providing a simple command, and the one we're going to play with for now is the list command. So let's go ahead and do that. So let's create a child. So what we're going to do, we're just going to call this spawn function, and we are going to provide the command that we want to run. Oops. Okay, so let's go ahead and run that. See what happens. Nothing. Well, that doesn't mean nothing is happening. What that means is something's happening, but we're not seeing it. And the reason why we're not seeing it, if you think about it for a little bit, when you start a node process, when you say node and then file name, what you'll do, you will start a process. And once you start a process, your program will be running within that process, and your program will have access to the environment that process provides and resources within that environment. And some of these resources are the process standard R, the process standard in, the process standard error. When you print something and you say console.log, what's happening is you are taking some data and you are piping them through the process that standard out stream. So this child process, when it's printing something, it's also printing to that standard out stream, but its own, not the process that this parent process has access to. So the way you access that standard out is by getting that property on that child process. Okay, so the way you do that is you get that right here. So it's a property on the child process, and because it is a stream, we can listen for data events. So what you can do here is get that data. So data events when they're fired, they will emit with that with the data object there. Okay, so what we can do, we can log this to the console. All right, so let's do some interpolation here. Data is going to be data. I don't want 4 here. What I want is $1. All right, so let's run this and see what we get. Now you can see that I get a copy of, not a copy, but the list of all the files that are in this current directory. And you can see, there are 6 files in here, and as we know here as well. All right, so what else can we do with this? All right, so we can provide some additional arguments. So what we're essentially doing here is just this. Okay, we're listing all the files in this directory. All right, so if you know this command, you also know that you can provide the flag A. And what the flag A does, it will print all the hidden directories and files that are in this directory. All right, so the same way, you can provide this flag in here as well, in the array of arguments that you can provide here. So let's go ahead and do that. Okay, how is this going to behave? Let's run the program, and you can see you get the same thing here as well. So you get the hidden current directory and the hidden previous directory in the hierarchy in there as well. All right, so you can also, by providing some options, dictate where this child process runs. Okay, you can say I want this child process to run in the previous directory, in the hierarchy. All right, so we can run that again, and as you can see here, we are getting outside of the directory we're working in, and essentially what you're doing is ls a and then the previous directory. So you can see you're essentially getting the same thing here. All right, this is the same result. Okay, one other command we can play around here is the long command, which will give us the permission, the creator. Actually, I printed something else. Let's do that. Okay, so we get permission for the user, how big the files are when they were created, and the name of the file. All right, so essentially what you're doing here is ls long, and then we are printing it in the previous directory in the hierarchy. All right, so these are some stuff you can do with Spawn. Now, what if there are issues? Okay, there could be some issues. What if what you provide here is a directory that does not exist? Okay, let's see what happens. If you do that, nothing happens. Right? Obviously, nothing is not happening. There's something happening actually. Okay, so what we are effectively calling is ls bug. Okay, we're getting an error if we run this in the command line. So we should have gotten an error here. Now the reason why we don't get it is because when errors occur, they're printed to the standard error stream. Okay, so what we need to do is listen for data events on that standard error stream of the child process. So let's do that. Okay, what we're going to get is p dot and have this spawn function create event that gets so you will also get error is going to occur. So it's going to tell us which could dictate which. Hey guys, this is Dooley. In this video, we are going to continue talking about the child process module, which is the module in NodeJS that allows you to create child processes in your Node program. But today we will focus on the exec function, which is somewhat similar to the spawn function we looked at in the previous video. And as well, it allows you to create child processes. Okay, and as you can see here, what it will take as arguments is a command that's a string. Optionally, it will have some options. That's an options object, and a callback, which is a function to have it done, to have some function get fired after the child process exits. Okay, so let's go ahead here and do the simplest thing we can do with the exec function. Let's just create a child process, just passing in one of these strings here for a command. All right, so let's go ahead and do that. Let's create a child. Okay, what we want to do is cp.exec. Okay, so that's going to execute the command that we provide. That is the command. We want to progs that, let's say, remove. Okay, remove. Okay, so what do I want to remove? Now, unlike the spawn function where you have an array that you can provide for as, that will contain things like flags and arguments for the command that you provide, here you simply have to provide a string as a command. So the whole string will contain all these arguments and flags. So, all you're going to do here is just provide these as a concatenation here. All right, so I want to remove a folder. Let me put in this flag here, which will tell the remove program to go recursively inside that folder. And the folder I want to remove is CSS. It's got nothing in it, but it should work. So let's go ahead and just run this. Okay, so what this will do here, actually, no. Okay, node.js, that is our file, so let's run this. The expectation here is that CSS function will be removed. CSS, not function, but directory. And as you can see, it did remove it. All right, so this is even simpler than using the spawn function. All right, so what are some additional things we can do here? We can have a callback being called here for this child creation. All right, so when you create a callback for these functions, what will be passed in are 3 arguments. One of them is an error. Okay, that's an error object. Okay, the second one, it will be a buffer. That buffer will contain whatever data that was printed to the, that was piped to the standard output stream by the child process, and the standard error buffer, okay, which will contain whatever data was printed to the standard error stream for that child. Okay, so now it gives us access to all of them. So let's go ahead and do something here. Now let's check for an error. Okay, if there is an error, okay, I want to do something. All right, and if there is no error, I want to do something else. Okay, if there's an error, I'm just going to print something. Okay, console.log. Okay, let's do some interpolation. Okay, because this error object, this error is an error object, we can get some stuff from it. So let's get the name, which will usually be error. So let's just get that. So error, that name. Let's push in, and then let's get the message. Error that message. And then let's get the stack trace. All right, so we will get all this information when an error occurs. But when there is no error, I want to just log the buffer. That's the SD out, the buffer for that's coming from. Actually, I want to log this, please. Okay, so now since we don't have a CSS folder in here anymore, let's run this. What we expect is an error. All right, so let's see what we're getting for that error. Okay, we get the name, it's an error. We get the message, it says comment failed, rm-r CSS, no such file directory, which is what we expect. And then here we're getting the stack trace. All right, so let's go ahead and change this to something that exists. Public. Okay, this is that directory right here. It's got nothing in it, but we can remove it as well. So you can see now here it's being removed. All right, so this is using it to remove something in the directory. Let's go ahead and play around with the list function as well, as we did in the spawn video that we did. So let's go ahead and create a child here.
I think this is pretty similar to the way that a sys works on Python.
It's going to be cp.exec. Okay, let's provide a command. This is progs.list. Okay, what do I want to list? I want to list whatever is in the previous directory. Okay, now what I could have done is provide options instead. Okay, option cwd. Okay, we could provide a directory here instead. Okay, so we can remove this right here. And we don't actually have to provide a callback for now, so let's go ahead and run this and see what we get. We got nothing. That's because the callback needs to be again. So, let's just go ahead and not copy ourselves. Let's just put this in here. Error. SD out. Okay. Okay, copy that in. Let's remove these. Alright, so we can go ahead and run this and see what we'll get. Alright, so we will get all the files that are in that directory that we provided. Alright, what else can we do here? We can try and provide something that doesn't exist, but bub. Right, and then here again, we'll get our stack trace, name of the error, and the message that was in this error here. Alright, so this is the video, guys. We looked at how we can create child processes using the exec function. We've also done this with the spawn function, but with the exec function, there's slightly different ways of doing essentially the same thing. There's a difference because the exec function, I believe, is starting a shell, and then within that shell, run this command. That's not what the spawn function is doing. So that's a little difference there. Another difference is that in the spawn function, you can provide an array of flags and arguments, essentially an array of strings, which would contain these flags and arguments in order. But here you don't have that. So the string that you provide as command should contain all these things, except for the directory sometimes, because you can provide it in the options argument. Okay, and in this function, you can provide a callback, which is a difference from the spawn function. And that callback will get an error object with a buffer containing the stuff that the child printed to the std out stream, and a buffer for the stuff that the child would print to std error stream. And this is how you use the exec function to create child process.
Execution takes place one line at a time from top to bottom. And this execution is handled by the event loop. This event loop handles asynchronous network operations very well. Their execution is moved aside from the main thread to a different location and handled separately behind the scenes. Once it gives a response back, it's moved back into the main thread. I'll be making a detailed video on the event loop soon, so do subscribe for that. Now, when there's a synchronous block in the thread for an operation that takes up a lot of CPU resources, like say for instance encryption or decryption using a library like crypto, it's going to block further execution. Tasks like these need to be offloaded to a different process or thread to keep the main thread free. In this series, we'll be taking a look at a bunch of ways to achieve this so-called multitasking in Node.js, starting with child processes. Now, before even getting into a child process, let's understand what exactly a process is. So a process is not necessarily a node-specific concept. It's basically an instance of the program you run on a system. So whenever you run an application, for instance Chrome or a game or even VS Code for that matter, the running state of this application is called the process. Similarly, an application created in Node.js will also have a process when it's executed. When you create a Node.js application, you can get access to the process information by using the process object. It's globally available, so you don't have to require it manually before using it. So if I just console log the process object over here and try to run this file, you'll see all sorts of information over here, and all this information is associated to this process object. This object has details related to the application, the operating system, the device, and much more. I'll probably have a separate video specifically for this process object in the future because it's actually quite interesting. But for now, let's come back to multitasking. Now, there's a possibility that somewhere in your program you could have blocking code. This will stall the process when it's being executed, and we don't want that. So Node.js provides us with a module called child process, which can spawn up new sub-processes to the main or the parent process. By creating a separate process for a certain task, you're essentially offloading heavy operations, which in turn will avoid any blockage in your main process. There are essentially three ways to create child processes in Node.js: the spawn, the exec, and the fork methods. The spawn function will run a command in the process. After running the command, the data that gets returned from that command will be in the form of streams. This means that it's purely going to be asynchronous. Whenever a piece of data is ready to be sent back as a response, it will be passed to the standard output stream, and if there's an error by running the command, it will be passed to the standard error stream. Okay, so to use the child process module, actually to use the spawn function, you first need to import it from the child process module. So spawn acquire child process. This child process module, by the way, is natively present inside Node.js. Let's first try to execute a basic command. So we'll be listing a few files in the terminal using the dir command. So you normally use the ls command in Linux to list down all the files inside a particular directory. But since I'm using a Windows system, I need to use dir because that is how you list down files in a Windows system. Now if I go down, I clear the terminal, and if I run this, I will get an error. Now the error is a bit vague and you won't seem to understand it right away. The problem is, in case of Windows systems, you need a shell before you try to run certain scripts. This might not happen in case of Linux systems, but it does happen for Windows. So there are two ways for you to fix this. The spawn method, if you take a look at it, has some extra parameters. There's an options object here which takes a bunch of configurations. So inside the options object, I can just pass in a shell property whose value is going to be boolean. I can just set it to true. So this is one way of solving the issue. It's basically telling the spawn function to open up a shell and then run this command inside that shell. So now if I clear this and run the script again, now the error is gone, but I don't see anything. I'm supposed to get a list of all the files and directories in the folder, but there's nothing displayed on the console. This is because, as I mentioned earlier, the spawn method returns data via the stream API, so the data that we get is going to be in the form of chunks. So in order to know when a chunk is ready for us, we need to listen to the stream. The way we do this is by using the standard output stream for the valid response and the standard error stream for errors. So I'm just going to copy two lines here. This first line here is going to listen to any error bits that are coming from the standard error stream, and the second line here is going to listen to the output coming from the standard output stream. So let me just run this once again. And you can see that we are getting a buffer string here. So to convert this into a more readable format, you can just use the toString method on your data. So I just add this here and save it. Now if I try to run this, I get the valid response. That is how you normally run child process with the help of spawn. You should also ideally listen for errors that occur when the spawn function itself ran into some issue. So note this command here. The dir command, if it gives an error, that error you get in the standard error stream. But if the spawn function here runs into some issue, you need to listen for that as well. So the way you do that is by listening to the error event. So by using this line here, you can simply listen for any errors that you get by running the spawn function. I hope you understand the difference between this error and the errors that you get inside the standard error stream. Now what if you want to pass in arguments to this command? So you have an option here, which is going to be the second parameter. Inside this, you just pass in an array of all the arguments that you need to pass for this command. So in this case, let me just pass in the b argument, which is going to return a concise view of this listing. So it's not going to show you the time, the date. All it's going to show you is the name of the file. So if I run the script now, you can see that it just shows the file names inside this directory. So that's how you pass in arguments for your commands when you're using the spawn function. The problem that we had faced earlier with respect to the shell, I mentioned that there were a couple of ways to solve the problem. The first way that we saw was this options object. Now the second way of fixing this is by using the exec method. So let me just import it first from the child process module. This exec method might not look that different from the spawn method, but they indeed are very different. The very first difference is that exec will always first open up a shell and run your command inside that shell. So the fix that we had found for the spawn function, the options object where we passed in the shell property, the exec function does it by default. You don't have to pass in any shell property to the exec function. It will just open up a shell and run the command inside that shell by default. So I'll just comment this out and just type in exec. And we're going to separate command this time. So what we'll do is we'll try to copy the values of the file inside this script.js file into a new file. So I'll just have script.js first and dummy file.js as a second argument. And you can also observe that in case of spawn, you used to pass in the arguments inside this array over here, but exec has no arguments. It takes the whole command string as it is. Now, if you want to pass in arguments, you pass inside the command directly. So the command here is the copy command, and the arguments for this command are these two files. In case of Linux, you would normally use cp instead of copy. Just because I'm on Windows, I need to use the copy command. If I save this and I clear the terminal first, and I'll try to run the script. Again, I don't get anything here. Which brings me to the third and the most significant difference between the exec method and the spawn method. The spawn method used to return data in the form of streams, which is why we had to listen to the standard output and the standard error stream. So anytime we got a chunk of data from those streams, we used to display them inside the console log statement. Now in case of exec, what happens is behind the scenes there's a buffer storage. Inside the buffer storage, all those chunks are stored, and only when the whole response is fetched will you get the response. So it's going to store all the chunks inside the storage, and after that at the end it will return the whole piece of response together. So in case of spawn, there was no limit in the size of response because it was sent back in chunks. You could potentially get a huge response over a period of time. In the case of exec, it waits for the buffer to be filled first. Once it's filled, it will return the whole response back. But there's obviously an issue here because what if the size of the response is greater than the buffer? The application will simply crash if that's the case. So if you know beforehand that your response is going to be huge, you should opt for the spawn method instead of the exec method. Yeah, coming back to the code, instead of listening to the standard output and standard error streams like we did in case of the spawn method, we now get them inside the callback function. Inside the callback function, we have three objects: the error, the standard output object, and the standard error object. Now what we're doing here is we're handling three cases. The first one is the error, and this error is associated with the whole command. If there's a problem executing the exec command itself, then you'll be getting an error inside this block. While executing the command here, if there's an error, then that error will be stored inside the standard error object. And at the very end, if there are no errors, you'll be getting the output inside the standard output block. If I save this and I run the script, I get the response. It says that one file is copied. And if you take a look over here, you can see that there's a dummy file. If I open this up, it has the same data that I had inside the script.js file. So yeah, that's pretty much how you create child processes with the exec command. Now what we'll do is we'll try to run one command with the spawn function and the exec function and see how both of them return data. Now we have the exec function here and the spawn function here. Both of these functions will run the node command, so it's going to run the script here. The rest of the things is the same. In case of error in the statement itself, it's going to return the console log statement. Same for the standard error stream. In case of an output, it's going to return the valid response with the exec string over here. Same for the spawn method. Now we need to have this file present inside our directory. So I'll create that as well. This node file is a simple script. What it does is it has this interval variable over here. Inside this interval variable, we are setting an interval which is just going to console log the statement. So it's basically acting as a string. This interval will run for 5 seconds, and after that it will clear the interval. So this whole function will only going to run for 5 seconds. The time difference between each function execution of this interval is going to be 1 second. So you'll be getting this console log statement every 1 second when you run the script. So yeah, everything's fine. Now if I clear this and try to run the file. So as you saw, the time difference between each spawn console log statement was 1 second, but all the exec console log statements were returned together. So this is what I was trying to say. Spawn used to return the data in the form of stream. So anytime it got a value from the node module file, it only then returned the data from the standard output stream. But in case of exec, it stored everything inside the buffer, and at the end of the execution, the file execution, so after 5 seconds, it returned the whole value that was stored inside the buffer. So it had 6 console log statements inside the buffer. After the 5 second mark, it returned everything together. Let me just console log this for 1 second. In case of exec, I had mentioned earlier that there could be a potential problem if the response size itself is greater than the buffer size. In NodeJS by default, the size of the buffer is around 1 MB. So what I'll do is I'll just replace this with the console log statement and copy in a bunch of text which is going to increase the size to more than 1 MB. So I have dummy text inside this file now, and I for a fact know that it's more than 1 MB. So this should give me an error here when running the exec command. So I'll just clear this and try to run the command. I get the error saying that the max buffer length has exceeded. So yeah, that's what I was trying to say. The buffer size itself has a limit. So when the response that it's trying to accumulate over time is greater than the size of the buffer, we will come across this error. So what I run for this is that I could just simply pass in the options argument here again, and there's a max buffer property over here which can be manipulated. So I know that the file size is 3.5 MB. What I'll do is I'll just set it to 4 MB. And the way you pass it inside this property is in the form of bytes. So 1024 times 1024 is 1 MB, and if I just multiply it by 4, this is 4 MB. Now if I try to run this, I get the whole thing. So yeah, so this is one way of fixing the problem. Or let me just stop this for a second. If you run the same command using the spawn function, this will run right away because it gets the output in the form of chunks, so it's going to run as this without any buffer issues. Yeah, you'll see that it's running without any issues because the data that you get inside the spawn function is in the form of streams. There is no buffer issue, which is why you get the response as it is. What else can you do with these functions? If you want, I'll just comment this out. I'll just run exec because it's simpler. Instead of this node command, I'll just replace it with, let's say, type. So type basically reads the contents of the file. So if I run this, you can see that it basically printed the contents of this file itself. I can create directories using child process. So mkdir, test dir, and say this. If I run this now, you can see that there's a directory over here inside our folder. So that also works. If I want to run applications, I can do that as well. So start, let's say Firefox. If I run this, I get the Firefox browser window. So yeah, you can see the power that these two commands possess. You can do a lot with these two commands. You can run different kinds of processes and offload memory intensive or CPU intensive tasks to these child processes. The functions here are asynchronous, so they don't block the main thread. There are two more methods left that can be used to create child processes. One is the exec file method and the other one is the fork method. We'll take a look at them in the next video. If you have any doubts or suggestions, you can put them in the comments below, and I'll see you in the next one.
In the previous lecture, we understand how to work with stream in Node. In this lecture, we'll understand what is buffer. Buffers were introduced to help developers to deal with binary data in an ecosystem that traditionally only deals with strings rather than binaries. Buffers are deeply linked with streams. When the stream processor receives data faster than it can digest, it puts the data in a buffer. Stream in Node.js simply means a sequence of data being moved from one point to other point over time. The whole concept is you have a huge amount of data to process, but you don't need to wait for all the data to be available before you start processing it. A simple visualization of the buffer is when you're watching a YouTube video and the red line goes beyond your visualization point. You're downloading data faster than you're viewing it, and your browser buffers it. You can think of a buffer like an array of integers, which each represent a byte of data. Let me show you a very simple example to understand what is buffer and how to work with it. So I'm going to simply create here a variable constant buff is equal to and call a buffer class here. And from this buffer, I'm going to call a method from, and here I'm going to specify hey. So this is kind of string. Now just like that, down here I'm going to say console.log, and in the parentheses, I'm going to say buff.
Alright then gang, so I made this video just to let you know that I finally
save the changes and execute this file. When I execute this file, I'm going to have the result something like this. So as I said earlier, buffer is like an array, so you can access it using square bracket. So down here I'm going to say console.log, and I'm going to just call buff, and in the square bracket, I'm going to specify 0 to access the first index of this buffer array. I'm going to save the changes and execute this file. As you can notice, I'm going to have 72 as a result. Here we have 3 numbers. These 3 numbers represent this string, and this 72 represent this first edge character. These numbers are the unique code that identifies the character in the buffer position. So here's the buffer position, and we have the edge character at this position. So this statement will print the unique code of this edge character. So it will print 72. Let me just duplicate this statement and change this index. I'm going to say here 1 and 2. Save the changes and execute this file. You can notice here I'm going to have 101 and 121. So you can notice here H has unique code 72, E has unique code 101, and Y has unique code 121. Now let me show you what happens if I try to print this buffer using toString method. If I just say here dot toString, let me show you what would be the result. Save the changes and execute this file. As you can notice, I'm going to have this message as a result. So this buffer is going to print this message using this toString method. As I said earlier, buffer is going to take the data as binaries. Now you can notice we call a buffer class and call the from method of buffer class to create this buffer. Now if you want, you can write to a buffer a whole string of data by using a write method. Let me show you. Let me just get rid of this method right from here, and I'm going to call here a method allocate to allocate a memory for the buffer. So here I'm going to specify 4, and using the buffer.write method buff.write, I'm going to write my buffer. So here I'm going to say, hey, like this. We allocated the size of this buffer 4. So we specify here 4 characters inside this write method. Now, just like that, let me save the changes and execute this file again. I'm going to have the same result. So using this technique, you can also write your own buffer. Now you notice you can access the buffer using array index. You are not limited to only access the buffer index. Just like you can
Hey guys,
access
and welcome to
the
your very
buffer
first
array syntax, you can also set the content of the buffer in the same way. So down here, I'm going to say buff, and to the first index, I'm going to specify 1, 1, 1. So this is equal to O. So this is the unique code of O. Now let me just print this buffer. I'm going to console this down here. Save the changes and execute this file. As you can notice, I'm going to have O at the first index of this buffer. So I hope you understand how to work with buffer in Node. Next, we'll talk about what is exception handling.
Yo, Sammy Campus, welcome to your first lesson of the best Node.js tutorial series on the planet. Okay then. Yo, Sammy guys, welcome to your third Node.js tutorial, and in this video I'm going to talk a little bit about the V8 engine. Alright then, so we can fully understand how Node.js works. I want to dive under the hood a little bit and talk about the different components that it's made from. And the first one is the V8 engine. Now, the V8 JavaScript engine is at the heart of Node.js, so I do think it's worthwhile knowing a little bit about it and how it works. So first of all, what is a JavaScript engine? So when we write JavaScript, the computer itself does not understand it. It takes a JavaScript engine to convert that JavaScript code into machine code, something that the computer can't understand, so that it can be processed. Okay? So it looks something like this. We have machine code right here at the bottom of the stack, and that is what computers run on. It's what they understand. But it's very difficult to program in machine code. It looks an absolute mess and you don't know what's going on. So then we started to abstract away from it using different languages. We have assembly language, which sits just above it, but still very much like machine code. Then we have something like C++ or C, and these are really popular because they abstract away quite a lot, but they still remain a lot of power. And then finally, we have things like JavaScript, which sit at the top of the pile and abstracted a lot away from machine code. So when we write in JavaScript, we need a way for it to be converted into machine code for it to understand what we want it to do. So Node.js itself is actually written in C++, which might seem a little bit flawed first, since it's all about writing in JavaScript. But here's the distinction. Node.js itself is written in C++, but as a program, it allows us to write JavaScript which can run on a computer or server. Okay? And the reason that Node.js is written in C++ is because it uses the V8 JavaScript engine created by Google, which is also written in C++. So we know that Node.js is written in C++, and we also know that at the heart of Node.js is the V8 JavaScript engine, which converts the JavaScript that we write into code that the machines understand machine code. So if you do want to read a little bit more about V8, then you can come to the developers.google.com website /V8, and you can see here it says that V8 is Google's open source high performance JavaScript engine written in C++ and used in Google Chrome. So it's also the JavaScript engine that's run in Google Chrome. So when we create JavaScript in Google Chrome in the browser, then V8 is used at that point too to translate it. Okay, and you'll see down here that you can see it says it can run standalone or be embedded into any C++ application. So we know that Node.js is a C++ application, and what it does is take V8 and it embeds it into Node.js. So how does Node.js work with V8? Node.js is written in C++, right? And V8 is embedded into it right there. So when we write JavaScript and we read through Node.js, it's passed into V8 and converted into machine code which the computer can understand. Now V8 is just a part of the Node.js C++ core, and there's other parts of Node.js written in C++ too. So what do they do? Well, the rest of the C++ in Node.js hooks into the JavaScript V8 engine, and it adds additional features to it. So initially, JavaScript was designed to run in a browser, and it wasn't meant to deal with low-level operations, but C++ was, So it's far more powerful than JavaScript. So Node.js, which is written in C++, hooks into the V8 engine, and it extends it in such a way that passes on these additional features to JavaScript, such as reading and writing files or connecting to a database. So this is what makes Node.js so exciting, the fact that we now have been given much greater power with JavaScript that we didn't have before, and therefore it enables us to create server-side code in JavaScript, which is really cool. So I think I'll do now for V8, gives you kind of a rough background of what it does and how Node.js works. Any questions? Drop them down below. Otherwise guys, I'm going to see you in the very next tutorial. Yo, Sammy guys, welcome to your fourth Node.js tutorial, and in this video I'm going to talk about the global object. Okay guys, when we write JavaScript in a browser, the global object is the window, right? The window object. And we can access properties and methods on that window object, such as alert, scroll, or set timeout, etc. Now, when we write JavaScript in Node, the global object is no longer the window object because we're not in a browser anymore. The global object in Node is an object called global. But much like the window object, it gives us access to some methods we can use straight out of the box in Node.js. So I'm on the Node.js documentation right here, and I'm looking at the global object, which lists all of these methods we can use on it. So we can see things like set interval and set timeout and console, which were also available on the window object in the browser. And they're also available on the global object in Node.js, plus some other stuff as well.
Good afternoon, this is Tina. How are you doing? We're going to talk about a buffer. First, I want to share a little bit about why do we need a buffer, right? When we just write plain JavaScript, which is the JavaScript execute inside the browser, most of the time, we are just working with the string values, like grab some information from a form or read some data in the DOM. All the values can be represented using the string and in the Unicode in character set, right? And most of the time, UTF-8 should be enough, right? So string works fine in the browser JavaScript, but when we do the Node is designed for the server-side programming, right? And which means you have lots of features or scenarios. You might need to work with the file system. You might need to work with the images, files, and the database connection, all kinds of, not limited to the string. So, which means you might need to work with the raw binary data. Sometimes it's fine to use the raw string values, but it won't work with most of the cases, and it's not that efficient. And that's why we need a buffer, okay? Buffer is designed to work with the raw binary data. And so each buffer is going to have a raw memory location outside of our V8, okay, memory location. And most of the time, we probably want using the buffer, this kind of like a class alone, because when we use buffer, sometimes most of the time we will coordinate or use together with the string. Like, suppose we want to read a file, right? If the file is very, very big, we don't want to read the entire file as a string value returned at once. We want to return a little bit, and that a little bit of chunk is using a buffer. This is how we're using buffer most of the time with the streams, or we can using the buffer with the HTTP request response. Those is also a stream, okay? But in this demo, I just want to show you if you really want to using raw buffer, and we have the buffer provided some ways to do that, and I'll just show you some very basic demo, okay? We're using buffer demo.js, okay? And suppose you want to have a raw buffer, okay? Just create a raw buffer one, okay? Equals, you can using buffer this class dot allocate, okay? And you give how many like bytes you want, okay? If now I print out, this one means 8 byte. And now I go to buffer, sorry. Okay, then node buffer demo.js. Those are using 000, okay? So it will print 8 bytes of 0 for you. This is it's gonna be represent a raw memory location, okay? And suppose you want to, you can also get a buffer from you can get buffer from some like integers, okay, like 1, 4, 6, 7, 2, 8, 9, like this. And now when we print, it also gonna be represented using the buffer too. You want to see, it also print the 8 byte. Okay, this is each is 1 byte. And also you can get a buffer using the buffer from, and here you can give a string value. And most of the time, in Node, you are using UTF-8 as the character encoding. Okay, so when you read, you will know it's gonna using ATF-8. It also supports for other character encoding, but UTF-8 is the most popular or common used one inside Node. And all of them gonna be represented using this one is each of the character gonna using the UTF-8 to represent that. And if you want to get that, you have to using buffer.toString. .log buffer3.toString value. Okay, you will get it exactly. And if you want, you can also pass character encoding. Which character encoding you're actually using. Okay, so that's it for the buffer, because most of the time we probably want to using the buffer alone, and most of the time we're using with the stream. So when we will give some example later when we're using stream and buffer together. Okay, so that's it for the buffer. Thank you for watching, and see you next time. Bye bye.
I think I'm gonna take my headsets off and put the other thing on, because I think I'm just gonna watch all these videos and not do anything else. And then if I want to talk about something, I'll go back to the headset.
Welcome to your 13th Node.js tutorial, and in this video I'm going to talk about streams and buffers. Okay, now before I talk about buffers and streams, I've got this true story I want to tell you. So there was this guy who lived in the woods, and one day he came across this huge Node.js candy rock. So he decided, hey, I'm going to move this big rock to my house so I can feed it to my kids. Now this guy's pretty strong, but even he knows that it would take him an absolute lifetime to drag the whole thing at once to his house. He can move it really slowly, and he knows he's going to get pretty impatient because, well, they're really fast. But he has this light bulb moment, and he figures out how he can easily transfer all of the rock back to his house quickly. So the week before, he just happened to build a travelator. So he puts it to good use and sets it up between this huge candy rock and his house. And he figures if he hacks away the rock with a pick and gathers a small heap of candy at a time into a cardboard box, then empty that cardboard box onto a travelator, it will all get to his house bit by bit. And the best part is, the kids can start eating the rock as soon as the first heap arrives. They don't have to wait for the whole lot to be transferred first. So, what the hell does a mountain forest with a giant candy rock have to do with streams and buffers? Well, this story actually has a lot of similarities to the way that buffers and strings work. So first of all, what is a buffer? A buffer is just a temporary storage spot for a chunk of data that's been transferred from one place to another. So if we have a large amount of data we want to move from point A to point B, then we can move it a little bit at a time by gathering a small amount of it in a buffer and then moving it on. So we're transferring small chunks of data at a time. So it looks something like this. We have all of the data here, and you can compare this to that candy rock in a story. And we want to get all of this data from point A to B. But instead of waiting for all of that data to be stored in memory, what we do is we transfer a little bit at a time and we fill up this buffer, okay? Which is a temporary storage spot for that data. The
How is it going, everyone?
Data. And then when the buffer is full, the data can be passed on and processed, okay? So we know what a buffer is, but what is a stream then? And a stream is pretty much that. It's just a stream of data that flows over time from one place to another. So we have some kind of data source over here, and we're transferring that to the client. And the data flows down this stream into the buffer, right? Which collects a small chunk of data together. Then when the buffer is full, it passes that chunk of data down the stream to be processed and sent to the client. So you've probably heard about streaming moves online, and this is buffers and strings in action. We have a mover, which is all the data we need to transfer since you want to watch it all, but we don't wait for all of that moved data to be sent in one go before watching it. We just wait for these chunks of data to be sent or to arrive, and then we can press play on the mover. And we generally say we're waiting for the mover to buffer, right? So you can see the benefit of this whole idea of streams and buffers right there. We can start consuming data even before it's all arrived. We don't have to gather all of the data in memory first and then consume it. We can do it bit by bit. So why am I telling you all this? What on earth has it got to do with Node.js? Well, we can create streams to read and write files in Node.js, which, because of the way streams and buffers work, can increase the performance of your application. And that's also true when we're dealing with requests on our Node server and we're sending data back to the client to be consumed. So this all ties in together. So now we know how streams and buffers work, we're going to go ahead in the next tutorial and we're going to create some streams and see how they work in Node.js. I'll see you guys.
In this lecture, we'll be taking a look at the buffer object.
Usually, whenever we receive data from a file or from some other stream, like from a remote server, that data cannot be natively used by JavaScript. In order to make it consumable, we have to convert the raw data into usable format, and for that, we make use of the buffer object. For instance, we have a file over here, and you can see that it's sample.txt file, which is just having one line. Now, if I go ahead and try reading it out in the REPL environment, so here, I'll type node and press enter. Inside this REPL environment, I'm making use of file stream read file, and you can see that I've passed the name of the file, that is sample.txt, and a callback function, which is having 2 parameters, error and data. Then we are simply logging the data, and now if I press enter over here, you can see that some kind of buffer is coming up. Obviously, this data is not human readable, and it's not of any use to us if it's in this format. In order to resolve this, what we'll be doing is we'll modify the log that we have over here, console.log. Now you can see that we have updated it, and the console.log now contains data.toString. Now let's try and execute this function. And here you can see that the same line is printed, which we have over here in our file, sample.txt. There's one more way of achieving the same, and that is by specifying the file encoding. So we'll go over here. Here you can see that just after the file name, we have specified the file encoding. Over here we are saying UTF-8. Notice that the console.log now contains just data, not data.toString. Now if I press enter over here, you can see that we're getting the same result all over again. There are certain methods available to us when we make use of the buffer object. We'll be exploring those now. The first thing is we can write to our buffer by making use of the write method. For instance, if I go ahead and create a new buffer in this fashion, here you can see that we are simply specifying the buffer size by mentioning it just after the constructor. That is, the buffer will hold 10 characters. Now if I go ahead and write it over here, something, so we'll say buffer.write, and inside this, let's write hi node. You can see the length coming up as we executed that line. And here if I say buffer.toString, you'll get the value. Now, if I have to overwrite something in the same buffer, I can simply specify the position. So I'll say buffer.write, wow. And then 2, for instance, press enter. And here, let's check this out now. So you can see that the position starts with 0, 1, 2. That was the space here. You can see that it's not having the wow word inserted just after second and next position. Now if I go ahead and also specify the length of character that needs to be written, so I'll say buffer.write, let's say now, 2, 1. In this case, if I execute this and print it again, you'll see at second position, it has just inserted the word N. The OW remains from wow. And the last alternative to this one is by specifying the file encoding as well. The default encoding obviously is UTF-8, so you can specify it over here in this fashion, press enter, and then you can check it out over here. There's some functions available like compare, equals, that we'll be exploring now. So if we have some buffer objects like this, and let's have a couple of more over here. So we have created 3 buffer objects, buffer E, buffer X, and buffer Y. Now if I go ahead and say buffer E equals buffer X, if you see buffer E is 12 and buffer X is also having the value 12, so this should return true, and equals returns true or false, not some integer value like 1 or 0. Now let's go ahead and check out the compare. So the compare method will return an integer value. Here we are saying buffer E, compare buffer Y. Buffer E is 12 and buffer Y is 10, so obviously you'll get a value 1 which says not matching. If I go ahead and change this to buffer X, and then execute this line, you'll see a 0 coming up, which means that buffer E and buffer X are equal. Next we have slice method in our buffer object. So here I'm creating a new buffer object which has this content hello node, and if I have to slice it out in this way, buff slice equals buffer n dot slice 0, 2. Press enter here, and now if I go ahead and say buff slice dot toString, you'll see the characters coming up as H and E over here. Now, whenever we make use of the slice method, we are not creating a new buffer object. Rather than that, we are simply pointing to the same buffer that we created earlier, that is over here. It's pointing to buffer n, and it's just taking that 2 characters into account. So if I go ahead and make some modifications to buff slice, and then if we check buffer n, the changes will be shown there as well. Let's check this out now. So here if I say buff slice dot write, and here instead of he, let's write hi, semicolon. Now let's go ahead and check it out, the content of buff slice. So obviously it will say hi. But if I go ahead now and say buffer n dot toString, remember we had buffer n as hello node, but now if I go ahead and check it out, it's saying hi hello node. So you can see that the reference was there when we made use of the slice method. So that was buffer object in Node.js.
This video, I'm going to discuss buffer in Node.js. So make sure that you have Node.js installed and open your text editor. Save one file with name sample.js. Okay. You can also use REPL to execute your code. Simply type in node and you'll have REPL access. Okay. You can use .exit to exit from it. Now, inside your sample.js, type in var buffer equals to new buffer. So here we set, let's say, size of 10 for buffer, and we can type in console.log for that buffer's value. Let's find out what output we get. And here you'll find some random text with buffer size up to 10, 3, 6, 9, and 10. Okay. So the next thing is we will see how to pass on arguments to your buffer. So for that, simply change your buffer constructor to get arguments. So in square brackets, type in 1, 2, 3, 4, and 5. Okay. Now open command prompt and execute the code again. you will get the argument passed to the buffer. Okay. Similarly, you can also pass string. Simply remove this and have strings such as node.js. Now, if you execute the code, it will put some random data instead of showing that string. Okay. So for that to show properly, you have to pass encoding as well. Before that, let's take a look at some encoding. So type in console.log, then buffer.eats encoding, and we'll check if it has UTF-8. Okay. Now open command prompt and execute the code, and it will say true. Now, what if you want to check encoding as ASCII? In that case, simply execute the code again, and it will pass as true. Now, how about hex? So hex will also give you true, but what if you don't pass anything? In such case, it should return false. Okay, so this is how you can check whether the encoding for your buffer is supported or not. Okay, now what we're going to do is we're going to write one string here. So type in var string1 and create new buffer, and here we will give length of up to 15, and we will write to that string with, let's say, node.js and encoding as UTF-8. Okay, so if you execute this on REPL, then you will get the size of your current string. However, if you execute with directly as node and then your sample JS file, then you have to use console.log to print the content of your string. Okay, and here you'll find it will print you the message with some random text. Okay, now what if you want to convert your content of string? In such case, you use string.toString. So simply type in str1.toString, and for this method, you pass on UTF-8. So it should show you the content of your current string. Okay, so let's just remove this and let me make it interesting, and you'll get Node.js tutorial as content of your string. Okay, similarly, you can also specify which part of a string you want to display from 0 to, let's say, 7. So you can print that out. So just Node.js. If you go for, let's say, up to 15, then it will print out entire Node.js tutorial as string. Okay, so this was our short video on how to use buffers in Node.js.
Web dev video. So I want to give you a quick overview about how do you deal with node, stream, and buffer object. Let me give you some background information. I've been using Node for a while. I work now to build my REST APIs, and I haven't really ran into a use case for using streams or buffers that often. Turns out that when you start dealing with really large files, like files that are over 512 megabytes, you can't just read them in with a typical fs.readfile sync, right? You actually need to read them in chunks and process them in chunks, or else your Node application could crash due to not having enough memory, etc. So if the term stream or buffer is something that you've seen in Node, but you actually haven't really seen a real life use case for, stick around in this video because I'm going to show you it. But before I dive into the actual real life use case I'm going to show you, be sure to click that like button because it helps my channel grow, and also be sure to click that subscribe button if you want to see more videos like this in the future. All right, let's just go ahead and jump right into it. And again, I don't really have this is just like one use case, but there's probably a lot of other use cases for using streams and buffers. So the best use case I could kind of show you, there's kind of two aspects of streams, right? You can do something called a write stream and you can do something called a read stream. So what I'm going to do is I want to show you what happens if you try to write out a ton of data to a CSV file, right? So I have a loop here that basically just loops through 1 to e to the 8. What is that? 1, 2, 3, 4, 5, 6, 7, 8. Is that like a billion? So that's 100 million. 1 e to the 8 is 100 million. So I try to write out a CSV with 1 to the e rows, right? So that's a lot of data. And so this is like a gig worth of data. I can kind of show you that if I do a du-h. I can show you have an output file here called LCSV, which is about a gig worth of data. So this is a pretty big file. And I want to show you a use case to why you want to use streams to write this file. So if I run this, I'm going to say node write slow. What you're going to notice is after about a minute or so, this application is actually going to crash because it runs out of memory. And the reason this runs out of memory is because it's trying to create 100 million strings and put them in an array called data, right? So Node is going to kind of keep tacking that onto its memory, and at some point, Node's going to run out of memory. And you can kind of tweak Node to allow it to do this, maybe not crash. But also there's an issue here. There's only so much data you can push into this write file sync as well, so it could be crashing here. I just wanted to show you, like, this is a real life use case. Let's say you need to create a CSV file with a ton of data. You can't really do it this way because your Node app is not going to be able to handle it. So you see here the app crashed. You go up here, it says reached heap limit, blah, 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 JavaScript out of memory. So this is the issue. When you start dealing with really large files, you can't just read it in with a read file sync or write file sync, etc. You have to kind of change your process. You have to change the way you're doing it. So this is why you need to do something called a write stream. So if I open up this file called write streams, I have an example of how this is done. So basically what's happening is we're going to create something called a write stream to this out.csv file. And kind of the same approach as the other file, we just loop through 100 million records. But now what we do is we just write this kind of string to the write stream. Okay, so this is kind of going to be converted to a buffer behind the scenes and pushed into a write stream buffer. And behind the scenes, Node has like a buffer that's filling up as you're writing this information, and it's going to hit a certain point where you put too much stuff in the buffer. Right? I believe it's called like a high watermark or something. So I don't really know all the nitty-gritties about streams, but I think what happens here is when you create a write stream, behind the scenes there's like a buffer that Node is using, and as you keep writing strings to that buffer is going to fill up. And at a certain point, there's enough data written in that buffer that the Node runtime is going to say, okay, I need to take this chunk and I need to actually write it to my file. Okay, and there's something here over here when the buffer fills up called a high watermark, and when it reaches that point, Node is basically going to kick off the write and push that data to the file. Now the reason Node does this is because file IOs are really slow, and you don't want to write data constantly to the disk. You want to wait till you have a good chunk of data, and then Node's going to write that to the disk. So you have this whole like high watermark thing implemented with the buffer. So the issue with this code though is that if you just keep pushing data into that buffer, the buffer ends up just filling up and using up all the memory on your computer, right? So you need to actually tell this program, hey, wait until you have reached your over watermark flag. So when you do a write call like this will potentially be true or false. If it's true, that means you need to wait until Node flushes the buffer and basically writes all that to the file. So if you hover over this, it says returns true if the internal buffer is less than the high watermark. Okay, so if this is true, that means you can keep on writing data. If it's false, that means you need to wait, and you need to wait until the stream emits an event called drain. Okay, so I know this can be kind of confusing. We're kind of learning about like event emitters as well, but typically in Node or JavaScript there's something called events, and you can do something called an event emitter where you can just emit events that other pieces of your application kind of listen for. we're basically saying just listen for the drain event to fire, and when it's done, we can basically no longer have to pause. Okay, so this is just like a pause logic that says if watermark is false, we need to pause, wait for that buffer to be flushed, and get reset back to 0, and then we can keep on writing data to it. So if I run this, it'll take a while, but it actually writes all that data out to that out.csv, as I showed you earlier, which has about a gig worth of CSV data. So that's basically an overview. I know it's a really quick, bad overview of what a write stream is. Sometimes you want to use this in Node when you're dealing with large files, and I just want to kind of give you that overview so you understand like the purpose of it. So in the CSV, what we're doing is we're writing a bunch of like indexes that are incrementing, and then also we have a comma and a 1. So hopefully you understand what a CSV file is. It's just like a file that has a bunch of rows in it, and then it has data in columns. Hey everyone, welcome back. The program that I wrote is I wanted to try to read in that CSV and just sum up the second column, right? So if I go to read slow, let me show you this. This is like an implementation of how you typically do it in Node if you're a beginner. You read through this, you'll notice that we're doing a read file sync on this file, and we're splitting up the lines by new line characters, and then we're turning out the new lines. We're taking off the header of the CSV because we don't care about that. And then we just basically sum up all of that, those ones I talked about, and this should print out 10 or 100 million if we did the sum calculation correctly. So let me show you, if I try to run this, you'll notice that the application just crashes, right? And you get an error saying cannot create a string longer than whatever this is characters. So again, you've reached a limitation in Node where Node can't read in this file because it's too big, so you cannot do this approach. And then secondly, this approach is actually kind of slow, it's not really performant, just reading in all that data into memory at once. What you need to do instead is use something called a read stream. So let me show you some other code over here called read streams, and let's just read through this. This is actually kind of more complicated. When you're dealing with strings, when you're dealing with read streams, you typically have to write code that is going to parse through your data and not crash because the data comes in chunks, right? You don't know where in the CSV file is going to like clip it. So you have to actually write some additional logic to like concatenate incomplete records together. So let me just kind of walk you through this. I don't know if it's going to be a good overview, but so a better solution from the read slow file is we are doing a create read stream, which is going to create a read stream on that file here. Remember, this file is like a gig worth of memory or a gig worth of data. And then basically I'm just going to create a sum, a variable to count and increment the sum as we read through that each row in the CSV. And so read stream again implements an event emitter, so I can say .on data. And behind the scenes, Node is going to keep on reading that file and giving you chunks of data, right? So you might have a gig worth of data in the file, but when you read it, you're going to get a chunk maybe of like, I don't know, 100 megabytes or 50 megabytes. You can actually change that up here by passing a second argument. But once you get that chunk, what I had to do is I'm basically taking that chunk, which is going to be a buffer, and I'm converting that buffer to a string, which you'll see here, chunk string. And then we loop over the chunk string, and we have to do some like lower level logic in JavaScript to kind of look through it to figure out where the new line characters are. And when we found a new line character, that means we found a line. And then we have to kind of split that line up to find the first comma. And once we find the first comma, we can kind of take that second value out. Remember, there's like a 1 that I'm pinning in all the rows. So we get the 1 out, we convert it to a float, right? And then we just basically sum it up. We kind of keep doing this logic over and over as we loop through the CSV. And at some point, the CSV is going to be chunked up in a way that you don't have a full complete row. So we had to do like this unprocessed array up here and just keep track of like any line that wasn't fully ending with a / new line character, which we kind of do down here. But all in all, I just want to show you that there's like something called a stream and a buffer that you can use to kind of process this file. So let's just go ahead and run this real quick. And I'll show you in about 10 seconds, it's actually able to run through that gig worth of CSV data and print out a sum of 100 million, I believe. All right, so it took about 10 seconds or so, but now you see it printed out the sum. It basically looped through the file. It summed up the second column of that CSV, and it ends up being 100 million because that's the amount of rows that we kind of outputted through that CSV file. So some of the main issues I ran into with this project is like figuring out this logic here can be kind of convoluted and complex because again, like the data you're getting in is chunked up in arbitrary pieces. So you don't know if the string that you got here is actually a full row in a CSV or not. And sometimes it's not. So you have to like keep track of where in the data this stuff go wrong, where is it split, and then kind of keep track of that and append it later on. So when you're dealing with streams, stuff can get kind of complicated. That's why it's probably better not to deal with these unless you really need performance or you have to do them because your files are too big. But yeah, I don't know if this overview is good at all. It's probably super confusing. But if you enjoyed watching this video, give me a thumbs up. And also be sure to subscribe if you want more videos like this in the future. That should hopefully help you become a better web developer. And also leave me a comment below if you've used read streams or write streams in your day-to-day.
Hey everyone, what's up? This is Marcos with Future Studio University. Welcome to this Node.js tutorial on how to increase the memory limit for your Node.js process. You know, Node.js starts and allocates every process with a specific amount of memory, and if you're doing memory-intensive tasks like loading a lot of data into memory, you might run into the JavaScript heat out of memory exception, which means the process gets killed, the server stops, and you can't proceed with the actual calculation. So what you are interested in is to increase the memory limit and to increase the heap space. And let us go into this little package that I've prepared to actually show you how to increase and that the Node.js memory limit increases. So let us just walk through the packages. I'm using V8 because Node.js uses V8 as a runtime, and the memory limit is caused due to V8's memory limit. So you're actually increasing the memory limit of V8, not Node.js, but indirectly it's Node.js because, you know, V8 is the runtime of Node, and, you know. So you can use the V8 package, which is part of the Node.js runtime, and you can get the method for get heap statistics. And you know what? Let's comment this block, and let's print on the command line what you get when console log this method. Okay, I'm switching to iterm, and let me show you, no, what is it? Show memory limit. Okay, you can see different values. The total heap size is this amount of bytes, and there are different other sizes. The total available size is the one we're interested in. And you can see that's this amount of bytes divided by 1024. Again, 1024, now we are kilobytes, megabytes. So you can see that we are close to almost 1.4 gigabytes. Okay, let's comment this one again. I can just go back. So you can see that I'm using the total available size from the get heap statistic method, and I'm dividing it by 1024, 1024, 1024 to get the gigabytes, and I'm just using the to fix method to round it and not have the tail with after the comma. So
we're using the total heap size in gigabyte and the total heap size in bytes, and cancel both values using the string literals in JavaScript and to print them on the console. So let's start this one again. I'm jumping back to iterm and starting again. Okay, now you can see the default memory limit for the process on my machine is this amount of bytes, and it's 1.39 gigabytes. So now you're interested in how to increase the memory limit, and we will definitely go there now. So you can use the max old space size and path a value like 4096 to path 4 gigabytes of space. So let's see if it increases. And yes, you can see that it's around 4 gigabytes. And you know, if you're not having that much of memory, because my MacBook just has 8 gigs of memory, let's pass 16 gig and let's see if it's available. So you can see that you can override the default memory limit of 8 by using the flag for max old space size. And you can pass it with dash dash max old space size equal sign and then the value of megabytes that you want to increase the value. Alright, so actually that's it. You can verify that the value for the heap size actually increases when passing the max old space size flag to the Node.js process. I hope you like this video. Give it a thumbs up if you do. Subscribe to the channel for more videos on Node.js and specifically on HappyJS, web framework, and check out the playlist in our channel. Enjoy your day, enjoy coding, and make it rock.
All right, so I think it's time to get started. All right, so hi everybody, my name is Ali. I work at Google. And I get to work on Node Core. I'm a member of the Node Technical Committee, and I also work on Google Cloud, and I get to make Google Cloud one of the best places to run Node applications. So today I'm going to talk to you about memory leaks. So I'm assuming you have some idea what a memory leak is. If you don't, this is what it looks like. Memory up to the right. So if this was your stock, you'd be really, really happy. But yeah, that's a memory leak. This one is a slow one. You can see over several days something's leaking. So it's not a nice one. Sometimes they're really fast, and very soon your application just goes to boom, and then bad things happen. Maybe your manager beats down your neck and says, fix this. All right, so let's just first dig a bit deeper into what a memory leak really is. And this is the definition that Wikipedia has, and I don't like it that much because it's confusing. Memory that is no longer needed is not released. But what does release mean? Because, well, we have garbage collection. We don't have to free memory ourselves anyway. So what gives? So the contract that garbage collection has with you is that anything that is actually garbage, stuff that you're not using, stuff that's not tied to the ground, is garbage. And anything, like, yeah. Actually, I like this video because that mailbox was not garbage. Okay, so taking this metaphor and looking at your JavaScript objects, if you're holding onto a JavaScript object, and what do I mean by holding onto a JavaScript object? If you have an object that points to another object, the first object is holding onto the second one. If the first object is not garbage, the second one is not garbage. So if you have a global variable that has an object inside it, that object is not garbage. That's the contract GC has with you, and anything that's garbage, it will sweep away. It's just like having a Roomba, one of those robotic vacuum cleaners. You throw stuff on the ground, it'll sweep it up. But if it's actually not on the ground, it can't sweep it up. All right, so how many people have actually had the opportunity to go debug a memory leak? Was it fun? So, okay, so I mean, it would be better if you don't write memory leaks to begin with. And I have 3 steps to do that. First, don't write code. Don't go from use code from anybody else. Yeah. Okay, I'm joking. So I think it's important to understand what memory leaks are and how they manifest in your code. I think if the goal is never to have memory leaks, that's hard. I'm not saying it's impossible. It's very, very hard. And chances are the application you're running with Node, maybe a small part of it is code that you actually wrote. There's probably 5,000 NPM modules you're using that who knows who wrote. They may have memory leaks. And then there's other stuff that may have memory leaks. So I think what's more important is understanding why memory leaks happen, and even more important, being able to debug, having the tools that you have experience with that will let you debug those memory leaks. So I'll go through some examples. In this example, this is like a very simple express request handler. The hello overlap you do with express, but I'm allocating a really big array inside this handler. And it's garbage because I never do anything with it. But this is not a memory leak. Why is it not a memory leak? Because GC can see that you're not using this anywhere. You're not holding on to this object that you've allocated, right? There's nothing that would prevent it from being garbage collected. So you run this, it's not really fast for you to allocate this object unnecessarily, but it's not a memory leak. Okay, so better example. So I'm actually holding on to the garbage now. So I put the garbage in the request object, so this should leak memory, right? Okay, this isn't a memory leak either because you have to look at the request object. When your request is done, it comes into Express. Express gives you information about this is what the user wanted, and you send a response back. And when Express knows that you're done with it, it throws away all references to the request object. So the request object is garbage. Anything that only it refers to is also garbage. If on the other hand, if you take this array and store it somewhere else as well, in addition to request.garbage, then it will be different. Then we have to look at where do you store it. Is that thing garbage or not? So this is still not quite a memory leak. All right, so the key insight, or one of the necessary conditions, is about expected lifetimes. Right, so when you have an object and you think this should only live for a short amount of time, so this is an object I've allocated, and I think it's short-lived, and then you go store it into an object that's really long-lived, then that might be a memory leak. And another thing to note here is it's about expectations, right? So that's why memory leaks become a bit fuzzy, because you're working with a bunch of APIs, and what was the contract you had with that API or that module that you're using? Whether if you give it an object, are they expecting it to be, like, is the contract that they're going to hold on to it for a really long time, or is the contract that they'll just use it and never keep a reference to it? So that's why it becomes tricky, right? That's why it's hard to avoid memory leaks, because you have to really understand how your objects are going to be used. Okay, so one more example. This is a bit contrived, but I want to actually show you a memory leak. This is most definitely a memory leak because I have a module global map. So there's an object on the outside requests, and every time a single request comes into my server, I throw more stuff into that object. The outermost object is going to live forever, so now you are actually leaking all the requests that come in. So this will quickly run out of memory. So on my laptop, I can handle probably 15,000 requests per second in a simple express server. So this 15,000 requests will be leaked every second, so this will run out of memory really fast. Which is good because then you'll know right away that something's wrong. So, okay, so this is a slightly less contrived example. This is actually taken from Stack Overflow. So there's a memory leak in here. There might be some object allocations. There are some object allocations in here as well. The obvious one is the object literal that we have, content type JSON. That object is not leaking, right? Because that object is passed on to response.writehead, and we have a contract with that function. That is not going to hold on to that after the request is done. What is actually leaking is actually the same problem as before. The client is a top-level object. Client.on, what is the contract of the on function? The contract of the on function, this is what I meant better, by the way, is that if you give it a function closure, closure is the right term, but you give it a function that you define in a line, that basically makes a closure, that's an allocation. And it may have storage associated with it. And the contract it has is that whenever you give me a function, I'll put it in a list. And whenever that particular event happens, I will call this function. So you're doing it every single time the request hits your server. Right? So you're allocating a new closure every single time. This is going to leak memory as well. So this one looks like a typo. This code shouldn't be inside the request handler. Seems like it should have been at the top level. That's my guess. But yeah, so this will leak. All right. So now things are getting tricky. So this a small program. You can run this in Node today. This program, the only thing it's doing is looking at how much memory it's consuming. It's doing nothing else. And this program will increase its memory footprint as you run it. It will run out of memory eventually. So this is not quite obvious because I actually don't see an allocation right there, right? So and actually there's an aspect on the leak. It's debatable whether this is a leak. This is a thing that JavaScript doesn't like anyway. So what happens here is that we're tying down the event loop. This is a synchronous loop, right? This is not waiting. This is going all the way to run on the same tick. What console.log does underneath the covers is it's going to allocate some closures and say on the next tick do something, right? But the next tick is never going to come. Okay, actually it will eventually come, but after a very, very long time. So this will leak memory as well. So the thing is, functions that you call may leak memory, and you have to understand what they do. So this is an interesting example, but leaks can be totally unexpected. So take this code, run with the latest version of Node 8.x, but don't panic, this is getting fixed really soon. 8.7 this will be fixed. And also this is a very specialized condition that most likely is not happening in real apps. So this will leak memory, but not right away. It runs stably for about 2-3 minutes, and then it just goes like copies and leaks memory. So what's my point here is that the code you might have that's running correctly today might leak memory in the future because something else has changed, or the conditions under which your application is running change, that now you suddenly have a memory leak. So it's great to understand that object lifetimes, and when I have a long-lived object and I store a short-lived object inside it, that's a memory leak. But it's even more important to be able to debug memory leaks. Right, so for debugging memory leaks, let's talk about some of the tools that I have available. And so whenever I look at these tools, for Node, there are a few questions that I'm asking myself. What kind of leaks can it find? Can I use this in production? Because that's the thing I fear the most, right? Leaks that I can catch in development are usually the easier ones. The things that make it to production are usually the harder ones. And if a tool that I'm familiar with doesn't really work that well in production, that's a problem. So those are the questions I'm asking. I'm actually going to focus more in this talk. I'll cover native leaks and JavaScript leaks as well, but my main focus is JavaScript leaks. Because I'm guessing most people are interested in JavaScript. Most people are writing JavaScript, and that's what you care most about. So first question, when you're leaking memory, where is it actually leaking? Okay, let me go back 2 slides. So in this case, this is actually quite ironic. This is a leak in the V8 garbage collector. So the garbage collector itself is leaking memory. So the problem was that the V8 garbage collector is quite awesome actually. It is quite adaptive. It's trying to figure out what your app is doing. It's coming up with a heuristic that this would give you the best performance for your garbage collector. You won't be interrupting you won't be incurring as much latency if you work this way. And there was a bug that was existing in that heuristic, and that's why this leaked memory. So this is a native leak, right? This is not a JavaScript leak, but your application may still experience this. So that's what I mean by native leak. And there's some tools available for debugging native leaks as well. And then, at the outermost level, the most basic level, you need to, I would guess you have some monitoring in your production applications that basically is showing you a chart that basically shows how much memory you're actually consuming. So, or maybe it's just the top command you have on your next machine or the task manager that just shows you memory usage. Those are the first set of tools to look at when your application is behaving weirdly. So, if you are not going to use any other tools, this is the most basic thing that you can have. This has 0 dependencies. Okay, I'm lying, there's 1 dependency, but that's just for formatting numbers. So you don't need anything. You just put this in your application. It will just keep spitting out how much memory it's actually consuming, and you can have a running tick off what's actually happening in your application from a memory point of view. So this is nice. Actually, there's some modules. One is called memory usage by Tom Swatton right here. That actually is really nice. Actually plots it. So it makes it even nicer to use it. The challenge might be that one may not be as suitable to run in production because it opens the browser page and shows you the data. So this stuff is the most basic thing you can have that gives you an idea of how your application behave. So let me cover a few topics. Let me cover what this actually tells you. It tells you what the resident set size of your application is. The resident set size is how much RAM your application is consuming. This includes anything that V8 is using. This includes anything that Node core itself is using. It includes anything that any other library that Node uses, or any other native module that's running as part of your application. Or if the Postgres, for example, Postgres module that you're using, if it's allocating objects that are C++ objects, those would all be in the RSS. So if your RSS is going up, you probably have a memory leak. Actually, I should define that and say if the resident set size is going up and you don't expect it to go up, that's when you're likely to have a memory leak. Heap total is the total amount of memory that you have available for JavaScript objects. The way the garbage collector works is that at any given time you have some JavaScript objects, but it grows eventually until it reaches the heap total. And at that time it decides whether maybe it was too short a time in which I was able to deplete all allocated heap space, so maybe I need to grow the total heap size. So this is a really good metric of how much space DC thinks you need for JavaScript objects. So if you have a memory leak in JavaScript, you would probably see this number going up as well. Heap used it's a bit more variable because it goes up and down as garbage collector works. So you can look at that as well, but heap total is probably a good enough metric to look at. And then there's external, which is interesting. So this is any memory that Node core is allocating for objects that it needs to connect between JavaScript and native side. So if you have, let's say, a buffer, this would go into the external memory. So V8 reports this as well. So this is interesting as well. And later on I'll come back to how. So if your overall external memory is going up as well, that means maybe you're leaking a buffer or some other wrapper object that Node core is using. Okay. So now let's say now you know that you have a memory leak. What are you going to do about it? So this tool, heap snapshots, has been available for a very long time. There's almost any memory leak tutorial that you look for on the internet for Node. It's probably going to talk about heap snapshots. So I'll give you a fairly fast overview of what this thing is, and then I'll move on to some brand new things that are now available. So I'll actually do a demo for this. So heap snapshots. So this is your Chrome DevTools. You can run node-js inspect, and you can attach DevTools to it. And so basically normally you probably see it like console resources, but this is the memory tab. And you can actually take a heap snapshot of the current running application that you have. I'm not going to do that right now. I have taken a heap snapshot that I saved earlier. And the interesting thing is you can save these snapshots as files on disk, and then you can load them back up and you can view them. So I'll cover a few things that are being shown here. It's telling you right now, all the objects that existed in the JavaScript heap, every single one of them, and what they look like, who was holding on to that object. Remember I said that something is not garbage if something is holding on to them, right? So if you expect something to be garbage, this will tell you why that thing is, who's holding on to that thing, making it not garbage. So, and just looking at this, let me increase the font this once. So just looking at this, you can notice that there's lots of objects, and the constructor that allocated the object is the first one, and this is the number of objects of that constructor that exists. So looking at this, you can right away tell if there's a memory leak, and then this object thing looks very common. If I sort it by count, seems like something that's just an object literal is leaking. Shallow size is the amount of memory that specific object is, and retain size is all the memory that objects reachable from that object have. So let me drill down a little bit. So each of these entries is an individual object that existed on your JavaScript heap. Right? These are right now live in memory in your JS application. Now let's just look at one of them. So when you click on one of them, or expand them, this actually shows you what the object has. It's actually showing you the internals of the object. It has a map, it has the proto, and it has one property called URL. And looking at some of these other objects in here, you can see most of these objects are this one. So right away you know this is the leaking object. So can you tell me which object, like where the leak might be? Well, you know what the leaking object looks like. You don't know where in code this object was allocated. And if you're really familiar with your code, right? If you just by looking at the object, it has a special property name that you know only one place in code adds, then you have a pretty good idea where the leak is. But that may not be the case in all cases. In this example, I have no idea. I have no idea where this object was allocated because the map was huge and I didn't write all of it. And yeah, I know there's a leak and the leaking object looks like this, but I don't know where it is. In more real-world examples, you won't see such a stark contrast, right? So you won't see like this one object type is so predominantly common, right? You have lots of other object types. So what do you do in those cases? Well, there's a really nice comparison view. You can say compare this log with this other log that I captured, let's say 30 seconds later. And it actually tells you the delta. Like, we have this many fewer objects of this type and this many more objects of that type, right? So this can give you an idea of over time, this is what's increasing, right? So this gives you a better signal for what actually is maybe leaking if there's too much noise. And again, I have some links to this, these slides so you can actually find out that probably won't even finish. And it is getting memory. That's why it optimizes things quite a bit in production. Non from Netflix, it's a really great talk. It talks about the...
I mentioned that node applications.
You might have heard people talk about this concept called
are highly scalable, and this is because of the non-blocking or asynchronous nature of node. What do I mean by asynchronous? Let me give you a metaphor. Imagine you go to a restaurant. The waiter comes to your table, takes your order, and gives it to the kitchen. Then they move on to serve another table while the chef is preparing your meal. So the same person can serve many different tables. They don't have to wait for the chef to cook one meal before they serve another table. This is what we call non-blocking or asynchronous architecture, and this is how node applications work. The waiter is like a thread allocated to handle a request. So a single thread is used to handle multiple requests. In contrast to non-blocking or asynchronous architecture, we have blocking or synchronous architecture. Let's see how that works. So back to our restaurant example. Imagine you go to another restaurant, and in this restaurant, a waiter is allocated to you. They take your order and give it to the kitchen. Now they're sitting in the kitchen waiting for the chef to prepare your meal. And this time, they're not doing anything else. They're just waiting. They're not going to take an order from another table until your meal is ready. This is what we call blocking or synchronous architecture. And that's how applications built with frameworks like ASP.NET or Rails work out of the box. So when we receive a request on the server, a thread is allocated to handle that request. As part of handling that request, it is likely that we're going to query a database. And as you know, sometimes it may take a little while until the result is ready. When the database is executing the query, that thread is sitting there waiting. It can't be used to serve another client. So it is a new thread to serve another client. Now imagine what would happen if we have a large number of concurrent clients. At some point, we're going to run out of threads to serve these clients. So new clients have to wait until free threads are available, or if you don't want them to wait, we need to add more hardware. So with this kind of architecture, you're not utilizing our resources efficiently. This is the problem with blocking or synchronous architecture, and as I explained, that's how applications built with frameworks like ASP.NET work by default. Of course, in ASP.NET, it is possible to use asynchronous architecture, but we have to do extra work for that. In contrast, node applications are asynchronous by default, so we don't have to do anything extra. In Node, we have a single thread to handle all requests. When a request arrives, that single thread is used to handle that request. If we need to query a database, our thread doesn't have to wait for the database to return the data. While the database is executing our query, that thread will be used to serve another client. When the database prepares the result, it puts a message in what we call an event queue. Node is continuously monitoring this queue in the background. When it finds an event in this queue, it will take it out and process it. This kind of architecture makes Node ideal for building applications that include a lot of disk or network access. We can serve more clients without the need to throw in more hardware. And that's why Node applications are highly scalable. In contrast, Node should not be used for CPU-intensive applications like video encoding or an image manipulation service. In this kind of applications, we have a lot of calculations that should be done by CPU and few operations that touch the file system or the network. Since Node applications are single-threaded, when performing the calculations to serve one client, other clients have to wait. And that's why Node should not be used for CPU-intensive applications. It should only be used for building data-intensive and real-time applications. Okay, enough theory. Next, I'm going to show you how to install Node and build your first Node application. Hi guys, it's Mosh here. Thank you for watching my Node tutorial. I just wanted to let you know that this video you've been watching is part of my complete Node course where you'll learn everything about Node from basic to advanced topics. If you're serious about learning Node, I highly recommend you to enroll in my Node course because this is much faster than jumping from one tutorial to another. It saves you time. Plus, you're going to get a lot of exercises that will prepare you for the real world. And also, at the end of the course, you'll receive a certificate of completion that you can provide your current or future employer. So if you want to enroll, click on the link in the video description. I hope to see you in the course.
So what is wrong with this write file sync line here? Well, it's the sync keyword. I earlier mentioned that there also is a write file method, but we use write file sync. The sync here stands for synchronous, and this is a special method which will actually block code execution until this file is created. Now, working with files is available in two modes. Here is the synchronous mode. We block execution of the next line of code until this file is done. Now, for this short of a text we enter, this is super fast and we won't even notice it. But think about a huge file, a couple of hundreds of megabytes or even bigger. If you do something with that, read it, copy it, whatever it is, and you block the code execution, then the next line and all the other code will not continue to run until that file operation is done. And even new incoming requests of other users would not be handled until that file operation is done. And you don't want that. Therefore, you should not use that syntax here. You can if you know you'll only have a very short file operation, but even then, it's better to use this write file method here, which actually does not just accept the path and the data, but also a third argument. And that is again such a callback, so a function that should be executed when it's done. So here again, just as with create server, Node.js implicitly registers an event listener for us. So here I pass another function, and this callback here actually receives an error object, which will be null if no error occurred. But if some error occurred, missing permissions or anything like that, you would get it here, and you could then handle it gracefully by returning a different kind of response, an error response, showing to the user that an error occurred, and otherwise return a normal response. Now here I won't do error handling, and there is really nothing that could go wrong here. We'll of course dive into error handling a bit more later in the course, but I will move my normal response code in there because this response should only be sent if we're done working with the file, because that is ultimately the action we want to do upon our request, right? So now we actually have our event listener with some method or function that will be executed once we're done parsing the request, and in that function that will be executed sometime in the future, we have yet another event listener, this nested function here, which will be executed once we're done writing the file. And this is actually pretty standard for Node.js. You have this event-driven architecture where you basically tell Node.js, please do something, and it will then go ahead and offload that process to the operating system, which does use multi-threading and so on, and will then continue its event loop to listen for event callbacks, and always just dispatch tiny actions like that to never block the code execution, and then always just come back once an operation is done by the operating system and so on. So this is what Node.js does here, and why it is high performant, because it never blocks your code, it never blocks the server, it just goes ahead and tells the operating system, do that, do this, and then eventually comes back and does something in the callback, like send a response, which is not a blocking operation because this is super fast, just a couple of headers, and off you go. So I hope this is clear, and with that, let's restart this by quitting the server, rerunning node app, and going back to just/nothing. Let's enter hello again here and send. And the message text, we see that, again, concatenated with an extra character, not something we have to worry about right now. So you see, write file also works, but this is the way you should use it due to the asynchronous nature of Node.js, which I hope now became clear, because it is a crucial concept of Node.js, and one you absolutely have to understand. With that, let's wrap this module up with these core basics, and let's from now on move to a more easier route where we...
You might have heard people talk about this concept called non-blocking I/O and how Node uses it to run super fast. But what is non-blocking I/O and why does it help? That's the question I'll be answering today. Along the way, we'll explore how servers handle requests and the differences between CPU-based workloads and I/O-based workloads. If none of what I just said made sense, then this video is for you. So buckle up and let's go. By the way, I'm going to assume you have just a little bit of software engineering knowledge, just a little bit. First, before getting to Node, let's talk about servers and threads just as an overview. A server is a thing that receives requests, does some work to compute a response, and sends it back. Oftentimes, there are HTTP servers that serve websites and HTTP APIs, but other protocols are also possible. For example, when you visit google.com, you send an HTTP request to a Google server, which computes the HTML response that you should see and sends it back to you. Then your browser displays the HTML on your screen as a website. Inside a server, one or more threads divide up the work in between them. A thread can be thought of as a single worker that does work. A single-threaded server has one worker handling requests, while a multi-thread server might have multiple ones handling requests at the same time. We can explore this using a restaurant as an analogy. Here is an infrequently visited restaurant with just one waiter. Because it's not super popular, parties tend to come in one by one. The waiter serves each party before moving on to the next one. If we capture this in an animation, here's what that might look like. Time goes from left to right, and each row represents a party. As the waiter finishes up one party, they either wait for more customers or move on to the next one. This analogy actually works really well to describe servers. The restaurant we just talked about is just like a server that infrequently receives requests and has one thread. The one waiter is like the one thread, and the requests are like the parties that come in. Let's imagine now that two parties enter the restaurant at about the same time. You might think that one waiter can only serve one party at a time, but that's actually not the case. While a party is looking at the menu or eating or waiting for their food, they generally don't need help, but the waiter can ping-pong between tables and help both at the same time. Here's what that might look like. I've now broken up each table into parts when they need help in dark blue and parts when they don't need help in light blue. So first, one party comes in, so we help them, and then the other party comes in, so we switch to helping that party, and we ping-pong between them as each needs help. But what about now, when both parties need help at the same time? The waiter can only help one of them, so the other one has to wait a little longer than if they were the only party. The time spent waiting is highlighted in red. Key insight here is that one waiter can serve multiple tables at the same time because each table has some downtime. In real life, you've probably noticed that restaurants you visited might only have one waiter for every 3 tables, or even one for every 6 to 8 depending on how casual the restaurant is. All of what we've been talking about actually applies to servers and Node.js too. Just like a table only needs help part of the time, request processing also has a part that requires active attention and a part that does not. The part that requires active attention is called CPU work because it requires the central processing unit of the computer to actively spend time thinking and computing results. CPU work requires a thread to handle it, just like a table that needs help requires a waiter to handle it. The part that doesn't require active attention is called I/O, which stands for input-output, because it involves waiting for something else to provide input or to send output. Examples of I/O include waiting to read a file from the file system, waiting while making a network request to another server, or even just waiting for time to pass. In the restaurant example, we relate things like looking at the menus at I/O because the waiter is waiting for something else to finish. In short, CPU is active computing or thinking, I/O is waiting for something else to happen. To make things more concrete, let's look at a pseudocode example for a server that receives a request, computes some prime numbers, posts them on Twitter, and sends a link to the tweet back to the caller. All the work the server has to do is expressed in this function, handle request. First, we compute the primality of some numbers in this section. Next, we choose a random prime and build our tweet. These parts are both CPU work. Then, we post the tweet on Twitter, which is I/O work. Specifically, the I/O work is between when the server has sent the request to Twitter and when Twitter responds. Here's the exciting part. Just like a waiter can save time by switching tables whenever a table doesn't need help, non-blocking I/O allows a thread to save time by switching requests whenever a request is doing I/O. This greatly increases the amount of effective work that a single thread can do. The non-blocking part means that while a request is doing I/O, the thread is not stuck or blocked waiting for the request to finish. Blocking I/O, on the other hand, means that the thread is stuck or blocked waiting for the I/O to finish before it can keep going. Here is what the timing diagram might look like if we were doing blocking I/O. There's a lot more red, which means a lot more waiting and unnecessary latency. In the restaurant analogy, that would be like if the waiter says, "Hi, I'll be your waiter for tonight," pulls up a chair and sits there while you read the menu, wait for your food, eat your food, and only leaves when you do. Not only is that super weird, it's also a huge waste of time for the waiter. You might be wondering, why isn't non-blocking I/O the standard? It just seems obviously better or more efficient. Well, when web backend development first became popular in languages like Perl, PHP, and later others like Ruby, Python, etc., the language model didn't easily allow for non-blocking I/O. It's possible in some of these, as well as in others like Rust, Go, Java, and Scala, but depending on the language, it can sometimes be inconvenient or off the beaten path. As an alternative, folks use servers with blocking I/O and lots of threads to handle high traffic. Node.js was written because the creator wanted to make non-blocking I/O easier to adopt, and JavaScript was a great fit because of its emphasis on callbacks. Let's wrap up by talking about some of the downsides of non-blocking I/O. The foremost one is that it's only effective for I/O-heavy workloads. In workloads that have more I/O work than CPU work, the efficiency gain from non-blocking I/O is much higher, as you might expect. On the other side of the spectrum, if a workload is predominantly CPU, then the non-blocking I/O won't help very much. This is especially important when working with Node.js servers because they only have one thread and thus will get bogged down quickly if subject to CPU-heavy workloads like this one. It's akin to a restaurant with just one waiter. If someone calls the waiter over for 5 minutes to talk to them about something, that's 5 minutes guaranteed that everybody else has to wait if they need help. That's why Node excels for applications like sending lots of network requests, but isn't as strong for other applications like machine learning, which involve a lot of CPU-heavy number crunching. I hope this is all helpful. Let's recap. First, the work of fulfilling a request can be divided into CPU work and I/O work. Second, servers handle requests using threads, which each independently handle requests. Third, non-blocking I/O allows the thread to put down a request while it's performing I/O to work on a different request's CPU component. Fourth, non-blocking I/O allows Node.js to efficiently handle I/O-heavy workloads despite having only one thread. As always, thanks for watching, and please like, comment, and subscribe. You can also do me a huge favor by sharing this video with anyone who could benefit from it. See ya!
Back, and in this one, we're going to talk about blocking or non-blocking. So if you go to the About on Node, it's going to give you some information about Node, what it's doing. It's very important to know what Node is and everything else. I would say it's an easy read, through all of this, but it just gives you some examples, some information about, again, how Node works. So if you go right here at the bottom, it says there's no contrast, blah, 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 and it says thread-based networking is relatively inefficient and very difficult to use. Now, furthermore, users of Node are free from worries of deadlocking the process. Now, this is a very important word, deadlocking. It says it seems there are no locks. So no, it's saying that Node gives you no locks. Now, almost no function Node directly performs EOIO, so the process never blocks. And again, the keyword blocks. So they're repeating the same keyword over and over. So it must be important because nothing blocks. Again, scalable systems are very reasonable to develop in Node.js. Now, right here, they give you a full article so you can understand what blocking and non-blocking is. Now, if you don't know what it is, if you know what it is, you know, right? Maybe you don't need to watch this section. If you don't know what it is, don't worry, because I'm not going to give you some weird explanation with words. I'm going to show you a chart just to show you what this is, right? So because again, this is one of the most important features of Node. Now, we need to define what blocking and non-blocking is and what I/O. So I/O is input and output. I guess I didn't need to explain much on that one. It's just input, data comes in, and then data comes out. Very simple. Now, of course, I'm going to show you a chart just to explain the blocking and non-blocking. Okay, so let me show you this chart so we can learn the difference between blocking and non-blocking without, fancy words. So let's say that we have a JavaScript file in our server that we execute, okay, in our server, Node server, and we have 4 different types of operations, right? We have a varable location, then we have a network request. We're going to do a network request that goes to a database to get some data, right? So to the DB, let's say Mongo. Then we have another network request, and then we have a function that we will execute. Okay, so let's go in order. Let me show you what's going to happen on the blocking side of things. So the server starts, and of course the computer is going to read our JavaScript file. So first it's going to go and say, okay, so we have a URL with a location, right? Then it's going to, of course, keep reading the JavaScript file from top to bottom. So it's going to say, all right, so we need to make a network request. I believe it's just for getting some data. So the application will go to this network request. It's going to go right here. It's going to go to the database, and let's say that the database is a little bit slow that day, so it's going to take like 10 seconds, right? That's what's going to happen. So whenever this action is done, it's going to send the data back, right? And of course, it's going to keep reading the file. So we have the data, so let's keep reading. So we're going to find another network request. So this is going to go to the database. Remember, the database is super slow, so it's going to be another 10 seconds, and then the data comes back, and then we can move forward. So we execute the function. Okay, so maybe you cannot see the problem with this. So this is blocking. So let me just explain it again. Okay, so again, we are going to run the JavaScript file. Of course, since this is JavaScript and it's just a variable, it's just going to do it super fast. Then again, we need to do the network request. So remember, the database is slow, so it's going to take 10 seconds before we can move forward and do some other things. And that's why it's blocking. It's going to block the next execution of code until this one gets resolved. And that sucks because maybe again you're just entering to a web page and it's using this blocking for the server, and the server keeps loading and loading and loading until you get a response from the server. And again, it's just 10 seconds, 20 seconds, whatever you want to call it. It's a long time. And imagine if you enter to a web page and you need to wait 10 seconds for everything that happens. It just sucks. So again, it's going to go wait 10 seconds, then come back, and then of course at the end of this operation, when you get the data back, then you can move forward to the next one. And since you have another network request, same thing's going to happen. It's going to go. We'll start. It's going to read the file, and of course it's going to say, oh, it's just going to keep moving forward, execute the function, and keep asking, is it done? And execute the code. Different actions that run at the same time. No, not at all.
Hello, and welcome to Section 4, Asynchronous Programming. In this section, we will learn asynchronous programming, which is a very important programming technique in JavaScript and Node.js. We will look at why Node can achieve a very high I/O performance through the event loop. Then, we will tap into callback functions and the error first pattern. Finally, we will learn the basics of async.js and promises. Now we move on to the first video of this section that deals with the event loop. In this video, we're going to take a look at the single-threaded concurrency model of Node.js, which is based on non-blocking I/O operations. We will also learn how to set delays in a Node program. Asynchronous programming is a paradigm in which the flow of the program is determined by events. For example, mouse clicks, key presses, and incoming requests. Typically in a computer system, input and output are the most expensive operations. The system needs to wait for the I/O operations to be complete, and hence, it's called blocking I/O or synchronous I/O. They involve waiting time, which is usually the performance bottleneck of the system. We all know that Node is a very high-performance server. What makes Node.js so popular and different from others is that it uses event-based programming model and non-blocking I/O operations at its heart. Node takes an approach that serves all requests from a single thread, known as the event loop. When Node receives a request from a client, it will put the request into an event queue. The event loop runs indefinitely to retrieve a request in the event queue. In one case, if a request doesn't involve a blocking I/O operation, Node will simply process and prepare the response and send it back to the client. In another case, if a request requires blocking I/O operation, Node will delegate it to a worker thread in printful to work on the blocking I/O operation. The blocking I/O operation may be associated with a callback function. When the blocking I/O operation is complete, the worker thread will prepare the response and send it back to an event loop, which then runs the callback function and sends the response back to the client. Therefore, the main program is not blocked by the I/O operations. So, Node keeps a single threaded event loop for our code, and everything else runs in parallel. That's the secret why Node has such a high I/O performance. Go to the terminal, create a new project folder, 4.1, and change to it. Run npm init. We simply accept all defaults. Switch to Sublime Text and open the project folder that we just created. Create a new file called index.js. We're going to make a program to test the asynchronous nature of Node. Type in console.log, the first statement. Make another, make the third one. Run the program. It seems that the program statements run in sequence. Node comes with a function called setTimeout, which can delay the execution of a piece of program code. The first parameter is a wrapper of the code to be delayed, and the second parameter is the time to be delayed in milliseconds. Let's apply it to the second console.log statement with a delay of 2 seconds. Run the code again. The behavior of the program is different. We have the first and third statement displayed before the second statements. Why? Because we added a delay to the second statement. The second statement is now a blocking operation, and the first and the third are not. The event loop simply executes our code asynchronously, and so the first and third non-blocking code run without waiting. And then after 2 seconds, the second statement comes back. With the setTimeout function, we can assign how long the delay should be. Think about the cases that we can't estimate how long blocking I/O operations could finish. It seems that we can't control program flow, right? We will have answers to this question in the next video. In this video, we have learned that Node has a single threaded event loop running indefinitely to serve a request. We also wrote some code to test the asynchronous behavior of Node.
In this example, actually, we are talking about how the event loop is executing the instructions. Okay, so this is the event loop, and we will be writing some asynchronous code like this. We are creating a server. So this is a basic example in the Node how to create a server. HTTP equal to require HTTP, then HTTP.create server, and we are listing that on 3000 port. So what is the event? What will be the event on the request? Request, whenever you are sending a request from the client, that is also an event. So request is a known event. So response is also an event because you created a server at the Node.js side. Now what will be the event? So that the response, when this event is fired to the server will respond something to the client. So that is the request is an event name. So simple hello is running on some server on some port 3000. Request callback executed. So that inside event loop. So once the event, another picture. Now this is the code which we are.
This is asynchronous IO in depth. My name is Thomas, and today we're looking at finite state machines and methods. If you watched some of the last videos, we built an HTTP server with a registry. We played around with threads, spawning processes, child processes. We played around with different ways to handle those requests without actually doing any kind of non-blocking IO, but we were still able to kind of create a little bit better performance for our application that way. If we want to go a little bit further, we're going to actually need to start doing non-blocking operations. So if you're a little bit familiar with what happens in a software interrupt or even a hardware interrupt, you have this idea of kernel space and user space. So whenever an interrupt happens, whether it's hardware or software, the CPU actually needs to decide how to switch between those modes. So what it'll do is it'll actually save the registers, whatever's currently on the register of the CPU, process the interrupt, do some kind of scheduling, and then restore the context and return whatever it was doing before. This is what it might look like on the process, right? So we have the kernel stack for whatever the process is. You've got the user stack data, heap, and some instructions, right? And then depending on what your level of access, so the kernel has the most privilege, and then the outer ring would be our applications. This is kind of the privilege rings, so to speak, of the CPU architecture. So kind of like why is this relevant? Why do we care about this? The whole idea is that the CPU is already kind of, then the outer ring would be our applications. So what it'll do is it'll actually save the registers, whatever is currently on the register of the CPU, process interrupt, do some kind of scheduling, and then restore the context and return to whatever it was doing before. This is what it might look like on the process, right? So we have the kernel stack for whatever the process is. You've got the user stack data, heap, and some instructions, right? And then depending on what your level of access, so the kernel has the most privilege, and then the outer ring would be our applications. This is kind of the privilege rings, so to speak, of the CPU architecture. So kind of like, why is this relevant? Why do we care about this? The whole idea is that the CPU is already kind of doing this idea of handling interrupts and responding to events and everything. And we don't want to create extra work for it by continuously polling and asking for things that maybe it's not ready yet. So we already know that the operating system and the CPU kind of work together in this sort of event-driven way. So within the operating system, there are actual APIs that are event-driven that we can take advantage of to do non-blocking operations. Things like epoll, KQ for Mac environments, and even IOUring, which is some of the newer APIs around asynchronous communication that kind of allow us to work with the OS and coordinate with when interrupts happen without kind of suspending our work. So if you get a network
Welcome back. Let's now learn all about the event loop, which is the heart of the Node.js architecture. And this is probably the most important lecture in this section, so make sure you really understand everything that I show you during this video. So let's get started. So here's a diagram similar to the last lecture, so let me know exactly what we're talking about here. So we're still in the node process in a single thread where the event loop runs, alright? Now, the first thing that you need to know is that the event loop is where all the application code that is inside callback functions is executed. So basically all code that is not top level code will run in the event loop. Some parts might get offloaded to the thread pool as you saw in the last lecture, but it's the event loop that takes care of all this. As I said before, it really is the heart of the node architecture.
Okay, now as I mentioned many times in the first part of the course, Node.js is all built around callback functions. So functions that are called as soon as some work is finished, sometime in the future. Remember that? And it works this way because Node uses an event-driven architecture, which is something we're going to talk about in one of the next videos. But what you need to know for now is that things like our application receiving an HTTP request on our server, or a timer expiring, or a file finishing to read, all these will emit events as soon as they're done with their work. And our event loop will then pick up these events and call the callback functions that are associated with each event. Okay, make sense? So again, the event loop receives events each time something important happens, and will then call the necessary callbacks such as we define in our code. So in summary, it's usually said that the event loop does the orchestration, which simply means that it receives events, calls their callback functions, and offloads the more expensive tasks to the thread pool. Now, how does all this actually work behind the scenes? In what order are these callbacks executed? Well, that is what we're going to find out next. So remember, when we start our node application, the event loop starts running right away. Now, the event loop has multiple phases, and each phase has a callback queue, which are the callbacks coming from the events that the event loop receives, just as we talked about in the last slide. Now, in some places, you will read that there's only one callback queue or one event queue, but in fact, as I said, the event loop has many phases, where each phase has its own callback queue. So let's now take a look at the four most important phases. There are one or two other phases that are used internally by Node, but these are not that important, and I'm not going to talk about them. So the first phase takes care of callbacks of expired timers. For example, from the setTimeout function. So if there are callback functions from timers that just expired, these are the first ones to be processed by the event loop. If a timer expires later, during the time when one of the other phases are being processed, well, then a callback of that timer will only be called as soon as the event loop comes back to this first phase. Make sense? And it works like this in all four phases. So callbacks in each queue are processed one by one until there are no ones left in the queue, and only then the event loop will enter the next phase. Next up, we have IO calling and execution of IO callbacks. And again, remember that IO stands for input output. So calling basically means looking for new IO events that are ready to be processed and putting them into the callback queue. And remember that in the context of a Node application, IO means mainly stuff like networking and file access. And so it's in this phase where probably 99% of our code gets executed, simply because in a typical Node app, the bulk of what we need to do is related to networking and also file accessing. The next phase is for set immediate callbacks. And set immediate is a special kind of timer that we can use if we want to process callbacks immediately after the IO calling and execution phase, which can be important in some more advanced use cases. Alright, and finally, the fourth phase is for close callbacks, which are again not that important for us, but I put this here anyway for the sake of completeness. Basically, in this phase, all close events are processed, for example, for when a web server or a web socket shut down. So these are the four phases in the event loop, but besides these four callback queues that we just saw, there are actually also two other queues, the next queue and the other microtask queue, which is mainly for resolve promises. If you're not familiar with promises, we'll talk about them a bit in a later section. Anyway, if there are any callbacks in one of these two queues to be processed, they will be executed right after the current phase of the event loop finishes, instead of waiting for the entire loop to finish. Okay? So in other words, after each of these four phases, if there are any callbacks in these two special queues, they will be executed right away. Now, for example, imagine that a promise resolves and returns some data from an API call, while the callback of an expired timer is running. So in this case, the promise callback will be executed right after the one from the timer finishes. Okay? And the same logic also applies to the next tick queue, which we didn't talk about yet. So basically, process.nextTick is a function that we can use when we really need to execute a certain callback right after the current event loop phase. It's a bit similar to set_immediate, with the difference that set_immediate only runs after the IO callback phase. What is similar though is that both are for really advanced use cases, and we're probably not even going to need them throughout this course. But anyway, I want to include these more complex stuff here as well, so that you have the tools that you need if you really need to dig deep into Node.js if you want to. Alright, and with that, we actually finished one tick of the event loop. And the tick is basically just one cycle in this loop. So now it's time to decide whether the loop should continue to the next tick or if the program should exit. And how does Node do that? Well, it's very simple. Node simply checks whether there are any timers or IO tasks that are still running in the background. And if there aren't any, then it will exit the application. But if there are any pending timers or IO tasks, well, then it will continue running the event loop and go straight to the next tick. So for example, when we're listening for incoming HTTP requests, like we did in our Node farm project in the previous section, we're basically running an IO task. And that is why the event loop and therefore Node.js keep running and keep listening for new HTTP requests coming in instead of just exiting the application. Also, when we're writing or reading a file in the background, that's also an IO task. And so it makes sense that the app doesn't exit while it's working with that file, right? Okay, and this is basically what you should know about the Node.js event loop. If you need even more detail than this, well, you can always try to read the official Node documentation, which should be quite easy for you to understand at this point, now that you already understand most of the event loop anyway. And I just want to emphasize that it's really important for you to correctly understand the event loop, so that you can write your own performance code and also debug your own code when something goes wrong in an unexpected way. And now just to finish, let's review some of the stuff we talked about here. So in a nutshell, the most important thing that I want you to understand from this lecture, and maybe from this entire course, is that the event loop is what makes asynchronous programming possible in Node.js, making it the most important feature in Node's design and making Node.js completely different from other platforms. It takes care of all incoming events, right? Now in other languages, like we actually did use the synchronous version, but it was in the top level in very large objects because it's on the right path. Now there are some potential solutions to these blocking problems, like manually offloading to the
I'm going to show you how to potentially triple your Node application's performance using multi-threading. This is an important tutorial because the methods and examples shown will give you what you need to set up production-ready thread management. But you have to stick with me till the end because I first explain some gotchas before showing off the good stuff. So let's get started. For the longest time, Nodes had the ability to be multi-threaded by either using child processes, clustering, or the more recent preferred method of a module called worker threads. Child processes were the initial means of creating multiple threads for your application and have been available since version 0.10. This was achieved by spawning a node process for every additional thread you wanted created. Clustering, which has been a stable release since around version 4, allows you to simplify the creation and management of child processes. Finally, we have worker threads, which was introduced in version 10 and became stable in version 12. Unlike child processes, with worker threads, no additional node processes are created. All threads get created for one node runtime, and they are also able to share memory, which is not the case for the former. This makes worker threads the preferred option in most cases due to it being simpler and less resource intensive. Now, before we get into multi-threading your application, there are a few points that you need to fully understand. There is a layer of node that's already multi-threaded, and that is the libuv thread pool. I/O tasks such as files and folder management, TCP UDP transactions, compression, and encryption are handed off to libuv, and if are not asynchronous by nature, get handled in the libuv thread pool. So why is this important? It means that the implementing multi-threading using child processes or worker threads will only be effective for your synchronous JavaScript code that's performing heavy-duty operations, such as looping, calculations, etc. If you try to offload I/O tasks, for example, to worker threads, you will not see a performance improvement. The third note is that creating one additional thread in your app is easy enough, and there are tons of tutorials on how to do so. However, creating threads equivalent to the number of logical cores your machine or VM is running, and managing the distribution of work to these threads is way more advanced, and to code this logic is above most of our pay grades. Thank goodness we're in a world of open source and brilliant contributions from the Node community, meaning there's already a module that will give us full capability of dynamically creating and managing threads based on CPU availability on our machine or VM. The module we'll be working with today is called Worker Pool. Created by Josh de Jong, apologies if I said that wrong, Worker Pool offers an easy way to create a pool of workers for both dynamically offloading computations as well as managing a pool of dedicated workers. It's basically a thread pool manager for Node, supporting worker threads, child processes, and web workers for browser-based implementations. Just quickly, a big shout out to Josh for contributing such a powerful tool that has saved me alone weeks worth of development and testing. For those who also find value in this module, showing gratitude is sometimes as easy as starting his GitHub repo, of which I will have a link to in this description. Also, if you're enjoying this video, please give it a thumbs up, and if you want to see more like this, please subscribe to my channel by clicking on the subscribe button and the bell icon so that you are notified when I publish new videos. Now, to make use of the Worker Pool module in our application, the following tasks will need to be performed. First, we need to install Worker Pool via npm. Next, we will need to initialize the Worker Pool on launch of our app. We will then need to create a middleware layer between our heavy-duty JS logic and the Worker Pool that will manage it. Finally, we need to update our app to hand off heavy-duty tasks to the Worker Pool when required. We finally get to the fun part of this tutorial, where I'm going to show you how to action the items mentioned before and properly implement thread pool management in our application. Here we have a Node application that holds code samples for all the videos that form part of my Node performance optimization series. This source code is available on GitHub, and I will definitely provide links in the description to both the code and the video playlist. In the multi-threading folder, I've already created the resources and logic for our demonstration. This is to save on time, however, I will take you through each line of code. In the Worker Pool folder, we have two files. One is the controller logic for the Worker Pool, and the other holds the functions that will be triggered by the threads, aka the middleware layer I mentioned earlier on. In the controller is where we require the Worker Pool module. We also have two functions that we export called init and get. The init function will be executed once during the load of our application. It instantiates the Worker Pool with options we'll provide, links to thread functions, and creates a proxy that will be held in memory for as long as our application is running. The get function simply returns the in-memory proxy. In the thread functions, we create worker functions that will be managed by the Worker Pool. For our example today, we're going to be using bcrypt.js to hash passwords. This usually takes around 10 milliseconds depending on the speed of your machine and makes for a good use case when it comes to heavy-duty tasks. Inside the utilities.js file is the function and logic that hashes the password. All we are doing in the thread functions is executing the bcrypt hash via the Worker Pool function. This allows us to keep the code centralized and avoid duplication or confusion of where certain operations exist. The .env file holds the port number and sets the node.env variable to production for our example. It's also where we specify if we want to enable or disable the Worker Pool by setting the Worker Pool enable variable to 1 or 0. We will be using this later. Finally, our app.js holds the code that will be executed on launch of our app. First, we initialize the variables in the .env file. We then set up an express app and create a route called bcrypt. When this route is triggered, we will check to see if the Worker Pool is enabled. If yes, we get a handle on the Worker Pool proxy and execute the bcrypt hash function that we declared in the thread functions.js file. This will in turn execute the bcrypt hash function in utilities and returns us the result. If the Worker Pool is disabled, we simply execute the bcrypt function directly in utilities. At the bottom of our app.js, you'll see that we have a self-calling function. We're doing this to support async await, which we are using when we're interacting with the Worker Pool. Here is where we initialize the Worker Pool if it's enabled. The only config we want to override in this case is setting the min workers to max. This will ensure that the Worker Pool will spawn as many worker threads as there are logical cores on our machine, with the exception of one logical core, which is used for our main thread. In my case, I have 6 physical cores with hyper-threading, meaning I have 12 logical cores. So with min workers set to max, the Worker Pool will create and manage 11 worker threads. Finally, we start our server and we will be listening on port 6000. For our first test, let's disable the Worker Pool, run a basic test, then perform a 10-second load test to see how many requests per second we can successfully execute. We'll be using AutoCannon for our load testing, but you are welcome to use whatever tool you prefer that can interact with web APIs. So let's start our server. And let's perform a basic curl request against the bcrypt endpoint. We can see that we successfully returned a hash value. Let's now perform a load test using AutoCannon. We just replace the curl with AutoCannon and hit enter. This will run for 10 seconds. Once completed, we can see the average request per second is around 58. We're now going to repeat this test but with the Worker Pool enabled. So let's go and set the Worker Pool enabled to 1 in the .env file, restart the server. We can now see in the console that worker threads is enabled, the min and max workers are set to 11, and the worker type is auto. In my case, it will see I'm using Node version 14 and will use worker threads. If you're running a version prior to 12, it will use child processes instead. Let's run a basic curl test just to make sure it's working. There we go, we get our hash value as a response. Now let's perform a load test. Look at that, at least a 500% increase in requests per second. Can you imagine the possibilities if you start porting all your heavy-duty tasks to the Worker Pool? All you have to do is take the example I provided today, add middleware functions in the thread functions.js file, as we did for bcrypt hash, and execute these functions accordingly. So that's it for this tutorial. I really hope you enjoyed it. If yes, please give this video a thumbs up, and to stay tuned for more, be sure to subscribe to my channel. Until next time, cheers.
Hey there, before we get started, I want to take a second to say that this video was brought to you by LogRocket, a front-end performance monitoring solution. If you like this video and want to keep making more like this one, all you have to do is click on any of the links in the top right of this video to sign up for a free trial. That's it. We hope you enjoy the video.
Hello and welcome. In today's video, we look into the single-threaded nature of Node.js and how multi-threading can be achieved by using several strategies. When Brendan Eich first created the JavaScript language, it was not the multi-talented beast that it is today. JavaScript was merely a utility to add interactions to your web page and to sometimes perform certain validations. All the JavaScript code running on a single thread did not pose as a shortcoming at that time, let alone a hindrance to performance. But as the use case associated with the language slowly got more and more complex, things started to change. In 2009, Ryan Dahl created Node.js, wherein he took the V8 JavaScript engine from Chrome and wrapped it in a bundle that could communicate with the operating system to perform asynchronous I/O and other related operations. But even at that time, instead of introducing a multi-threadedness into the ecosystem, he thought of leveraging the single-threaded nature of JavaScript by implementing an event-based architecture for the Node server. What that means is all the JavaScript code that is running as a part of the node server runs in a single thread, whereas everything else can practically run in parallel. Whenever an IO operation is to be performed, the operation is initiated via an API and a callback is registered. The callback is invoked by the API when the async operation completes. Till then, the JavaScript block of code keeps executing synchronously. Usually, this synchronous JS code runs quite fast, and majority of times it is the case that the engine keeps waiting for the callback to get triggered after having executed all the synchronous code in the call stack. So, there doesn't seem to be a need for spawning a thread in this case. Let's consider this code for example. We are trying to run an SQL query. Even though the time it takes to execute that query is 10 seconds, the node server is not stalled. The find one API here accepts the query to be executed and the callback to be fired once done. Once the line of code calling that API is executed, query run will happen in a separate context. The synchronous execution continues, and the next line of console.log, which says running query, is printed immediately. Similar case with the timeout. Once the setTimeout API executes, a callback is registered for after 1000 milliseconds, and the main JavaScript thread does not have anything else to process. Then, once 1000 milliseconds pass, the callback runs, and hey there is displayed onto the console. Later, when the query completes execution, the callback is fired, and the result is console logged. All this happened without ever bogging down the main JS thread. That sorts out our concern with respect to asynchronous I/O. But what about the tasks in the synchronous JavaScript main thread itself that take a long time to execute? Here is an example. Let's say that the result has a million entries, and decrypt is a decryption function which is CPU intense and also not available as an async API. Thus, runs on the main thread. In that case, if this function took 5 seconds to execute, no other JavaScript code can execute for those many seconds. And this is usually one of the use cases where we can contemplate about the feasibility of a multi-threaded solution to the problem. On that note, if you find yourself constantly striving to improve the performance of not just your backend, but your overall app, then you'd want to give our sponsors LogRocket a try. LogRocket is the front-end application monitoring solution that allows you to see why your bugs are happening. LogRocket shows you your users' network activity, their console logs, errors, as well as the Redux store. You'll get to experience your bugs just like your users do. So check out LogRocket at the link in the top right of this video to get 14 days for free.
Request, you have a hardware interrupt, and we can take advantage of that immediately by saying, we're interested in certain file descriptors. When things happen, send me an event. That's kind of the idea with non-blocking I/O in general. You have two different models in that case. One of them's called a readiness model. The other one's called a completion model. Systems like epoll, poll, KQ are typically readiness models, which is where you tell the operating system, this is something I'm interested in doing. Can you just let me know when I can do it in a non-blocking way? A completion model like IUring or IOCP for Windows, those are sort of like you schedule to the operating system, I want you to perform this operation. Will you let me know when it's done and send me the data as well with that? So those are the kind of models. Right, so the operating system will create some kind of event-based activity we care about, whether that's a read operation, accept, an error, hang up, and the OS event may actually contain the results of that. So that would be the completion model that I mentioned. So one of the APIs here is called poll. So this is in a single threaded, use a poll system.
What's going on, guys? My name is Mehul, and welcome to your 10th Node.js tutorial, in which we'll be starting off with the file system API provided by Node. So this file system API, what it actually does is it will allow you to have access to a bunch of methods and functions to edit, read, or modify your files on the server. So with the traditional JavaScript, we didn't have this functionality because just reading or writing to the file system poses a great security vulnerability to all of the systems on the internet. So that's not allowed in the browser-side JavaScript, but on the server-side Node, it is. So we'll be mainly covering how to read files in this tutorial. So to do that, let's first of all just create a folder. I'm just gonna say this as files. I guess it's the wrong directory. Here you go, files, and a new file, and you can name anything without even an extension, it will just work fine. So first of all, you need to import a custom module known as fs. So just throw that in, require fs, and since this is a system module, a core module, there's no dot slash here. So now fs has our module, and now what I'm going to say is that fs.read file, and this would be our path, this would be our encoding, and this would be our callback. So let's just populate each of them. So what I'm going to do is that this is the path, so this would be files slash file, then this would be UTF-8, and this is the callback function with error and data as the parameters. I'm just going to console log some data. And then what I'm going to finally do is I'm just going to say console log executed before file reading and executed after file reading and probably. So why I wrote probably here is that this function right here, the read file, is asynchronous function. So what is asynchronous function? Well, this asynchronous function would not block the execution of JavaScript, which is under this code. So as you know that computers execute Satan one by one, so it would first of all come to this line, then this line, then this line, then this line, this line, and so on. So in JavaScript, what you can do is that if this block of code is taking some time to execute, you have the option to make the control skip to this line as well, and not kind of skip, but this code is executing as well, but this code executes with it as well. So if you just consider the line-by-line execution method, then you should say that the data would be console log first and then this line. But let's see what happens. So inside a file, I'm just going to say this is a really simple file with some new lines, and that's pretty much it. So let's go ahead and run that in the terminal. So I'm just going to say node.js, or just a node script 10.js. Alright, so now you can see that we got this executed before file reading from here, executed after file reading, probably, well, not true. So it got executed before file reading only, and this is because this is an asynchronous function, so it did not just block the JavaScript under it, it kind of just made that executable. So when this code is completely, this file is completely loaded in the system, then this function is fired. So this function is fired with error and data, and this console log data, so this is our file right here. Now what happens if I remove this encoding? So when I remove this encoding, this happens. So it returns me a buffer. Well, I don't know what the heck is that. So I probably suggest you guys to make use of the encoding always. So UTF-8 is probably if you just code in English language, and by that I mean that you just write in English, then UTF-8 would be good for you. I guess for some other languages there are some other language codes, so I guess you should probably Google that if you are just writing in some other languages or you have some other somehow struck in a function. What it does is, so let's just console log the data now, and it should probably show us that.
Hi friends, welcome back to Arc Tutorials. This is Node.js full tutorial series for beginners. In today's episode, we are going to learn about events and event emitter. I've told you that Node.js is JavaScript running at server side, right? So for friends who are joining us recently on this particular episode, you know that JavaScript used to be focused mainly on the client side, but with Node.js we have now started using JavaScript heavily as a server side programming language. Which means since JavaScript is mostly event driven, right? So it's obvious that Node.js has full support and events are first class citizen in Node.js. Node.js also has a class called event emitter, which is the most powerful tool through which we can configure, trigger, implement events of any type and of any scale. We'll learn all about it in today's episode. Welcome back, friends. My name is Sridhar. This is part 15 of Node.js full tutorial playlist. The playlist link is in the description box below. I've planned down 25 hands-on tutorials and live examples for you. Make sure you check out the playlist link, which is in the description box below. Alright, so what you see on your screen right now are the topics we have covered in the previous episodes. If you are not really sure about some of these topics, I request you to kindly check out the playlist link and go through these topics because they are extremely important to learn and master Node.js. Today, in the last episode, we have also seen some of the core modules like file system, util, URL, parse, path. So today, we'll learn about events, which is also a part of a core module, right? So Node.js has a core module called events, which has a class event emitter, which is used to configure, trigger the events, right? Events are the extremely important topic and functionality and feature of Node.js. If you're working on any serious web application in enterprise setup, you'll find yourself writing a lot of events. Now, events can be configured to be triggered in a particular manner, like how and where it has to be. We can also pass parameters, right, using spread operator, which means it can take one or more parameters to the particular callback event. We'll see that now, and let's get into hands-on. So if you have any doubts during the course of this tutorial series, drop them in the comment section. I will try and help you. Alright, so the first thing in the previous episode we have seen and explored and learned about some of the core modules. Let's add it to that list and say today we are going to learn about events. So the first thing that we want to do is we need to require an events, right? So we'll need the core module, which is events of Node.js. Now this is an important step. Remember, without this it won't work. Which is once you've created the event, we need to create a event emitter class, right? Object. So event emitter equal to, you'll say new events. This one, this events dot event emitter, right? Now you're saying creating a new object of event emitter class. Now once you have it, then you'll say event emitter dot on. This is nothing but defining the event or what event you want to define and how it will be invoked. So what is the event? Here I'm saying invoked. Now, a lot of people will have doubt that should these be JavaScript events, right? Should this be JavaScript events? No, they are not JavaScript events. These are called custom events. Right? Why? Because in JavaScript there is no function by the name invoked. I can also call an event called arc, or I can call it YouTube, anything, whatever you want to call it. Right? So these are my events, so I can name them anything I want. Same way you can name it anything you want after your pet, after your anything, whatever you want. Right? So once you've done that, you're defining and saying that whenever there is an event which is invoked, call this function. And this is nothing but ECMAScript, right? Which is nothing but your arrow function. So now we are saying whenever there is an event called invoked, event custom event invoked, right? So we have defined an event, right? So remember, this has two-step process. One, first event definition, right? So this is event definition, like what it should do when it is when this invoke is not a great name, say update results, update student, or some event, right? So I'm saying whenever there is an event called update student, you should call this particular method, right? So first is event definition, what it should do. Second is actually calling the event, right, or invoking the event, right? That's the two-step process. So first we have defined what this function should do when you have an event called update student. Now we will call this, and how do we do that? We'll say event emitter dot emit. This is a thing to trigger and tell what you're emitting. Here we are emitting the same name as this. So now you're saying call this particular method. Now this emit can be called anywhere in the program, right? Inside append file. So I will show you that also now. I'll just show you. Don't worry, we'll go step by step. So first we will call it here, and I'm saying emit means emit this event to the program. And Node.js will know that there is this event was called, so I have to execute this. Right? Now let me show you that first. So see, it says custom event invoked. Right? It came here, it executed it. Right? Now what I'm doing, I'm taking this event emitter. Right? And what I do, I will call it inside the read file, which we did it in the previous episode. Right? So here I define the event, and I'm saying I'm calling it inside the read file. So whenever the reading of the file is done, event should be called. Let's see this. So now if you see, it has done all the processing, and finally it says custom event invoked, right? So that's because it's done after this operation. Similarly, you can use it anywhere you want in append file after a particular so the idea is it's a method you are calling. You can call it anywhere inside class or pass it as a parameter, right? So that's number two. The third is optional. Optional is nothing but passing params, right? Now you'll say, can we pass parameters? Can we pass parameters to this event method, callback method? Certainly we can do. So how can we do that? I'll say a comma b. See, if you see, it is a three dot operator, which means it's a spread operator, right? Spread operator means it can take any number of arguments. So here I'm saying a comma b, and here I'll just print them out. I'm not doing any processing just yet. And here we'll just pass the values. I'll say 10, 30, right? A comma b, 10, 30. This will go in place of here. Let's see. So now you see custom event invoke. Then it is just printing 10 and 30, which is from this particular console log, right? So that's how you can define a custom event. That's how you call a custom event. That's how you pass parameters to custom events, right? I hope it's clear to you. We can also call another custom event inside this particular event. So how do we do that? Let's create it. Now I will say after updating the student, read all students. I'm creating one more. Reading all student data, right? So here what we're doing, we are calling another method, and where should it be called? We can call it inside this and say inside, once it has done custom event, just call another event, right? So now see, I'm just sending the emitter update student. It will come here, it will execute this, then it will call another event, which is read all students, and internally it will call second event. So that way you can have chaining of events, right? Now see. So here we have custom event invoked, then reading student data, right? Which means it will come here, it will call this particular event, which is update student, it will go here, it will execute this, it will find one more event calling, it will go here. So that way you chain the events, right? That's how you chain the custom events. Chaining custom events. Or you can also say calling events inside events. Right? That's how you can write different events. Right? I hope these examples are clear to you. I hope you have gained enough knowledge on the event and the event emitter, because these are extremely important topics that you will work if you're really working with Node.js application. All right, so that's all for today's episode. We will see that in the next episode. We'll explore about buffers and streams. This is Node.js tutorial playlist. If you like the series, you hit like button. Don't forget to subscribe to my channel.
Hello everyone, Alex here from warnoffkeys.com, and in this video I'm going to show you how you can listen for and fire events within Node.js. So real quick before we start, if you need help with anything, feel free to leave a comment down below or ask in the Warnoff Keys Discord. If you post in either of those two places, I'm sure someone will be able to help you out. So to start things off, I have this empty index file, and we're going to import the events package, which is installed with Node.js by default, so you do not have to install it manually. I'm going to say constant event emitter, and both of these are going to be capitalized, symbolized that this is a class. This is going to equal require events. Now we have to actually create an instance or an object from this class. We can say constant emitter equals new event emitter, and now we can actually use this to listen for and fire events. So for example, if I want to listen for a custom event, such as something called user join, I can do it with emitter.on. Then here's the actual name of the event as a string. I can say user join, and then we're going to have a callback here. This function will be ran whenever this event is fired. Now to actually fire this event, I can say emitter.emit, and we can pass in the actual name of the event. So I can say user join. And if I were to run this, nothing would actually happen because within our callback we're not actually doing anything. So I can add a simple console log saying event fired. I can then save this and I can run this code with node index.js. We then see event fired. Now if I were to comment this out here, and I were to run the code again, nothing actually happens because the event is actually never fired. Also keep in mind that if you are listening for the event after we are actually firing the event, then nothing will actually happen because whenever this line is ran, it's going to look for existing listeners. So it's important that you listen for the event before you actually fire them. Now I'm going to show you how you can pass in information. So let's say hypothetically we have some object here, and we can say user is Joe, and then their email is test@test.com. So this object is actually passed in as an argument to this function, so we have access to user. I can then console log the user here. I can save this and I can run the code. We then see event fired, and we see our object right here, which is the object that was fired from right here. So next I want to explain a warning that some of you might have run into when actually listening for events. If I were to take this event listener, and I'm going to put this inside a for loop, so let a equals 0, while a is less than 20, plus a, this will just loop through 20 times. So we're going to listen for this 20 times. If I save this and I run the code, we get our user printed 20 times, but also we see max listeners exceeded warning. Possible event emitter memory leak detected, 11 user join listeners added to event emitter. And so this is going to be a problem because if you have more than 10 event listeners for this specific event, it's going to throw this warning. Now your code is still going to work as expected, as you see up here, but we want to try and fix this. Obviously the proper fix here is to not put this inside of a for loop and try and minimize the amount of event listeners that you have. However, if this is not possible for your application for whatever reason, then you can actually edit this. So you can say event emitter dot default max listeners equals some higher number. Let's say 50 for example. I can then save this and I can run the code again, and we no longer get the warning. However, this is not the proper way to fix this. It is important that you actually just fix the initial problem, such as removing it from the for loop or whatever your use case might be.
Now, a couple quick notes for those of you who are following my Discord.js series. When it comes to the advanced command handler, the best way to solve this is to actually format your code to use the commando framework, which I recently released a video on. Also, you might be familiar with some of the syntax when it comes to the .on, some string, and a function. That's because Discord.js actually uses events. If I go to the Discord.js documentation and I scroll down to client, which you often use as your actual client, some of you might know bot, it's the same thing. We can scroll up and we see client extends base client. If we click on this, we then see base client extends event emitter, which is the exact thing that we're using here. So this is why the syntax seems similar if you use this within certain APIs, because it is Node's event system, and it's fairly simple to actually implement within your own applications. And so this is a basic rundown of how you're going to use the event system within Node.js. If you found this video helpful, then please consider liking and subscribing. And again, if you need help with anything, consider joining the War and Peace Discord server. A link to that can be found in the video description. Thanks for watching.
In today's tutorial, we will look at another topic specific to Node.js. We're going to look at the event emitter, a default module available in Node that allows us to create custom events. Welcome to another tutorial from All Things JavaScript, where we help bridge the gap between novice and expert. Using custom events in your code can lend itself to a great pattern for asynchronously responding to something that has happened in your code. This can be done with vanilla JavaScript using custom event. I talked about this in the last tutorial, and we'll provide a link in the description if you'd like to visit that tutorial. The idea behind creating a custom event is that you want to respond in several ways to something that happens in your code, but you don't want all that code in a single function in the same place. The event emitter in Node allows us to do that. Let's first take a look at the event emitter. Now, the event emitter is a default module available in Node. So once you have Node, you have access to this module. And to learn how to use some of these default modules, you can use the Node documentation. So here I am on nodejs.org, and I can simply go to the docs tab. And then I'll choose the version. And then here's a list of some of the things we can learn about in Node. And many of these are default modules. I can click on events, which is where I want to go to learn about the event emitter. And you can see all the different topics. And then you can see the classes described here. And we're going to be using some of these things in our sample event that we're going to create. So here's where you could go to learn more about a default module in Node. Specifically, one we're looking at is the module. Okay, now let's go ahead and set up an example so you can see how this would be used. So I'm going to jump to Sublime. Now, the first thing we want to do is we want to make the event module accessible to us in our file. And we use require to do that. Just like we have talked in previous tutorials on Node, require allows us to take advantage of modules. So I'm going to set up a variable. And I'm going to set that equal to require. Now notice, because this is a default module, I don't have to specify path. And we'll go ahead and find that module for me. So now I have the event module, a part of my file. I'm going to set up a new emitter. And it's an emitter that we use to do all of these custom events with. So let's go ahead and set that up. Equals new emits an event. Anytime that event is fired, I can respond to it. It's going to be set up user. That's what we'll do here. Indicate we want to respond to it. But we always emit this event. And it causes anywhere else in this code.
Now, in order to set the stage for the next couple of lectures, let's start by learning a bit about the Node architecture. So let's represent the architecture here in terms of Node's dependencies, which are just a couple of libraries that Node depends on in order to work properly. So Node runtime has several dependencies, and the most important ones are the V8 JavaScript engine and libv. Now, we said before that Node is a JavaScript runtime based on Google's V8 engine, right? And so that's why it appears here as a dependency. If it wasn't for V8, Node would have absolutely no way of understanding the JavaScript code that we write, and therefore V8 is a fundamental part in the Node architecture. So again, the V8 engine is what converts JavaScript code into machine code that a computer can actually understand. Okay, but that alone is not enough to create a whole server-side framework like Node, and so that is why we also have libv in Node. And libv is an open source library with a strong focus on asynchronous I/O, so input-output. This layer is what gives Node access to the underlying computer operating system, file system, networking, and more. Besides that, libv also implements two extremely important features of Node.js, which are the event loop and also the thread pool. And in simple terms, the event loop is responsible for handling easy tasks like executing callbacks and network I/O, while the thread pool is for more heavy work like file access or compression or something like that. But you'll learn all about that, so about the event loop and thread pool in the next couple of videos. One important thing to note here is that libv is actually completely written in C++ and not in JavaScript, and V8 itself also uses C++ code besides JavaScript. So therefore, Node itself is a program written in C++ and JavaScript, and not just in JavaScript as you might expect, right? Now, the beauty of this is that Node.js ties all these libraries together, no matter if written in C++ or JavaScript, and then gives us developers access to their functions in pure JavaScript. So it really provides us with a very nice layer of abstraction in order to make our lives a lot easier, instead of us like having to mess with C++ code. That would be a terrible experience, right? So again, this architecture allows us to write 100% pure JavaScript code running in Node.js and still access functions like for file reading, which behind the scenes are actually implemented in libv or other libraries in the C++ language. And speaking of other libraries, Node does actually not only rely on V8 and libv, but also on HTTP parser for parsing HTTP, CERS or something like that for some DNS request stuff, OpenSSL for cryptography, and also zlib for compression. And these are not that important to understand, alright? So in the end, when we have all these pieces nicely fit together, we end up with Node.js ready to be used on the server side of our application.
All right, so it's 9 a.m. We'll go ahead and get started. Good morning, everyone. Thank you for coming to my talk. I just want to let you know ahead of time that the projector is having some issues yesterday and today, so if it cuts out, it's not my fault. So the title of my talk is libv, what's a unicorn velociraptor? So if you were to enter that into Google, you would see some results similar to this. So the picture on the top left is the actual libv logo, and then things just kind of go off the rails from there a little bit. We have a dinosaur riding a unicorn. For some reason, the Chicago Bears football player is on a dinosaur. But yeah, so what I'm talking about is libv, the platform abstraction library that Node.js sits on top of. libv is written in C. It's not C++, it's actually, I believe, C89, so it runs in most places. The point of the library is to do asynchronous I/O, so it's going to be what gives libv, or I'm sorry, gives Node its asynchronous I/O operations, event loop, things of that nature. Oh, here we go.
Your fault.
My fault.
Oh, wait, no, sorry.
That's all right. I'm glad I warned you guys ahead of time about that.
All right, so libv is used by Node, obviously, but it actually has a number of other really big consumers. So a language called Julia, NeoVim, CMake, a bunch of others. At the bottom of the screen here, you will see Cartoon Head. That is Saul. He's another one of the libv collaborators. That's his GitHub icon. And he said this really nice quote to me one time, and I wanted to attribute it correctly, not take credit for the quote myself, but it basically is, we write the if-def so you don't have to. So if you look inside the Node.js C++ code base, there is some branching, some if-defs based on what platform you're executing on, but it's really not that bad. If you then dive down into the libv source code, it's a whole other story. There are if-defs all over the place. There are actually two different source trees, one for Windows and then one for everything else. So there's a lot of branching logic there that kind of gives a nice, consistent API to people who want to build on top of libv. And as I said, it is a cross-platform C library, so we support a large number of operating systems, some more than others. So we have a 3-tiered support system. So tier 1 is kind of, we test this in the CI. Anything that might cause a regression on any of those platforms is going to block something from landing. And then tier 2 is it's considered officially supported. It might not necessarily be tested in the CI, and we'll try to the best of our abilities to make sure that it never breaks. I'm not really sure why we have the distinction between tier 1 and tier 2 because I do believe that all the things in tier 2 are currently tested in the CI. And then tier 3 is going to be community maintained platforms, so that's going to be Android, IBM I, although I think they're currently in the process of trying to add higher tier support right now. And then just some other different random platforms. A lot of times people will show up with platforms that I've never even heard of, and they'll start trying to add if-defs into the code and see how it works. So as long as it's not too intrusive into the code base, we're usually okay with that. But we can't really make any promises that it won't break because we're not testing it anywhere. So if if there's a platform you care about and you want to see it in there, you are kind of on the hook to make sure things don't break. So some of the features that come from libv, the event loop obviously is a really big one in Node. TCP sockets, so in Node that basically translates to the net module. We have DNS resolution, so in the DNS module, some of the system calls are from a library called CARES that I'll talk about in a couple slides. But libv also implements some stuff there. UDP sockets is going to be basically Node's DGRAM module. File watching and file system operation, so just about everything in the FS module is going to go through libv. Child processes and threads, obviously that translates to the child process module and worker threads. And then we have other things like synchronization primitives, mutexes and things like that. And then we offer a high resolution clock. So if date.now is just not accurate enough for you, you can use inside of node process.hrtime to get a little more high resolution timing. And I want to talk a little bit about the high-level architecture of libv. So I like to think of this as broken up into 2 rows. So basically the top row, which has the network I/O all the way across to like file I/O, DNS, and user code. That's more of the public-facing API, what users of libv are going to consume. And then the bottom row with like the IOCP and thread pool and things like that, that's more of the guts of libv. You can actually get pretty far using libv without having to interact with any of that stuff. One of the things that's interesting on the bottom row is, IOCP is basically how we do I/O polling on Windows, but we also have things like epoll, KQ, and event ports. So libv will basically pick the best primitives for what operating system you're running on. So KQ will be used on BSDs and the Mac, epoll is used on Linux, and then event ports are Solaris. So in order to really use libv effectively, there's a couple things you have to understand, a few concepts. The first one is handles. So these are an abstraction for what's typically a long-lived resource. So this might be something like a socket or a child process, TTYs if you're dealing with your terminal, timers, and things like that. We also have a couple of different types of handles that are used for interacting with the event loop. So something called an idle handle, which is actually poorly named because it runs on every iteration of the event loop, so there's not really anything that's idle about it. And then prepare and check handles, which run before and after you do before libuv does its I/O polling. And then async handles, which can do things like be used to wake up the event loop if it's sleeping and things like that. And then handles have a concept of being active. So if a handle is active, it'll actually keep the event loop alive. So for example, in Node, whenever you start a server, if you just you call server.start and nothing else, you'll notice that Node doesn't exit. That's because the event loop sees that there's at least one active handle alive or remaining and keep the event loop open. And then there's also an operation called unreffing, and then the inverse of that is reffing. So when a handle is created, it's in a state of being referenced, and that is what will help you keep the event loop alive. But if you unref that, then the event loop no longer considers that as something that will keep your application open. So these are actually exposed inside of Node. So if you've done a lot of Node programming, there's a chance you've seen .unref and .ref, and that's basically what it translates to down in libv. So in addition to handles, we also have something called requests. I like to think of handles as more of an object, whereas a request is more of a function or a method. I say function or method because sometimes they are involved with a handle and sometimes they're kind of their own standalone thing. These are typically shorter-lived operations, so things that happen when you're doing file I/O, if you're doing DNS lookups, or if the user passes in their own custom work that they want to execute in the thread pool, then that's going to be more of a request type operation instead of a handle. But like handles, they can also keep the event loop alive. So for example, if you start Node and you do fs.read file, Node's not going to terminate until that read operation is complete if that's the only thing that's happening. If the request wasn't something that could keep the event loop open, you would call fs read file and then the program would just exit immediately. So if you're ever curious why it is that Node doesn't exit in some cases, it's usually because there's a request or a handle somewhere. And then one of the more, famous things that we get out of libv is the thread pool. So the whole point there is to move computations off of the main thread. JavaScript as a language, with the exception of workers, which are relatively new, is single-threaded. So in a server application, you probably are going to have a lot of things going on at the same time. You could have hundreds or thousands of requests being processed simultaneously. And if everything ran on just the one main thread, things would slow down pretty quickly. So we use the thread pool to offset some work onto worker threads. One common misconception is that everything runs in the thread pool. That's wrong. Only file I/O, DNS lookups, so get address info and get name info, and then custom work that a user might actually off-put into the thread pool. Those are the only things that actually run in the thread pool. And by default, there are 4 worker threads in the thread pool, but you can actually control that with an environment variable called uv_thread pool size. So if you pass that, that's propagated up through Node too. So if you start Node with uv thread pool size equals 124, that's how many threads you'll spawn. Unless you actually need to do this, you should probably be careful because more threads are not always better. If you don't have enough hardware to keep up with all the threads, they can actually compete with one another, and all the context switching in between them can actually slow your application down. So this picture is taken directly from the libuv documentation. It basically explains how the event loop works. So every tick through the event loop, we calculate the loop time, so we have some reference for what time it is. And this is kind of an expensive operation, so we cache it at the beginning, and then we're going to check is the loop alive or not. And by is the loop alive, I mean are there active handles and requests that are outstanding. If there are none, then the event loop can exit, and then in Node that'll propagate to the process exiting. But if there is still work to be done, there's a number of steps that libuv goes through. So first, it'll look and see if there are any timers that are due. So if you've called set timeout or any of those like ready to be processed. From there, it goes on to pending callbacks. So these are going to be your in Node.js callbacks. It pretty much we pass the functions down to libuv as well. So are there any callbacks that are ready to run? Next, it'll process idle handles. These are the things that I said before had kind of a bad name because they get processed every time through the event loop. And then we do something called prepare handles. So this is basically we're about to go into polling for I/O. Prepare handles give you kind of a hook into the event loop if you want to do anything before polling for I/O. So then we move into the actual I/O polling, and then when we come out of that, we have check handles. So it's kind of the inverse of the prepare handle. So it gives you a good way to hook into your event loop. Then finally, any closed callbacks that are outstanding, we execute, and then we loop all the way back up to the top, compute the time again, and basically start from scratch. And that's basically one tick of the event loop. This is all that I'm really going to cover on the event loop. But if you're interested in more about it, I would recommend Bert Belder's talk from 2016 Node Interactive. It is a few years old now, but the structure of the event loop hasn't changed, so the information there is still relevant. So next, I talked a little bit about how libuv works. Now I want to talk about how it fits into Node.js. So at the very top of this diagram in yellow, I have that's going to be your application's JavaScript code, and then it's going to call down into Node's standard library. So FS module, DNS, job process, all those, and that's going to be the second layer of yellow there. From there, it's going to call down into the purple layer, C++. That's the binding layer. It's a really ugly code to kind of interface between JavaScript and V8 and libuv. And then the binding layer, I kind of listed some of the major libraries that are part of Node here. I put libuv on the left by itself because it is what we're talking about here. But in reality, I would say V8 is the biggest dependency, and then probably libuv. But you can see some of the other dependencies here. So CArrays is a DNS resolver. So you can actually, Node has 2 different ways to do DNS lookups. There is the way that goes through CArrays, which is always going to make a network request. And then there is the one that libuv implements, which is going to be DNS lookup in Node. That actually uses the system resolver. So it's going to use the same lookup mechanism as like ping and any other applications you might be running on your computer. One thing to note about that is, until, I don't know, about a year ago, it was actually possible that if you issued a bunch of DNS lookup requests, that it would go down into the thread pool. And so if you're doing like 5, 6, 7, 8 DNS lookups, it could actually block other things in your application that were using the thread pool from running. So people would issue a bunch of DNS requests and then start doing file I/O, and they wouldn't understand why their file I/O wasn't working. It's because the threads were tied up with DNS lookups. So that's where it would be a good use case to use CArrays, because CArrays doesn't go through the thread pool. But either way, that's no longer the case. So we've now, inside of libuv, started to distinguish between different types of thread pool operations to make sure that they don't step on each other's feet too much. And then finally, at the bottom is just the operating system. Libuv calls out to that, but for the purposes of this talk, it's not really important to think about. So on this slide, Saul is back to talk about the onion architecture, where basically the more layers that you peel away, the more you cry. And the reason for this is, inside of Node, you might use something like net.socket, which has a nice JavaScript API, it's built with streams, and it's just fairly easy to use. But if you look closer at the source code, it references something called a TCP wrap, which is in purple, so it's one of those nasty binding layer objects. So this is written in C++. It's a lot less nice to work with. And then that actually wraps something called a UV TCPT, which is a libuv type written in C for interacting with sockets. And then inside of libuv, we actually wrap that inside of an OS-specific handler, or OS-specific handle, so a Windows socket or a Unix socket, things of that nature. I want to talk a little bit about how we test this thing. So we had issues in the past where we would create a release of libuv, and all the tests we would pass, and then we would go to update Node, and then all of a sudden things would break inside of Node. Libuv has close to 400 tests, but they're written in C. C is kind of a pain to deal with. I think we're mostly JavaScript developers in this room. So it's tedious, and like I said, we had issues where, for example, libuv 119 came out, everything was fine, went to upgrade Node, and the CI came back red, so we didn't actually land that. But unfortunately, there are people in the community who, as soon as a new libuv release comes out, they build with that version, they compile Node with that version of libuv themselves. So even though we hadn't strictly broken Node, we did break some users who were a little more brave. And so we very quickly reverted and got a new version released, and life was good again. But it was an issue that happened more than once, and it was kind of frustrating to deal with. So we kind of thought about it for a little bit, and we're trying to figure out a good way to make sure that Node was going to be fine before we actually made a libuv release. And so the Node.js build working group stepped up big time for us there. They actually created a new CI job where before we create a libuv release, we actually take whatever is the latest in Node and whatever is the latest in libuv, compile them together, and then run Node's test suite and see what happens. So Node has over 2,800 tests. It's easy to write tests in Node because they're JavaScript. And ever since we kind of took this approach, we haven't had any issues where there have been bugs, but we haven't had any of those known regressions that cause us to do cycles of multiple releases. So that's been a nice process improvement. So now I want to actually trace through thread pool operation, so all the way from userland JavaScript code all the way down to the thread pool. So in this case, we're just going to do a copy file operation. So we're going to use fs.copyfile. There's 3 different variations of that. So there's the synchronous version, the promises-based version, and then the callback-based version. And so the first one shown here is the synchronous version. Second is promises, and then the one at the bottom is the old-school callback-based approach. So from the code that we just saw, the first thing that would happen is we would call into Node's FS module. In this case, I'm showing the code for the promises-based version because it fits nicely on the slide a little better. But if you look inside Node, there's similar code for synchronous and callback versions. But so all we're doing here is we're passing in source, the destination, so where we're going to copy the file to, and then certain flags that the operation takes. So for an example flag would be if the file exists already, do we want to overwrite it or not, things like that. We're going to validate both the source and destination paths inside of Node. The flags, we're going to make sure that the flag is an integer. So that's what the or0 is. That's kind of a JavaScript trick. JavaScript doesn't really have different types of numbers, but under the hood, the JS engine does. So the or0 will actually convert it to a signed 32-bit integer under the hood. And then we're going to call binding.copyfile and pass in the normalized paths, the flags, and then a special symbol here here called k-use-promises. This is just a symbol that under the hood will tell the binding layer that we're doing a promises operation as opposed to synchronous or callbacks. And so if you look through the node code base, these are the three different ways that we would call binding.copy file. You'll notice that the first three parameters in every case are the source destination flags. That's going to be the data that we're operating on. Then the remaining arguments differ between implementations. So I already mentioned k-use promises is a symbol that tells you to use the promises implementation. The synchronous version passes undefined followed by context. The context is what we populated with any results and errors that might come back from the binding layer. And then the callback based version just passes something called rec, which is a C++ object that's used for the callback code. So from here we're going to leave in JavaScript. We're going to enter the really ugly C++ code that I talked about a little bit. Can everybody in the back read that? Not that it's nice code, but so this is actually the C++ code that gets executed anytime you run copy file. The first collection of statements, you'll see a bunch of check GE, check not null, things like that. These are basically a last ditch effort to validate user input. If any of these checks fail, Node will hard crash. And we're okay with that for a couple reasons. First off, you're really not supposed to be using the binding layer directly. So if in your code you're calling this directly, then you're kind of on your own. The other reason is we've already validated all these same things in JavaScript, so we're just trying to make sure that people aren't going to be passing in garbage data to us. From there, we're actually going to then call something called get rec wrap, and that is what we're going to be able to use to determine what type of operation it's going to be. So synchronous, asynchronous, and then if it is asynchronous, it's a callbacks or promises. I'm not going to go too much into what all these different arguments are because you can see there's a lot of them. You'll see the copy file is there. You'll see the source and the destination, the flags. And most importantly, you'll see uv_fs_copy file. That's the function inside of libv that this operation is going to execute. So from here, we're actually going to leave Node completely and going into libv. And this is that same function that I just mentioned. This is what the signature looks like. So the first parameter is going to be the event loop. For synchronous operations, that can actually be null, but it'll be there in all the calls. The rec, the second parameter is it's going to be basically a file system operation request. So earlier I talked about handles and requests. This is one of those requests. So Node's not really responsible for attaching all the information to the request. There are some macros down later in this code that I'll go over that kind of populate that some more. But then the source and destinations are passed as path and new path. The same flags that we gave in JavaScript are passed as the flags. And then the UVFS callback, that's going to be either a callback function or null if it's synchronous. From there, we're going to call init. So init is a macro. It's going to populate that request I talked about with. It's going to basically tell the request that this is a copy file operation. So everybody who calls into libv doesn't have to specify what operation they're running. It'll just automatically know about the function that you call. Then we do some flag validation. So we want to make sure that people aren't passing garbage values in the C layer too. So if anyone passes in a flag we don't recognize, we'll return e and val. Next we do fs capture path. The point of this function is to basically take the path that was passed in and make a copy of it, because if we're doing an asynchronous operation, there's a chance that that memory can be free by the time the operation completes. If that happens, you're probably going to run into a hard crash. And then finally, we add the flags to the request, and then we call post. So post is another macro that is going to send your work off to the thread pool. It's worth pointing out this is the actual full implementation on Windows. There are similar ones on Mac and Linux, but because Windows code is a little smaller and cleaner, I'm going with that. So this is what the post macro looks like. Basically, it checks the callback if it's null or not, so it knows if it's synchronous or asynchronous. And then if it's asynchronous, it's going to register the request with the event loop. So once it does that, it'll keep your process alive if the while the work is still happening. And then it'll call work submit, which basically takes your request and sends it off to the thread pool. You'll see UVFS work is one of the parameters. That's basically a giant switch case where it looks at what type of operation you're trying to run, and then calls whatever the code that you need to call for that. And then UVFS done is what's going to be called once the work is complete in the thread pool. That'll basically propagate you back to the binding layer and then back up to the JavaScript. If you're using a synchronous operation, we just call UVFS work directly, so it'll do the copy, and then it'll just return the results directly because we don't really need to involve the thread pool for blocking. So this is the Windows internal copy file implementation. We're beginning to do some flag validation. This is going to be operating system specific flag validation because certain things are supported on Unix and Mac that aren't supported on Windows. And then you'll see the copy file W call. That's actually a Windows API call that will handle the copy for you. And then the rest of the code at the bottom is because of the little button on Windows where it'll return ebusy if you're trying to copy the same source and destination. So we try to do the copy operation. If it fails with ebusy, then we stat both of the files, and if it's the same, then the operation actually succeeded. It's not a genuine error. But from there, we're basically going to go back up to stats. We'll go back to we'll exit the event loop, go back up to the binding layer, back up into JavaScript. Next, I want to talk a little bit about the possibility of a libv 2.0. So this has kind of been an ongoing thing for a while. libv 1 was released in 2014, so it's now 5 years old. The project has been API and ADI stable since then, with a few, basically a few oopses on our side. But in order to do some cleanup that we'd like to do and add some new features that are breaking changes, we would have to bump up to 2.0. The problem with that is at this point that would be a rather large delta. But also, we have a small team, so there are hundreds of people collaborating on Node. I'd say there's less than 10 collaborating on libv, so it's a pretty big support job for the people who are working on libv to support a 1x and a 2.0. Even though some projects out there are already actually using the fake 2.0, so we have v1x, which is what Node and most people are using, and then the master branch in GitHub is what would be the 2.0. I think Julia Lang at least is already using that. But we've been going back and forth on this for over a year now, and I think we're starting to come around to the idea of just staying on v1 forever. There's something to be said for stability and things like that. It would avoid extra work on Node side of having to create APIs and APIs so the libv changes wouldn't break Node add-ons and things like that. So I think now we're leaning more towards 1.x forever. But we are still adding a bunch of new features. So this is just some of them that have landed in the past year. One of the ones that I guess depending on your use case could be a big feature is the maximum thread pool size has been increased. So by default it's still going to be 4 threads, but if you really need it, you can bump it up to 1,024 threads. Prior to that change, the maximum you can do is 120.
Before we move on any further and talk about things like streams and net module, adhesion module, and so on, we'll first have to take some time and understand the JavaScript object that Node.js gives us, and that is the event vendor object. So what exactly is this event vendor object, and what sort of problems it solves? Before I answer those questions, let's just very quickly include the object and use it. Now, I'm not doing anything crazy here. I'm just going to include the object and use it just to have a working program with the object. So I'm going to say const events vendor equals require events. Like this. Now, let's not focus on what exactly is this file, is this events. We're going to take a look at the source code and see what exactly it exports and what are some of the other objects that we have available. So with this event vendor object that I have, what I could do right now is to define So in the last lecture, I told you that in Node we have a few useful modules that are built into the core of Node. With these modules, we can work with files, with the operating system, with the network, and so on. So let's have a quick look at this built-in modules. Head over to nodejs.org, then go to docs on the left side,
go to version 8.9.3. That's the current stable release. Chances are by the time you're watching this video, this version might be different. So that doesn't really matter. Just pick that version. Now here in the table of contents, you can see the built-in modules. Of course, not everything you see here is a module. For example, we have console, which is our console object. We have buffer, which you're going to learn about in the future in this course. Again, that's a global object, but you can see that this is a fairly short list. And some of the items in this list are built-in modules in Node. So just that, you can see there are not many modules built into Node. I'm going to highlight a few very useful modules that you should be aware of. For example, we have file system to work with files. We have HTTP that you're going to learn about later in this section. So with this, we can create web servers that listen for HTTP requests. We have OS to work with the operating system. We have path, which gives us a bunch of utility functions for working with paths. We have process that gives us information about the current process. We have query strings, which is very useful in building HTTP services. We have stream, which allows us to work with streams of data. Again, you're going to learn about this in the future. And a bunch of other modules. Now, in this lecture, we're going to look at this path module. So on the documentation, you can see all the functions defined in this module. In this lecture, we're going to use the parse method. Now, if you scroll down, you can see how you can use this module. So you have seen the require function before. We call the module using the require function, get the result, which is an object, and store it in constant. So back in VS Code, in app.js, let's call require, and as the argument, use path. Now, the argument that we give to this require function, Node assumes that this is a built-in module. If there is no built-in module by name specified here, then Node looks for the existence of a related path to a file in this application. So if you have period slash or period period slash whatever, then Node assumes that this is a file in this application. Now, in this case, we're going to load the built-in path module and store it in a constant called path. So this is an object with a bunch of useful methods. The method we're going to use is the parse method. So I'm going to give it this underline file name, which is one of the arguments in module wrapper function that we saw in the last lecture. So let's call this and store the result in path object. And then finally, log it on the console as object. Now back in the terminal, let's run this application. So this is a path object. It has a few useful properties. We have root, we have dir, which specifies the path to the folder containing this file. Here's the name of the file, app.js. Here's the extension, and here's the name of the file without the extension. So if you want to work with paths, it's much easier to use the path module as opposed to working with strings. In the next lecture, we're going to look at another built-in module that gives us information about the operating system. Hi guys, it's Mosh here. Thank you for watching my Node tutorial. I just wanted to let you know that this
So the next question is, what is the purpose of the following flags in read-write operation on files? Okay, so R is used for reading, when you're opening the file for reading. An exception occurs if the file does not exist. Okay, so R plus, it's like you're opening the file for reading and writing. Okay, an exception occurs if the file does not exist. Then we have RS. This is for opening the file for reading in synchronous mode. Okay, it instructs the operating system to bypass the local flags in read-write operation on files. Okay, so R is used for reading, when you're opening the file for reading. An exception occurs if the file does not exist. Okay, so R plus, it's like you're opening the file for reading and writing. Okay, an exception occurs if the file does not exist. Then we have RS. This is for opening the file for reading in synchronous mode. Okay, it instructs the operating system to bypass the local file system cache. RS. This is for opening the file for reading in synchronous mode. Okay, it instructs the operating system to bypass the local file system cache. So this is primarily used for opening files on NFS mounts, as it allows you to skip the potentially stale local cache. Okay, so it has a very real impact on input-output performance, so don't use this flag unless you really need it. Okay, note that this doesn't turn fs.open into a synchronous blocking call. If that's what you want, then you should be using fs.opensync function. Okay, then we have rs plus. Okay, so this is for opening the file for reading and writing. It's like telling the OS to open it synchronously. Okay, coming to W. So W is like open file for writing. Okay, here the file is created if it does not exist, or the file is truncated if it exists. Then we have WX. So here you're trying to create a file, but if the path of the file really exists, then this fails. Okay, then we have W plus. This one. So here you create a file, but if the path of the file really exists, then this fails. Okay, create a file, but if the path of the file really exists, then this fails. Okay, then we have W plus. Path of the file really exists, then this fails. Okay, then we have W plus. This one.
So here
Okay guys, so welcome back again. So in this video, let's see that how do we scale our Node.js applications. So for those of you who don't know that Node.js processes are single threaded, that is whenever you start your application, it runs on a single thread that is inside a single process. And if you have a multi-core CPU, then it won't be utilizing the full power of that CPU. It would only be using the single core of that CPU. So to scale our application, we would be using the cluster module. And even if you don't have multi-core CPU, if you only have a single core CPU, then also I would suggest you to start your applications using the cluster module because it will provide you with zero downtime. That is, if in any case any of your instances go down, then the second instance will be up there running. So before diving into the code, let's see the results first. So here at the top we have the results for multiple instances of our application, and here at the bottom we have the results for single instance. So the target URL is the same URL here, that is localhost port 3000, and then the number of requests is 1000 requests with a concurrency level of 100. And we see that the total time taken to complete the request is 28.91 seconds in a single instance application that is running on a single thread, and the request per second that a server could handle is only 35. And if you look at the multi-instance application, then we see that the requests are same, the concurrency level is same, but the total time taken to complete the request is only about 9.29 milliseconds, and the total number of requests per second that a server could handle is 108. That is about 3 times faster. So now let's do some coding and let's see that how we can achieve this result. And after completing the application, we would be again doing the load testing. So the result would be in front of your eyes. So let's go back to VS Code. And here I've created a new npm project. And if you look at the package.json file, we have only two dependencies, that is the Express framework and the Node.1 dependency. And we have a single start script here that is Node.1 app.js. So now we can close the package.json file. And here I'm using one extension called REST line. So this is the extension which I'm going to use to make a request to our server. So if you don't know how to use REST line, you can go and watch my video. That is linked above and it's in the description also. So it's super simple to use. You simply install this extension and you simply create a file called rest.http, and here you can define a request like this. Since we are making a GET request, so we add in the GET keyword here and then the URL to which we want to make a GET request. So now let's go to our app.js file. So here I've initialized a very basic Express application and it only has an index route here, as you can see here. And then inside the index route I'm making some long running task that is going on after sending back a response of 4K here, and then we are listening on port 3000, and then we simply have a log statement here. So now if I simply do npm start, then we see that the server is started on localhost port 3000, and if you go to rest.http and if you make a request here, we see that we get back a response that says okay. So now let's close this and let's go to our app.js file. So now here firstly to use the cluster module, what we need to do, we need to require the cluster module, and we do not need to install any third-party package. This is all built inside Node.js. So what we can do, we can simply say const cluster equal to require cluster like this, and then const OS equal to require OS. That is the operating system package. And why I'm using this OS package, it is because to get the number of CPUs or the number of cores present inside the processor. So we can say const num CPU equal to os.cpus.length. It will give us the number of cores present inside the CPU. And now instead of listening to port 3000, what we can do, we can use the cluster module to check whether the process is a master process. If it is a master process, then we simply fork a new worker process, and then we start listening inside the worker process. And the master process would not be listening for any request, but only the worker process would be listening on some port. So now firstly what we need to do, we need to check if it is a master process. If it is a master process, then we create a new worker process as the number of CPUs present inside the system. So we can do it like this. So if cluster is master, if it is a master process, then we need to do something. Otherwise, we need to do something else. So if it is a master process, then we need to create a new worker process. So for that, we need to create as many workers as the number of CPUs present inside the processor. So we can do it using the for loop here. So for let I equal to 0, I is less than number of CPUs, and then I plus plus, simply like this. And now what we need to do inside this for loop, we simply need to use one method of the cluster module, and that is a fork method. So we can say cluster.fork to create a new worker process. And basically this cluster.fork uses the child processes.fork method. And if you want to learn more about child processes, then you can watch the video that is linked here at the top. So now coming back here, so whenever we fork here, then it will create a new worker process. So we know that if we are in this else block, then we are sure that it is a worker process, because here we are making an check, that is if it is a master process, then we are doing this thing here. Otherwise, we are doing this thing here. So we are sure that we are inside a worker process. And now what the worker will do, worker will simply listen on this port 3000. So let's copy this line and we can simply paste it here. And the beauty of these workers is this, that they all share the same port. We do not have to create different ports for different workers. And now one more we can log out here, we can simply log out the process PID. So we can simply pass in $process.pid like this, just to make sure that we are getting different PIDs for each of the workers. So now the work is already done or almost done. So now if we save this application, the application restarted because of mode 1, and we see here that our server started on these 4 processes with these PIDs, that is 56, 57, 58, and 59. And now if we make a GET request here, we see that we are getting back a response. But now let's see that which worker is sending this response back. So let's go to our app.js file and let me minimize this thing here. So here whenever we are sending back a response, let me add the process PID. So to see that which worker is sending back as a response, so we can simply use the dollar thing here, that is $process.pid. Like this, and now we can save our app.js file. The application again restarted, and IDs of the workers this time are these, that is 74, 75, 76, 77. So now if we make a request here, we see that we get a response from 75, that is 28075, and if we make again a request, we get back a response from 77, again 76, again 74, and again 75. So basically, this cluster module uses the round robin approach. That is, firstly the first request would be handled by 75, the second would be handled by 77, then 76 and 74, and then again by 75. So this is how this cluster module works. So now let's take it one step further. So let's go back to our app.js file, and what I want to do after sending back the response, I want to kill this block process here. That is, whichever worker is responding to a request, I want to kill that worker. So what we can do, we can simply use this cluster thing here, that is cluster.worker, that is the current worker, not kill. So now let's save this, and the application will restart. And now here inside this if block here, we can listen for an event on this cluster here. So we can say cluster.on exit, that is if any of the worker died. So here we have the worker, then the code, and the signal like this. And now here what we can simply make a log statement, that is this worker died. So we can simply make a log statement. So console.log, and here we can use the backtick. So we can say worker, and here we can log in the ID of the worker, and we can simply say died. That is the worker with this process ID has been killed. So we can simply get the worker's process ID like this, that is worker.process.pid like this. So now let's save this application. The application again restarted on these processes, that is these IDs here. So now let's go to our rest.http, and as soon as we make a request, we'll see that one of the workers will die. So let's make a request. So we see that we get back a response from 108, and that 108 worker has died. So if we know that we started these 4 workers here, and now only 3 are left because 108 has been killed. So if we again make a request, 106 has been killed. If we again make a request, 107 has been killed, and now we are left only with 1 worker. So if we again make a request, we see that all the 4 worker processes have been killed. So if we again make a request, we won't be getting back any response because there are no processes left to handle our request. So in this case, what we can do, we can go to our app.js file again, and whenever we see that a worker has been killed, what we can do, we can simply fork another worker by doing cluster.fork, simply like this. And now as soon as the worker is killed or it has crashed for any reason, then a new instance of that worker would be initialized, and we always have our 4 instances up and running. So this is why I was telling you that even if you don't have multi-core CPU, if you only have a single core CPU, then instead of using num CPU here, you can provide a number here that is 2 or 3, and then you will have that many instances of your application running, so that your application should have 0 downtime. So now let's save this application, and this time let's see what happens. So let's go to our REST client here. So let me make a request here. We see that 117 died, but we fork another worker here, that is 120. If we again make a request, we see 115 died, but we again fork a new worker.
class define objects and specify a way to inherit from this object. Now I'll use the ES6 class syntax to define my object and to inherit from this object. Now, if you don't know what classes are and what is inheritance in JavaScript,
programmers over the decades, right? Originally, you had to program your computer in machine language. Then there was assembly language. Then we had the sequence of higher level languages like Fortran and C or C++. And nowadays we have stuff like C# or Haskell or JavaScript that are even further away from the machine. And the justification for this is like, look, we're working at a higher level of abstraction. The higher your level of abstraction, the more work you get done because you don't have to worry about scheduling machine instructions and stuff. So we're really being smart and we're saving effort. And I think that's actually true. Like, I don't think we want to program things in assembly language. That's a waste of time. But somewhere through this chain, it becomes wrong. And that's how people are wrong a lot of the times, right? Like, you start out by being right and then you extrapolate it too far into wrong territory. But the important thing to all of this is that we only see one side of it. We see that we're being smart and saving effort, but we don't see the flip side of all of these things, which is that there's a corresponding loss of capability, right? Because I don't program in assembly anymore, I no longer am able to program in assembly, right? If I don't, if I use languages that are too high level, and I'm a little bit lazy, as people often are, I don't know where my variables live in memory or what they look like or even how remotely how big they are, right? I certainly don't know what the CPU is doing in response to the code that I've written. I may be scared to use non-managed languages because the very idea of memory allocation just seems too hard and scary. Or even if I'm a person who programs in a non-managed language, maybe I'm afraid of pointers and start generating this cult of being afraid of pointers and what to do about that, like the modern C++ people do, right? And so the rhetoric that we have is, I'm being smart, I shouldn't have to do the low-level stuff, right? But part of the reality is the loss of capability that corresponds to those choices. And both of those things can be true at the same time. I'm not saying that we're not being smart by going up some level, well, a little bit. I mean, there's a problem, which is that the point of going up all these levels is supposed to be to make everybody more productive. But programmers are not more productive now than they used to be. In fact, it looks to me like productivity per programmer is approaching zero, and if that's true, then where's the proof that going up this ladder of abstraction further and further is really helping? So the way to at least get a feel for this is you look at a company like Twitter or Facebook, it employs a lot of people, and you look at their product and you say, how much does that product change from year to year, right? How much functionality is added to Twitter year after year? How much functionality is added to Facebook? It's not that much, right? And then just divide by the number of engineers at the company, right? Which is thousands or tens of thousands sometimes. That's a very small number when you do that division, right? It's going to be pretty close to zero. So what's going on, right? And to illustrate again the difference in productivity, and it's not just me that thinks this, I'm going to show an excerpt from an interview with Ken Thompson, who is the original author of the Unix operating system, and he's talking about the time at Bell Laboratories when he first started making Unix on a computer that by modern standards had like no software at all, right?
At some point, I realized, without knowing it up until that point, that I was 3 weeks from an operating system with 3 programs, 1 a week. An editor, I needed an editor to write code. I needed an assembler to turn code into language I could run, and I needed a little kernel kind of overlay, call it an operating system. And luckily, right at that moment, my wife went on a 3-week vacation to take my 1-year-old, roughly, to visit my in-laws who were in California. Disappeared all alone, and one week, and we had Unix. Yeah, I think programmers aren't quite as productive these days. Yeah, he says programmers aren't productive these days like that, and everybody laughs. But it's funny, but it's not funny, right? It's really not funny when you consider like how much waste there must be in the difference between how productive people are and how productive they could be if everything wasn't so messed up, right? So I've made a case that robustness of software is declining, productivity of programmers is declining. So if you're going to say the actual technology of software is somehow advancing, it seems contrary to those two facts, right? So I think the argument that software is advancing is clearly false, except again maybe in tiny local bubble-like areas. So now why is it so bad? Why is it so hard to write programs? Why are we so miserable when we try to write programs today? It's because we're adding too much complication to everything, right? And I have a way that I think about this called you can't just, right? Where there's all kinds of things that you used to be able to do on a computer that you can't do today, right? So today you can't just copy a program from one computer to another and have it work, right? You need to have an installer or like a Flatpak on Linux or like containers if you're a server hacker news guy, right? And so people think this is cool. Oh, now we have containers. That's an advantage, or it's an advancement of software technology. All containers are doing is get us back to the 1960s when we didn't have to do any of this stuff, except it's actually not because it's adding all these steps that you have to do, right? And things you have to maintain. So now let's think about it for a second. Like, why do you need an installer to install software? Is it because of the CPU? Not really. Like, imagine you have, well, imagine you have some x64 machine code, and don't worry about how you got it into a computer's memory, but you just got it there, and you just jump to it. You set the program counter to that code. That code is going to do the same thing on a Windows PC as it does on a Mac, as it does on a Linux machine, as it does on an Xbox, as it does on a PlayStation 4, all right? Because all of those systems use compatible CPUs. So what's the installer for? The installer is to get around the incompatibilities that we added at the OS layer, which is this immensely complex thing that we mostly don't want, actually. And so we tend to think about operating systems as adding capabilities to a system, to the system of the hardware and the software, but they also remove capabilities like compatibility, right? And it's often very arbitrary, and it doesn't get any worse than I think it does for us today when it comes to shading languages. Anyone who ships 3D engines is going to know what I'm talking about. So it used to be that if you wanted to compile a program from many platforms, you could write it in some portable language like C or C++, and you might have to do some little if-defs to modify it for the different platforms, but you could do that, and it's supposed to be the same program. Today, you can't do that because we've decided if you're writing a shader, it needs to be in a different programming language on every single platform, even if the hardware is the same, right? So if you have an x86 CPU and an NVIDIA GPU, then on one OS you need to write your shader in metal shading language, and on another OS you need to write in HLSL, right? And they're different even though they're the same. And so you either have to rewrite everything n times, where n is large, or you have to start using auto translation systems to rewrite your shaders, and those come with a lot of complexity and annoyance and bugs. And why, though, a shader is a simpler program than the old programs that we used to write, but why have we made it harder to build a simpler program? It doesn't make any sense. We don't care, right? So the list of things you can't just do. You can't just copy a program, you can't just statically link, you can't just draw pixels to the screen. Oh my god, the number of steps you have to do to draw a pixel today is crazy. You can't just write a shader, you can't just compile a program on Windows without a manifest and stuff, and on these new closed platforms, you can't just run executable unless it's signed through this like whole process, right? And all of these things, and many more that are not on this list, add friction, bugs, time, engineering time, and headspace that keeps us from thinking about interesting things to actually do. Then when it came to giving a talk, it made me think about some things that transpired between both of our societies some decades ago. For example, in 1957, when the Soviet Union launched Sputnik, the world's first man-made satellite that orbited the Earth successfully. Back in the USA, everybody freaked out about this. They didn't like being behind in space and said, oh my god, we got to catch up. We have to get a satellite into orbit in 90 days, which seemed crazy. And it was. Our first attempt blew up on the launch pad. But the second attempt succeeded. That was January 31st, 1958. It was almost 120 days after that initial launch. It's pretty fast by modern standards.
Then April 1961, Yuri Gagarin became the first human being to orbit the Earth. And again, that made news all over the world. Everybody was very impressed by that. And back in the United States, people were upset because, again, we were behind. We were behind in what was becoming clear was the space race. And we didn't like that. And what were we going to do about it? So in May 1961, 1 month after that flight, our president at the time, Kennedy, made a speech to Congress saying, like, look, if we're going to catch up and not be behind forever, we have to do something big. We have to commit a lot of money, a lot of resources. We're going to go to the moon, right? And that was kind of a crazy idea. And in 1962, he reiterated this in a famous public speech. And he said, look, we're going to go to the moon before the decade is over. And that was crazy. It was really crazy because we hadn't done anything remotely like that. But lo and behold, eventually we did. So Apollo 11 launched on July 16, 1969. Before the decade was over. And just this year, there's a very good documentary that came out about this whole mission. What it is it's made of all original footage that NASA took during the mission that's been sitting away in cupboards and closets, and they restored the footage, and they sort of made a recreation of what it was like to live through this mission. And I'm going to play a short excerpt from that documentary just to give you a sense of what the scale of this whole thing was like. It's a lot, and it's crazy. We went from nothing to all that stuff in something like 12 years. Before Sputnik flew, we didn't have much of a space program in the United States, and in the end, we had all that stuff. And then, of course, after that, we continued to do space things, right? We made the space shuttle. It seemed like a really cool thing. It's like a ship out of science fiction. It could like take off and then land again. That's so great, right? Problem is, actually, most of it couldn't land, like those tanks in the background there, and therefore it was very...
It's completely fine. I'll talk about it in a couple minutes and give you some resources to learn about those things if you want.
Welcome back to Minute JavaScript, where I cover topics quickly and concisely. But first, today's video is brought to you by you and all my subscribers. So special thanks to Deepak, Gareth, Abdi, Chirag, Francisco, Nick, Sarath, Nando, Coolflame, Fabian, Yantao, William, Sam, and Mox. I really do appreciate you guys taking the time out of your busy schedule to watch my videos, and a special thanks to everybody who subscribes. It really is the support of you that keeps the channel going. So if you want to see more content like this, please like and subscribe. And now on to the show. So the project I have here builds a custom gallery, and as you can see here in the terminal, it takes about 90 seconds to build all of the images. And 90 seconds doesn't seem like a long time, but it really feels like an eternity when it's running, and I'd like to speed up this process. So I want to implement node clustering to take advantage of my multi-core system. I have 8 cores on this machine, and I think I can process the files a little bit faster. So I'm going to create a cluster to see how fast it speeds. Page. Really easy to set up, so I'm just going to import cluster. Let's just see what it looks like. Actually, let's just copy exit. So here's my master. 1 through 8.
Hello friends, welcome back to NodeJS tutorial. So we are discussing about the streaming concept. So basically what is stream? Streams are data collected from the source and brought to another location in a sequence. Means basically in simple language, stream is taking data from the source and passing data to the destination. So this is the simple step. So for this stream there are 4 types of category. This is the write stream, the read stream, duplex and transform. Today we are going to discuss about the duplex stream. So if I just take the overview from the basic, so what is basically read stream? Read stream is basically they will have some files, and from the files they will get the result and fetch from the input.txt, means from the source file. So this was the read stream. And then we discussed about the write stream. I'm going to add some data into some files, that is the destination files. Suppose I'm creating output.txt and it will dynamically create. So just put the name of your file, and if you just write something, and if you want to write something, then you can use the create write stream method, right? And by using this, it will print your data to the destination file. And the last thing we discussed about the piping concept. So basically, this is the combination of read stream and write stream. Means we don't need to write the streaming, read stream and write stream separately. Basically, pipe will directly pass the data from the source to the destination, right? Now, in this video, we are going to discuss about some new things, that is the duplex. So this is the one kind of streaming concept, and these all are related to the read stream and write stream. That's the reason I'm just overviewing these things, and I will recommend you please see my last tutorials so that you can understand it better. So I already discussed about the read stream, write stream, and the piping concept. So if you don't see that, I recommend you please see this, so you will get better understanding. Now, what is duplex stream? The duplex streams are fundamental category of streams in Node.js. This type of stream is basically hybrid stream, meaning it accepts read and write method while it's implemented, right? So as an example, we can see what is duplex streams, like any sockets, that is TCP socket, crypto streams, and there are lots of examples. Basically, duplex stream is responsible for both read and write stream. Now, let's create a custom duplex stream to delete some chunk data, right? So for this, we'll use the pass-through. So how to use this? Simply just create a constant and call the pass-through and write a require, and here just call the stream. So simple stream, and here just call pass-through, right? And I will going to call the pass-through, that is constant, and I'm creating some tunnel. So tunnel, and just call the new pass-through, right? So I already included the pass-through, so we can use this, right? So with the tunnel, we can check the data processing to the writable stream, right? So pass-through is basically a duplex stream that acts as a tunnel to pipe our readable stream to the writable stream. So already in the piping concept, basically it will directly pass the data from source to the destination, right? The pass-through doing the same things, right? Now let's read the file using the readable stream. So simply just create here and just write constant. So I will include both readable and writable stream, and will include the file system library. So inside the file system library, we'll get all the things. So simply write fs, and here simply write create read stream, and also we'll use the create write stream. So we both including these things, and now we have a file that is input.txt. So let's use this. So this is duplex concept, right? This is duplex concept in Node.js, and simply just write here constant and call the read stream. So here I simply read stream equal to create read stream, and here just I'm going to call the input.txt. This is the source file. So from the input.txt we'll collect the data, we'll read the data, and we'll print the data to the output, that is we'll use in this time write stream. So write here write stream, and simply write create write stream, and write any name. So here simply write output.txt. So don't worry, if you don't have output.txt, it will automatically create when we done the application, right? Now just use this tunnel and check. So simply just write here tunnel.on, and we'll get all the data from input.txt, and we'll call the event emitter, that is the data event emitter, right? So we call this, and here simply write chunk. So this is actually, I'm going to write a arrow function, and here in the function, we're just passing the chunk, and we can console this thing. So simply write console log, and let's see what happened. So simply just write bytes, let's print the bytes, and just write chunk. Okay, so our set. Now just pass all the data to the write stream. So using pipe. So simply just use the read stream. So I have taken this pipe read stream, and use the pipe. This is the pipe, and just use the tunnel, and tunnel equal to, not equal to, actually we'll pass the pipe into the write stream. So in this way, right? So now simply run this program. So simply write node and duplex.js. So simply we can see the bytes, that is buffer 54, 68. These are all things, and this actually cannot be understandable code. So here we can use the throttle. So besides the pass-through, we have throttle to delay how long data passes from one source to another in the pipeline. So let's see. So we can use duplex stream to set the delay of when the data is brought into our application. So simply create a class. Suppose you write class, and let's use the throttle class. So simply write throttle, throttle, and let's extend the duplex. So write duplex, 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 and let's call the duplex. So here inside the string we'll get the duplex, and inside this just create a constructor. So simply write constructor, and I'm just passing a time, that is I want to make some delay. So here simply write time, and I'm passing the time. So I'm calling super, and this dot delay. So we have here this dot delay. So we can use the delay using this, and I'm passing the time, right? And here simply just write underscore read, and we'll create a read function. So simply write read. Okay. And also we have another type of things, that is write. So we have a read function as well as we have a write function, and inside the write function we'll just pass all the chunk. So simply write chunk, and we need encoding, and we need some callback. So we'll get output to the callback, and here we'll create this dot push, and we'll push the chunk. And simply just use a setTimeout function. So just call the setTimeout function, and simply just use the callback variable from here, and that delay. So which we have actually set it from the constructor. So this delay. Okay. So now let's define the delay. So here we have a tunnel. So let's create a throttle. So we just use the throttle. So simply here just write constant, and write throttle. So here throttle equal to new throttle. So simply just write new throttle. Okay. And let's call these two things from here. So after the class is done, so let's split this. Okay. So now our aim is we need to get the amount of data. So simply write let, and suppose I'm taking a variable amount by default. I'm setting initially this is 0, and we're passing all the chunk, and let's concatenate the value. So simply write amount, and every time we'll add the data with the actual length of the chunk. So simply write chunk dot length. Okay, and here also we're getting console log and bytes. Okay, so all right. Now, if I just write this program again, if I just run this program again, let's see what is output. So we're getting the same output. So this actually is small file, and there is, so actually this is a small file, and I want some large. Suppose if we have one file, so I already have a sample cartoon. So let's use these things, and here simply for input stream, in read stream, just use the file that is sample.mp4 and here write new background.mp4. So this will be the destination, it's the output file. Okay, now let's see the output. So just clear this again and run node duplex duplex.js and let's enter. So we are getting there is lots of data passing separately. So we can see every time we are getting all the things, right? So basically we're going to pass some delay to the constructor. So simply by defining these things, just pass some 500 milliseconds and let's run this again. We are getting this type of things, that is the 65486, right? So this is the bytes, and in this way basically it's concatenating. So simply just remove these things and print the amount, right? And here just write this amount and let's see what is the difference and how data is and how the byte is transferring. So here you can see the byte is transferring. So in this way actually data is transferring from the source file to the destination file. So basically this is all of the duplex concept. By working with the duplex stream in Node.js, we can see how can we delay passing data from one stream to another. So in the real time, if I just see live matches or live streaming, actually all the videos are not uploaded, but we are getting all the things with a delay. Means suppose this is the 2302, this is the time, and this time actually live streaming started, and we can see that things with a delay. Means after starting with a 500 delay or 1 minute delay or 2 minute delay, we can get access of that things. That means the actual event are not completed, but we are getting all the things lively with some delay. So it is an important thing, and it's very much important in your digital world, and we use most of the time without us knowing, especially in socket. So this is the powerful features of how to implement both variable streams and both variable streams together. So I think you will like this video, and you'll get some live streaming concept, how live stream is working, and how we can get the live data from any live server. So hope you like this video, and still if you have any doubts in this video, please comment in the comment section. And next week we're going to discuss about another topic in Node.
What's going on, guys? Welcome back to a brand new video. This is Web Dev Journey, and in today's video we're going to be talking about a few things actually. We're going to be talking about piping streams, duplex streams, and also transform streams. These are essential streams that we need to know about, and you probably messed around with some of these already. You just didn't know, right? So let's get right into the video because this is going to be, I'm going to say a long video because I'm going to be long, but it might be, so I'm going to say it. Screw it. This might be a long video, okay? So you might be thinking streams while streams is fun to work with or very interesting to work with. There's a lot of things that we have to do, to get some streams out, right? Just to read some streams and all that. Well, to that I'm going to say you can actually delete all of this and also delete this little option that we have right here. We don't need that anymore. And simply what we do is really just pipe the read stream to the right stream, right? So all we have to do is just say restream.pipe, pipe, and we want to pipe it to the right stream. So whatever we're reading, we want to pipe whatever we're reading to this right stream that we have. So right stream. Just like that, right? So again, what we're doing is the same thing. Instead of wiring up a bunch of listeners to listen for chunks of data and then pass those chunks of data into the right stream, the pipe method is doing it for us. The pipe method also automatically handles back pressure for us. The only thing we didn't do is wire up an error message or an error listener, and we can simply just do that by saying dot on error. All we want to do is log the error. That's it. Get rid of that semicolon. And yeah, that's it. This is basically doing the exact same thing we had in our back pressure, but the only thing is that we only did it in this one line code. And I'll show you that it's working. I deleted the copy.mp4 because we're going to be redoing that. And if I do node pipe.js, this is the name of the folder, pipe.js. Oops. Right, error will have to find, I'm not meant to do log, it's supposed to be dot error. That's it. So control save this. Sorry about that, guys. We'll do that again. And there we go. And you can see that the copy.mp4 is right there. It, like I said, is doing the exact same thing. So any read stream can be piped into any write stream. And we're going to take more, we're going to look at that a little bit more. So let's actually delete this. Or I'm just comment this out so that we have reference to that. And what I'm going to do now is comment this out because we're not going to read that. And we're actually going, our read stream is going to be from our input, and we're going to be writing to a text file instead. So I'm going to say file, whatever, and then it's going to be a text file. So what we're going to be doing is reading from our keyboard, from our input, and then writing it to our file. So what we're going to do is say process.standard input. So stud in. Dot, what we want to do is pipe this, whatever our standard input keyboard, whatever that is, we're going to pipe it to the right stream that one we created upstairs. And the right stream is going to be creating right stream to a file text, right? So if I control save this, and let's try to do this right here, let's do node pipe.js. If I hit enter, it's waiting for me to do a input, right? So I can actually open up, you can see that I already created a file text. So if I do hello, hit enter, and then I say world, hit enter, lost one limit, word, that, enter again, right there. So as you can see, it's actually just typing our text from our input and then just, writing into that file text. I'm doing one time. This is only going to show once file.txt is closed. Then we open, right? If I hit enter, it's not showing, I have to get out, and there it is right there. Another way of looking at this, I'm actually clear this out, and I'm pretty sure you already know, you've seen this before where you could echo some stuff from your terminal, right? Hello world, and it would just say hello world. We could actually pipe this down to our Node.js application right here, and all we have to do is just say hello world and then pipe the Unix pipe, right? You've seen this if you work with Linux a lot, you've seen that little pipe. So we're going to pipe that to the node pipe.js, pipe. Right, so if I hit enter, essentially what it's doing is since we're piping the hello, the text hello world, it's going to write that to our file text, and if I open that, you can see hello world right there. And another quick example is, clear this out, is cat, cat, right? Cat is just going to give you the content of a file. If I do cat pipe.js, right, it gives me the contents of that file. What I have to do is literally just pipe that again, in pipe.js. So what I do is just say cat pipe, we're going to just use pipe, we're going to pipe this to the node pipe.js. Right, yeah, there you go. So if I hit enter right here, you can see that file.txt is actually just our program that we wrote here. Is exactly the same thing. So the pipe method allows us to pipe data from any readable stream to any writable stream. Okay. Now let's actually focus on. Now let's turn our focus to the duplex stream. Now a duplex stream is a stream that implements both a readable and a writable stream. Okay, it does both. These streams allow data to pass through. Readable stream will pipe data into a duplex stream, and the duplex stream can also write that data. So duplex stream represents the middle sections of pipelines. So what I'm going to do is get rid of this, and this back pressure. I'm just copy this right here. Create a new file. We're going to call this the duplex.js. Paste that in there. We're going to get rid of this high watermark. Don't need that. And what I'm going to do is again just by simply saying read stream.pipe. We're going to pipe everything to that right stream. There's nothing, I mean, you've seen it before we did it already. I'm not doing a duplex stream just yet, but this is what we're going to be working with. So in order to do a duplex stream, what we're going to be doing is grab the most basic type of duplex stream, which is called the pass-through. And we actually grab that from the stream module. So I'm going to say const over here, we're going to grab the pass-through, we're going to set equal to require, and it's going to be from the stream module as pre-built, and we're going to grab the pass-through. That's why it didn't work. Man, I was like, why isn't it working? So now, okay, there's pass-through, right? So this is basic duplex stream. And if you don't know too much about it, like I said, we're going to look at this, but you can look at it in the Node.js documents as well. And then after this, we're going to create a new pass-through stream called report. So I'm going to say const report and call and equal to pass-through, or actually new pass-through, And this is our report stream now, or our new duplex stream. We just call it report. And when I say that the duplex stream represents a middle section of the pipeline, that means that we just put them in between readables and writables. So right in between this readable stream and this writable stream, what we're going to do is just say we also want to pipe our new report stream down here as well. So a duplex stream can be piped between a readable and a writable, so it means that a duplex stream can receive data from our read stream and send that data to our write stream. Okay, so you might be wondering what's the point of implementing a pass-through stream, right? And well, there's several reasons, but basically if you just wanted to see something about the data or report on it. Okay, now I do want to say that a typical duplex stream doesn't change anything about the data. There is a type of duplex stream called transform stream, which we will talk about later in this video. And technically, yes, pass-through stream or the pass-through is a transform stream, but we're just going to use it as a basic duplex stream in this example. So what I'm going to do is simply just say we're going to just count how many chunks of data is being passed through. That is it. So I'm going to say total. We're going to set that equal to 0, and what we're going to do now is if we're going to report on that data, right? Since this report stream is a readable and writable, we can actually add listeners to this, right? So right here I'm going to say report dot on. We're going to add the data event listener, meaning that once it receives data, we're going to report on that, right? So we're going to have a chunk. We've done it before, chunk, and we're simply just going to increase that total. So we're going to say total. We're going to plus equal chunk dot length. You've seen it before. This is nothing new, and all we're going to do is log out the bytes. Oops, and it's going to be the total, whatever the total is at that moment, which we still have not created yet, right? And we're going to do flex. We're going to grab the flex right here, and up above we're going to create a class called throttle, and it's going to extend our duplex. Duplex right there. And we do need to have already some functions inside this duplex called read and write. Remember, duplex are a combination of both a readable and a writable string. So it's going to have automatically the read function and also the underscore write function as well. We're also going to have a constructor up here, constructor, and we are going to be passing in milliseconds, like you see right here, 10 milliseconds size constructor. We're also going to invoke super without the ms, and we're going to just set this dot delay. We're going to set that equal to the ns that we have upstairs, and that's pretty much it for that. So when we're reading or writing the data, we want to throttle that write, right? We want to throttle how fast it's going to write. So in the read section or the read function, what we're going to be doing is this dot push. Now remember, this dot push is referring to the stream itself, so the throttle stream. So this dot push we're going to be pushing. By the way, sorry, I'm getting ahead of myself. The write method, you already know that the write method is going to have a chunk. These are already things that the write method already has, right? So the write, when you're writing to this function, it's going to have a chunk, the encoding type, and also the callback. Encoding, there you go. So we're going to this dot push the chunk out. And also, like I said, this is where we want to throttle that how fast it's writing, right? So we're going to set timeout on this. We already know how to do that. We're going to call back. We're going to call the callback once this delay has happened. So once the 10 milliseconds has passed, right? So delay. There you go. And I am going to add in one more function called final. And this basically once there's no more reading being done, there's nothing to read anymore. So once this happens, what we want to do is this dot push null. So that way we just stop reading and stop writing. Control save this. Now let's try this out. If I clear this out, wait, sorry, we can't write out. The reason why is because we haven't even piped that. So what we're going to do is literally just say pipe. Like I said, this is the middle section, right? So we can put this anywhere we want. So we want to pipe the throttle. I'm going to do it like this. Dot. There you go. Throttle. So we're going to pipe the read string through our throttle first. So basically right here, this is what's going to happen, right? It's going to push the chunk into the report. So we're going to see that console log, and then it's going to delay for 10 milliseconds, and then redo this again. Put the chunk, delay, push the chunk, delay, push the chunk, delay, right? It's going to do that all the way through. So we're going to see this right now. Let's open this up. Let's do node.js. And you can see that look at this. You're actually seeing it delay, right? This is much more slower than what it did in the first time. And to really get a clear view of this, we're going to actually delay 100 milliseconds. Where's that right here, right? And you're going to see it's going to really slow down. Look at that. Pretty cool, right? Control C. So as you saw, duplex strings are a necessary component when you want to compose strings into a complex timeline or complex pipelines, not timelines, pipelines, right? The duplex string implements both a readable and a writable side of things, so therefore they represent the center parts of a pipeline. And the last thing we're going to be talking about now is the transform string, which we could transform the string coming in. So what I'm going to do is, actually I'm going to grab this, copy this, delete all that stuff, new file, and we're going to call this transform.js. There you go. Paste it, and you have to actually grab the transform from the stream module. There is something called transform. There it is right there. Right? So transform strings are a special type of duplex string, okay? Instead of simply just passing the data to the read stream and to the write stream, transform strings change the data. Transform strings are the center pipe pieces that can be used to transform data from readable strings before they are sent to the writable strings, right? So that's what we're going to be doing in this video, or in this part of the video. So what I'm going to do is actually create a class, and we're going to just call this replace text. Basically, we're going to write a text out, and we're going to replace it with a character of our choosing, right? So replace text, txt, and this is going to extend the transform. There you go. We're going to have a constructor, obviously. Constructor, obviously, right. We're going to invoke super. Also, we're going to grab, remember, so I do want to explain what replace text does. So what this is going to do for us, so every time we write a string call, let's say hello, right? All we want to do is replace all those characters into x's. So this is going to spit out, it should spit out just that, just x's, right? Or replace it with any type of character you want to. So you want the s's, it'll be s's, right? That's an s's, whatever. You know what we're trying to do, right? So we're going to be passing in a character into the structure, and we're going to add this dot replace char. We're going to set equal to the char that we passed in. Now, unlike the typical read and write string, where if you want to create methods for those have automatically the read method and the write method, transform has different types of methods. It actually has the transform method, and that's right here. And this is basically the same thing as the write method. So we're going to have a chunk being sent in. We're also going to have the encoding type, and also we're going to have the callback. Okay. And what we're going to do here is literally create a little, we're going to replace all our text with that character that we have. So I'm going to create a variable called const, it's called transform chunk. Chunk. We're going to set that equal to chunk. We do need to read it, so chunk.toString. Remember, we've talked about that before. And I'm going to replace everything. What I'm going to use is regex expression for this, but I'm going to replace everything with this dot replace char. Replace there you go. Replace char. And the regex expression I'm going to use is anything coming in as lowercase a through z, or uppercase a through z, or any numbers that are coming in 0 through 9. I'm not going to do my bracket right there. So anything as lowercase a through z or uppercase a through z or numbers coming in, we're going to replace everything with the replace char, whatever this character might be. Okay. So once we do that, what I'm going to do is we're going to this dot push. We're going to push that transform chunk into our string, and also we're going to call the callback. And that's going to be error code. It's const like that. Okay. And another method that we're going to add is the flush method. And basically, once the read stream is done, we can add more data or more things to the write stream, right? If we wanted to. So in this case, it's going to have a callback, and what we're going to do is just this dot push. This final thing, we're going to say more stuff is being passed through. Right. And that's it. And we're going to call out the callback once again. So this is our replace text string. Now all we're going to do is create a new instance of this. So we're going to say const. I'm going to call it x string because we're going to create a new replace text string with the character x. We're going to replace everything with the x, right? And all we have to do now is just pipe this through our read string, pipe it, and then going to our write string. So what I'm going to do is just say process, because I want to read from the keyboard. So anything I type in the keyboard is going to be transformed into like this. So process dot in or standard input, right? Dot pipe. We're going to pipe our x string first of all. X string. Why isn't it doing it? It should be grabbing it automatically, right? So we're going to pipe our standard input through our x string first, and then what we're going to do is pipe that to our console, right? So I can say console log, or I can do another type of way, which we've done. Process dot start out, right? And that's it. So we already know that any read stream can pipe anything to a write stream. So let's see this in action, right? So let's go here, clear this out, and we're going to node transform. There you go. So if we say hello, you can see that it transformed our string into all the x's, right? And we can see all I can see is x's. There it is. Now, there are a lot of transform strings out there, right? Node.js comes with the zlib package. That's a transform string that can be used to zip incoming data from the read stream and send compressed data to the write stream. Crypto is a NPM package that has transform strings that can encrypt data chunk by chunk and then pass encrypted data to the write stream, or decrypt data from the read stream and pass the decrypted data to the write stream. So transform strings are the essential part of the string family, all right? So that was it for this video.
In previous lecture, lecture, we learned how an asynchronous JavaScript code gets executed behind the scenes. We also learned that the callback function associated with an asynchronous code will have to wait for its execution either in the callback queue or in the microtask queue. Most of the callback functions associated with an asynchronous code have to wait for the execution in the callback queue, but there are some callback functions, for example, the callback function associated with the promise, waits for the execution in the microtask queue. Once the call stack is empty, the event loop pushes the callback functions from callback queue as well as microtask queue to the call stack for the execution. And we also learned that the microtask queue takes priority over the callback queue. That means the callback functions which is there in the microtask queue will be executed first, and once all the callback functions of the microtask queue are executed, then only the callback functions of callback queue will be executed. And we are going to understand the same thing in more detail in this lecture. Now, before you go through this lecture, I highly recommend you to go through my previous lecture where I've talked about how an asynchronous JavaScript code gets executed behind the scenes, because we are going to make use of the topics which I have covered in that lecture. Here, we have a very simple JavaScript program. And in this program, first of all, we are logging a message in the developer console. And then we have this setTimeout function. And for this setTimeout function, we have specified a callback function and a time interval of 0 milliseconds. This means this callback function should get executed immediately. And that is because we are specifying the time interval as 0 milliseconds. Similarly, we have a promise here, which is getting resolved immediately. So on this promise, we are using this resolve method, which will resolve this promise immediately and it will return this resolved data. And in this video, we will explore the URL module in Node.js. Currently, we are in section 3 and we are about to check out the last video, that is fourth video of this section. So again, before you start, make sure you download all of these files from the link in the description. Once you do it, you will get those files within this folder of 3.4 URL module. Once you get it, then in your terminal, navigate to that folder of 3.4 URL module. So let's begin. Now a server can be invoked by a particular URL coming from the client. So suppose this is the requested URL, which looks like this. This is our main domain name. It could be google.com or smarter.com, followed by /user. Now this part is known as the path name. And then I have a question mark. Now in a URL, when you encounter this question mark, then generally it is actually the query parameter right after it. And the query parameter appears to be in the form of key value pair. For example, this is the key equal to its value. And then I have another pair such as key city and the value as Delhi. Now these two key value pairs are separated with the help of an ampersand, which you can find it here. And in case you want one more key value pair, then simply put an ampersand in the end, followed by another key value pair. Now you might ask how to create such URL in the client. Well, it is something which I will discuss in my some other course. Since it is a Node.js tutorial, so let us focus on its concept. Now in the server, how to parse such URL. So for that, you have to use the URL module. Just use the query syntax followed by the URL module. You will get the URL module object here. And right now let's make it as constant. Always start your variable with the constant keyword. Now to parse that URL, you have to use url.parse method. And as the first parameter, pass the requested URL, the incoming requested URL, followed by true. This will give you the parsed URL object. Once you get this object, you can call its properties to get the values out of this URL. For example, if you use URL object.host, then this statement will simply return this part. That is your main domain name. Fine. Now what about this part, /user? Well, this part is known as the path name. So for that, I have the property of path name. Pretty simple. So this will return /user. Now next comes the query parameters right after this question mark.
Well, this can be extracted by using the search property on this URL object. So this will return this whole part along with the question mark and also the ampersand in between. Fine, like this. Now if you want, you can also verify these output by using the console.log statement. Save the file and run it in your terminal. Well, these are the exact same output as predicted. Now this query parameter still needs to be more simplified. So how to get individual query parameter out of this search property? So for that, we can do URL object.call the query property. Now this query property simply returns the object, and this object contains the elements in the form of EL pair like we have it here. For example, it will have the country property with the value of India, and another property such as city with the value of Delhi, which you can find in this URL, Delhi and India. Quite simple. Now you can get this object in a variable, let's call it query data or the query object as per your wish, and then you can call query data the property name such as country. Once you call the property, here you will get India. Similarly, you can extract the city. How cool is that? Now let's print it out. If you want, you can also verify it. So here we go, these are the two predicted output represented. Now moving ahead, on the right I have one more example file such as 2file.url.js. But in this example, I will combine the file system module that we discussed in the previous video. Along with this, I will use the URL module. Let's see how to do it. So here I have included these three modules which I want to use. HTTP is the most common one. Then we have URL and FS module. Here I have written the code to create a server and then listen to a code. Now on the right I have two files, demo1.html that has some content of January, and then I have demo2.html that will print out something related to February. Now my objective is to parse the incoming URL, and as per the incoming URL, I have to send back the content of either demo1 or demo2. Fine. For example, if I have the URL of domain name slash suppose demo1.html, then in that case I have to send back the content of this file. And if it is demo2.html, then accordingly I have to send back demo2.html content to the client. Fine. So here I will again write code to parse the incoming URL. Now this code is very similar to what we have written here. Fine. And this REQ is basically the HTTP request object coming from the client. And then I can get the path to this demo1.html. I've used dot and then I've used URL object dot path name. Now this will represent this part on the right slash and then demo2.html, whatever is on the right of the main domain name. And this whole statement file name will actually represent the path relative to the current file, such as 2file URL.js. Fine. So that is why I'm using dot slash demo2.html. Thereafter, I use the file system to read that file by using the read file function. Pass the file name as a first parameter and call that function in case if there is any error, or if you have a success reading that file. I will now define my header and then use the write function and pass data. Now this data is basically the file content as requested present in this file of demo2.html. And this write function put that data in the body of the HTTP response object and then end response. Now let's also write some code if in case there is some error. And this is basically useful in case if the user requests for some file that does not exist. Suppose if the user requests for XYZ file that does not exist, so in that case we will show a page of 404 not found. Send back the 404 status code along with the statement 404 not found. Save it and now run this file.
Olá, meus amigos, tudo bem? Bem-vindo a mais um vídeo nessa série. E você que já está acompanhando ela, sabe que no último vídeo nós fizemos o cadastro de usuário, e nesse a gente vai estar implementando o token, né? A gente vai estar fazendo o método de login do usuário, retornando para ele o token, no qual ele vai persistir esse token nas demais rotas que serão protegidas, né? A gente ainda não vai entrar tanto em detalhe ainda da utilização do token em si nas outras rotas, mas pelo menos nesse vídeo eu quero mostrar para vocês como a gente vai fazer.
Welcome back to Web Dev Simplified. My name is Kyle, and you can imagine when you're using the web, almost every single website that you use has some form of login component to it, where you have a user account, you can log in, log out, etc. And I bet you the project that you're thinking about working on also has the exact same login component. So in today's video, I'm going to show you the boilerplate template for how to set up your very own login system inside of your application. Let's get started now. Before we jump into coding, let me show you the absolutely beautiful looking website that we're going to build in this video. Well, maybe not so beautiful. We have here the login screen. We can click register and go to our register screen. And let's say that we register a user here, just a very basic user. Click register, it'll bring us to our login page. And then if we want to log in, let's say we choose an email that doesn't exist and we're going to choose password and click login. It'll tell us that the user with the email doesn't exist. And if we actually log in with the correct email with the wrong password, it'll tell us our password is incorrect. And finally, if we type in both the same email and the same password and click login, it's going to bring us to the page, display our name, and give us a logout button. Also, if we redirect to that login page, it's actually going to redirect us back to this home page because we're already logged in. As soon as we click logout though, it's going to bring us back to login. And if we try to go to that home page, it won't let us. It's just going to redirect us back to the login page. So now
Yo, what's up guys, welcome to your 14th Node.js tutorial, and in this video I'm going to talk about readable streams. Okay, so we saw in the last tutorial how streams and buffers kind of work behind the scenes, and in this tutorial I want to show you how we can make our own custom stream in Node.js. Now, there's a couple different types of streams we can create in Node.js, or writable and readable streams. So what's the difference between them? Well, a writable stream allows Node.js to send data or write data to the stream, and a readable stream allows Node.js to read data from the stream. And we can actually create a third type of stream which can do both, write to the stream and read from the stream, and this is called a duplex stream. So you can imagine when we're sending a response to a client from Node.js, we are sending the client some data. So in this instance, we'd be talking about a writable stream because we'd be writing data to the stream that's going to be received by the client, the browser. And vice versa, if Node was receiving data from somewhere, like reading a file or receiving a request, then we'd be talking about a read stream because it would be reading data coming in the stream. So let's take a look at an example. Okay then, so I'm back here in app.js, and I've gone ahead and commented out that server we made a couple of tutorials back. I'm keeping it there because we are going to be using it again in a couple of tutorials time. But I've commented it out for now because we're just going to look at creating a read stream in this tutorial. Now I've also created a readme.txt file, which is basically a load of junk or lorem, and I've just copied and pasted this off the internet. I grabbed loads of lorem and pasted it in there. So this is what we're going to be reading in the readable stream. Okay, so how do we go ahead and create one? Well, first of all, we need to use one of Node.js's core modules, and that is the FS module, the file system module. And we use this module to read a file. And this is kind of like the same thing, but we're doing it in a different way. We're reading it through a stream this time. So let's go ahead and get that module. So we'll say var fs equals require, and then fs. So now we can use this. And to create a readable stream, we need to use a method called create read stream. I'm going to store this in a variable. So I'll say var my read stream. You can call this whatever you want. And I'm setting this equal to fs, then create read stream. Okay. And this is going to create a readable stream for us, which we can read data from. So what we need to do is specify and tell Node.js which file we want to read through the stream. So I'm going to read this one right here. So what I'm going to do is use the dir name property on the global object first of all. That's going to get in my current directory. So this one right here. And then I'm going to concatenate that with the file name. So /readme.txt. Okay. Because it's going to be in this directory. Then we need to do / after that directory because we're in it, then the file name. So now we're going to go out and create a read stream which is going to read this file. So what's going to happen is we're going to read this a little bit at a time. It's going to go out, find this data, then this data is going to be read a small amount at a time through the stream. It's going to fill up the buffer, then that buffer is going to pass the data on in chunks. Okay. So it's going to essentially split this data up and pass it on in chunks to this variable. Right there, okay? So what we can do is we can kind of recognize when we receive one chunk of data. So the first piece that comes back to us. And we can do that because this create read stream inherits from the event emitter. And there's an event called data on this create read stream, which allows us to listen for when we receive any kind of data or any kind of chunk of data from the stream. So we'll go ahead and set up a listener that's going to listen out for that and then fire a function every time we receive something. So let's say my read stream and then listen for event. So that's dot on, and then the event is called data. And then we're going to fire back a function every time we receive some data, and then this data is now called a chunk. Okay? So we read the file, it fills up the buffer passes that chunk on, and every time it passes a chunk of data on, it recognizes it because we're listening for that data event, and we fire this function. Okay? So now what we can do inside here is console.log new chunk received, and then we can do another console.log and actually log to the console the chunk itself. Okay? So if I save that now and run it in Node, just have to wait for this to load, and I say node app, then you're going to see here new chunk received. Okay, so we've received a chunk and it's fired this function on this event, on this data event, and then again it does the same thing down here, new chunk received. So it does it twice. So we're getting two different chunks from this file. It's split up into two. And if this file was much larger, then we'd receive maybe 10 chunks or 20 chunks. Okay? And every time we receive one, we fire a function and we log that chunk to the console. Now, you see right here, this chunk is just a buffer. It's not the text itself, we're not reading that. And that's because we've not specified right here the character encoding. So we can do that if you want. We can go ahead and say UTF-8, because at the minute, this is just a full buffer that it's sending to us. It's filling up the buffer and it's passing it on. But if we say UTF for the character encoding, then we're going to receive it as that text that we want. So if I save this now and run it through Node again, Node app, we're going to see all that text. And I have to scroll up a long, long way to see the new chunk received text because there is absolutely tons of this. But if we keep on going, and hopefully, eventually we will see it. Have faith, guys. There we go. Okay, so new chunk received. And we got all this text. And there will be another one of these messages halfway through something. But I really don't want to waste your time or my time by looking for that. So you just have to take away from it. There will be two of these chunks received. Okay? So that's what we're doing. We're reading the data in chunks via stream. And every time we receive a chunk of data, we can do something with that. And you can compare this to the other method we used to read a file a few tutorials back, which was called fs.readFile. And what that did was go out and grab a whole piece of data and wait for it all to be stored in memory before it fires a callback function and we get all the data in one big piece. This time we split it up into small pieces. And the benefit is every time we get a small piece of data here, we can send it on to the user using a writable stream. So we can pass it on to the client that way, a bit at a time, rather than waiting for the whole thing to be read. Okay, makes sense? So we're going to see how we can do that by creating a writable stream in the very next tutorial. Any questions about this, feel free to leave a comment down below. Otherwise, guys, I'll see you in the next one.
What's going on, guys? Welcome back for a brand new video. Wait, to a brand new video. This is Web Dev Journey, and in today's video, we're going to be talking about readable streams. We are going to get into the other streams, writable streams, duplex, transform streams, but right now, in this video, let's take it slow. This is probably a topic that everybody knows, or probably doesn't know, so we're going to be talking about readable streams. Now, if you did not know, a readable stream reads data from a source and then feeds it into a pipeline bit by bit. For instance, we can create a readable stream that can read from a source array, like this one right here that we have right here, advices. Take a moment and just, this is golden advice, right? So take it. So what we're going to do is we're going to create a particular type of stream that can read the data from the array and then pass it along chunk by chunk. So let's say, let's see what that would look like, okay? I'm going to go ahead and create a new instance. Don't worry, a new instance of this advice stream. So I'm going to say const advice stream. I'm going to say stream, right? And we're going to create a new instance of this using the class stream from array, but we don't have this just yet. So stream from array. We don't have this just yet. We are going to be building this class, but right now what we're going to be passing in this class is the advices. Okay, advices. There we go. Now, streams also trigger events, and some events that we're going to be looking at are data and end. So basically, the data event, once the data event is triggered, that just means that a little bit of data is passed back to the callback function. And let's try that right now. So we're going to say from the advice stream, right, we're going to call on the data event, data, there it is. Like I said, it's going to be something passed back to the callback function, and we're going to call this chunk, right? This is a chunk of data being passed back. So for right now, what we're going to do is just log out, console.log, and then chunk. So that way we see what exactly what does it look like, right? What does this chunk look like? Chunk, don't know why there's like semicolon right there. Now, another event stream that we could talk about is the on end. If you want to figure out when the stream ends, you call on this event, and well, this is kind of self-explanatory, right? It ends, right? So you know it ended. So you want something to do once the stream ended. You want to do something else. Right now, we're going to log out. What? Log. Okay. We want to log out. Done. Something like that. Just like so. Okay. Now, since we are creating a stream, we're going to be using a module called stream, and we need to grab what happened. We need to grab the readable stream from that module. So const, sorry. Something we're going to grab that from require, and this is already a pre-built module. And it's called stream. There it is. And I think can I grab it now? Please. There it is. Readable. That's all we want. This is the module that we need. The readable stream module, and we're grabbing it from the stream module. Okay. Now down below this, I'm going to be creating a class. Not const class. Stream. Where's that? Stream. I'm going to copy this. Stream from array. We're going to create this class. We're going to extend the readable. Right. It's going to extend readable. So readable. Good. We all know I can't type, so this is not surprising. I'm struggling. So whenever we extend readable stream, whenever we extend readable stream, we want to implement a read function. What we're going to do is do read. Right. We're going to implement a read function. So the read function is what happens when the stream reads each chunk of data. So in this function, I need to read bit by bit. So in this one, we're going to do this dot push. We're going to grab this. Actually pushes this data into the stream, not to the array, not anything else, but to the stream, right? Next, we're going to increment it by or greater than this dot array, and it's going to end the stream. Okay. Now I'm supposed to of data that sends in, right? This chunk is showing us the binary data. And now we're going to say we want the encoding to be variable. You can see, hey, here is our what's it called? Our devices. Now, like I said, there's another type of mode, and that's the object mode. So we can pass binary data to a read stream. We can also pass string data by sending the encoding type, and I can also specify whether the object mode of our readable stream is on. So let's actually create let's actually convert it into a readable to an object, right? So this is object mode. So this go here, and we need to say we need to tell the read. I'm just copy this. We need to tell the stream, hey, this is going to be running on object mode. So I'm going to say object mode. We're going to set this to true. It takes a boolean for true, and I'm just put this on the side so that way you know that encoding converts buffer to string. So that way when you get to GitHub, know what this is, right? So right now we're saying that, hey, we want the stream to be bam, check that out. We got our first one and 0, 1, 2, 3. And take notice that it does creating a stream if Node.js are there's more to this, but this is like a basic stuff. Here you go, FS. And this is the exact same thing that we did. We pass anything. And it's going to say it's going to send some chunk to the callback function. So we also have the on end, which is doesn't pass anything. And it's going to then when I didn't talk about, but there is a error event. So if an error does occur, what we do is just log try to do node. So node readable class, not class FS. There you go. You can see that it's very long because this is MP4. So anyways, you can see we have this buffer chunk. This should not need to be more. You do have a little chunk, right? And then when we do FS, you can see that here it is the size. It is a readable stream. We do on and listen for that data. Or listen, let text, we're going to set that equal on. So if I type in, well, hello, you can see hello back. And just make it a little more clear, I'm going to say echo. Right here, echo. That's what you see right there, so that way you know exactly what's going on. Do this out. Let's try again. Okay, so if I say hello. So this is waiting for an input to be standard input, which is a keyword. It's waiting for input to come in so that way we read that piece of chunk or piece of data. So this one we need to ask for the data. So to read the stream, and it's going to be reading the flowing mode, which is going to read all the bits without pausing anything. Which is going to enter back into flowing mode, which is just going to like fill out all the rest. So I hope this video helped you with at least the readable side of streams. Now we're going to get into the writable side of streams in the next video.
Hey guys, welcome back to the series of NodeJS. This is me. आज की हम बात करने वाले हैं DNS फोल्डर के बारे में। आज हम DNS फोल्डर यूज करते हुए आप इस तरह से होस्टनेम को आईपी एड्रेस रिजॉल्व कर सकते हैं। जानेंगे कौन सी एपीआई DNS फोल्डर है। जिसकी हेल्प से अपन होस्टनेम को आईपी एड्रेस रिजॉल्व कर सकते हैं। किसी भी वेबसाइट को IPv6, IP4 एड्रेस जानना तो किस तरह से अपन जान सकते हैं। तो लेट्स गेट स्टार्ट।
Hi and welcome to the video training of Node.js. In today's video training, we will learn how to get user location using Node.js. We will be creating a small utility using a npm module called setLies. setLies module fetches the user information based on IP. So first of all, we need to install this module. Let's go to console and realize our project. Yeah. That will the setLies module IP address and index.js continent code EU your
Your IP address can be quite revealing. Even your general location can be found with the IP address. So it makes sense to change it, not only to protect your online privacy, but also to access content unavailable in your location. In this video, I'll tell you exactly how to do that. Prepare for a step-by-step tutorial on how to change IP address. For more tutorials, reviews, and privacy news, consider subscribing to our channel. So the IP address is your unique and universal identifier online connected to your router. It's associated with you and websites. ISPs and network owners can monitor and track your online activity and even real-life location with it. Can you change your IP address to avoid that? Yes, you can. Changing IP address prevents the websites you're visiting from tracking you through your real IP address and allows you to access previously inaccessible content. For example, getting an American IP will allow you to watch Netflix US and so on. Before changing an IP address, you can check the current one on a website called What is my IP address? See how it shows your general location too? After you change your IP address, you will be able to see how the website detects a different location. Here are a couple of ways to change your IP address. Firstly, you can change your access point. For example, when you switch to a different Wi-Fi source, you'll get a different IP address. However, if you have only one router or you don't want to jump between random Wi-Fis all the time, that's not the best method. There's one more thing. This way you'll only change your IP address, but your location or country remains the same. Plus, your connection won't be encrypted either. Fortunately, it's not the only way. You can also use a proxy server to change your IP address. This is configurable in your browser and it changes your IP address as long as you're within the browser. This will also change IP address location if you choose a foreign proxy server, and that means you might be able to access certain geo-block content. Some streaming platforms like Netflix, however, usually detect and ban proxy servers. It's very easy to change your IP address on Windows 10 with this method. It is also good for general browsing, but it offers no protection to your data. Can VPN change IP address? It's an often asked question, and the answer to it is yes. Actually, changing IP address with VPN is the most efficient and useful method, and here's why. Virtual private networks reroute your standard connection to a remote server, assigning to you an IP address from that server. This way, at the endpoint of your connection, whether it's a website, a game, or anything else, the IP address of the VPN server and its location will be shown, not yours. VPNs also apply encryption to your connection, making sure that even if your traffic is intercepted, it doesn't reveal anything about you. With VPN, you get good protection alongside IP address change, and you can access geo-block content, depending on your VPN provider. There are lots of VPNs on the market, though, and choosing one may be hard for a casual user. I personally recommend taking a look at NordVPN, Surfshark, PrivateVPN. They are amongst the best in terms of speed and security, and they have a money-back guarantee. Plus, PrivateVPN has a 7-day free trial. Surfshark offers the same free trial for mobiles and NordVPN on Android. They also unblock Netflix, so if you want to change your IP to watch some geo-block content, they are a good choice. So is ExpressVPN, which is more expensive and doesn't have a trial, but it's one of the best VPNs in terms of quality. IPVanish and CyberGhost and Viper VPN are also some good options with good performance, protection, and speed. They are all good at concealing your IP address. But those are paid options. Some free VPNs can also boast good performance and ability to change your IP address effortlessly. With ProtonVPN, Windscribe, and Atlas VPN, you can be sure you don't have to pay a penny to change your IP address. However, you would need to purchase a premium version if you want to access Netflix or other streaming platforms. VPNs also often have apps for all major platforms, so you can change your IP address on Android or Mac and so on. Guys, I hope now it's clear how you can change your IP address. Leave this video a like and remember to check our channel out. There are more tutorials and news there that you might find interesting, so consider subscribing. Thanks for watching, and I'll see you again soon enough.
So in the last lesson, we looked at setting up client servers with the HTTP and net modules, and there is also a DNS module, which you'll probably very rarely use, but I thought it was worth just doing a quick tutorial just to show you what you can achieve with the functions that the DNS module provides. So if you don't know what DNS actually is, in a very simple nutshell, it's the conversion or translation of domain names into IP addresses. Because of course, computers don't really understand the textual representations of things, they like to work with numbers and binary data. So if your domain name on the internet, like facebook.com, google.com, or twitter.com, points to a server or a group of servers that are represented by an IP address. So let's create a new file and see how that works with the DNS module in Node.js. And of course, we'll require the DNS module, and let's call the DNS lookup function. And really, the lookup function takes two arguments, the first being the domain we want to look up, and the second is a callback or a function that we actually want to run once that lookup is complete. And that function that's run on completion actually takes two arguments as well. The first argument contains an error if one occurs, and the second is the value, in other words, the IP address of the lookup of the domain. So let's just put some code to print that out to console. So here I've just put in a quick if statement to check if the error has value, and if so, we'll actually log that out to console instead, and we'll exit the callback function using the return keyword. And of course, if there's no error, we'll just log value out to console. So let's have a go running that now from the terminal. So you can see when we run the program, we're not getting any errors, and we actually get the IP address of the domain name that we entered as the first argument to the lookup function. There is also pretty much an identical function called resolve as well, which if we save and run the file again, you can see it gives us pretty much the same output, except we've got two IP addresses in an array that's returned from the function. And that's because the resolve function has actually gone and made a network request to the DNS system to see how many IP addresses are registered with that domain name that we specified, whereas the lookup function just uses the computer's internal DNS mechanism first to see if there's an IP address that it can actually return without having to do a network request. So there is a subtle difference between these two functions, but unless you're going to build an application that relies heavily on checking domain names and DNS settings, then you can probably stick with the resolve function, as it'll give you a bit more information about the domain to work with. You can also provide another argument to the resolve function to specify what type of record you want to look up. For example, within the DNS system, you can find out the mail exchange records of the domain. That is, when you send an email to the domain, which are the servers that should handle that email request. So if we modify our function to do that now, and run the program again, you can see I get an array back that has the mail exchange records for that domain. So one final function that we'll look at in the DNS module is the reverse function. So the reverse function works exactly the same as lookup and resolve in that it takes an argument and then has a callback as a second argument, but instead of supplying a domain name, we're actually supplying an IP address, and this function will actually go into the DNS system to find out if there are any reverse DNS records associated with this IP address, which quite often there isn't, but with this IP address, it's actually owned by Google. It's actually the publicly accessible DNS resolver that you can use to use Google for your DNS requests. But that's not massively important here. They do have a nicely configured reverse DNS record setup, so we can use the reverse function to find out what that is. So let's run the program again. And as you can see in the output, we actually get the textual representation of that IP address within an array. So this could be useful if you want to find out who owns an IP address, or simply to check if it does actually have a reverse record configured. So if a lot of these terms have been confusing in this video, don't worry too much. As I mentioned, the DNS module is rarely used unless you're writing some kind of large-scale program that requires knowledge of domains that you're working with. But hopefully this short overview is just giving you an idea of what you can achieve with the DNS module, should you ever have any need to use it within
This video is about doing DNS lookups in Node.js. It's a really useful skill. Anytime you're doing anything on the internet, you pretty much need to resolve a domain name. So we're going to show how to do that using this DNS module. So let's import that as a constant. DNS equals require DNS. And we're going to use that straight off here. DNS.lookup on tia.com. And let's see, we'll do error address and family. Now family will be the type of IP address, whether that's IP version 4, IP version 6. Okay, and then arrow function here. We're going to send that to just a console.log. So we put address, and then we're going to put plus the actual address. And then let's also add in family. Plus what the family is. Like again, that's IP version 6, IP version 4. And that's about it. Let's give this a go and see how it works. So node DNS lookup. And there we go. Oh, space would have been nice in there, but that gives the idea. Address. The IP address family 4 is an IP version 4. I'm just going to add that space in here. A little bit OCD. Run it again. There we go. Okay. Thank you for watching. Actually, one more thing. Why don't we try, again, adding in an argument so we can make this into a little tool that we can actually use. So we'll do constant input text equals process.arg2. And instead of that being hard-coded, it's going to be input text.
But right now, let's just focus on getting our program to function. So I'm going to define my class. I'm going to call it emitter, which extends or inherits from this event emitter object, and it's just a class. So I'm just going to define an empty class. This is the same if you define an object and define prototype this object to point to prototype this object. So let's now move on. Now that I have my class emitter, I'm going to create a new instance of it using the new keyword. So I'm going to say const my emitter, which I'm going to abbreviate it to just my e, equals new emitter like this. Now with my object in place, I could now make use of those methods that this object, this event emitter object, gives me. So I could say my e.on foo.
very expensive to fly, and it was very unreliable. People died on this on a couple of different missions, and we decided to stop using it for all these reasons. So after that, if we wanted to put people in orbit, we had to get a ride on the Soyuz, and then from there, the trajectory of our space program kept going downwards. And so if you talk to somebody like me, sometime around the year 2002 or 2005, we all had this attitude like, isn't it a shame? Like the USA used to do all this cool stuff in space, and now we like don't really do anything, and the science fiction future that we visualize isn't really going to happen, and we don't ever see that changing, but what can you do about it? Oh well, shrug, right? That was just everybody's attitude. But not quite everybody, right? At some point, somebody came along who made a bunch of money on a website and said, hey, I want to do something about this. Despite having no rocket experience, I'm going to start a company to launch rockets and to do bigger stuff than we've ever done before. And so here's an excerpt of a video about why he did that stuff.
Then there's becoming multi-planet species in space tranquilization. This is not inevitable. It's very important to appreciate this is not inevitable. The sustainable energy future, I think, is largely inevitable, but being space tranquilization is definitely not inevitable. If you look at the progress in space, in 1969, we were able to send somebody to the moon. 1969. Then we had the space shuttle. The space shuttle could only take people to low Earth orbit. Then the space shuttle retired, and the United States could take no one to orbit. So that's the trend. The trend is like down to nothing. This is not. People are mistaken when they think that technology just automatically improves. It does not automatically improve. It only improves if a lot of people work very hard to make it better. And actually, it will, I think, it by itself degrade, actually. You look at great civilizations like ancient Egypt, and they always make the pyramids, and they forgot how to do that. And the Romans, they built these incredible aqueducts. They forgot how to do it.
So his idea was pretty successful, and today we're like landing rockets, and we're seriously talking about doing another moon mission as soon as the year 2024. We'll see if that actually happens, but we're at least talking about it seriously, and that's a pretty good thing given where we were not long ago. So Elon talked about a few things from the past that were great achievements that have been lost, and I want to go through a few more of those to reiterate his point that technology automatically degrades. This thing here that you see is the Lycurgus cup. This was a relic found and dated back to the Roman Empire, 300 AD. And it's made of glass, and this glass that it's made of is the world's earliest known nanomaterial. Okay? The color of the glass changes based on how you look at it, like where the light source is. So if you're looking at it standing in front of the glass and the light source is sort of over here with you so that you're seeing it with reflected light, then the goblet is green. But if light is passing through it, the goblet is red. They had this in 300 AD, right? And then the Roman Empire fell, and that knowledge was lost until basically forever. The way this worked was actually, it got figured out around 1990. The glass is suffused with very small particles of silver and gold. By very small, I mean 50 to 70 nanometers, which is so small you would not be able to see them with a physical microscope. You would require an electron microscope to see these particles, right? But at some point, the Roman Empire fell, and they forgot how to do it. A lot of craftsmanship went into this. You can see, how it's hollowed out on the inside where the little guy's body is to give him more of a purple sheen as opposed to a red in background. And if you hear people talk about this today, or you read up on this, they tend to have a dismissive attitude toward it, like, oh, the stupid Romans didn't understand technology. They probably didn't even know it was silver and gold that made this happen. It was probably just an accident, and they made like 5 of these, right? Which is complete nonsense. Like anybody who actually builds things, as opposed to just writing about them, knows you do not get a result this good without a constant process of iteration and refinement. You can imagine there was some initial accident, like maybe somebody wanted to make glass sparkly and they tried to put silver and gold in it, and then they noticed a little bit of discoloration, and they said, like, why is that there? And maybe they pursued that. Like, what happens when I change the proportions, right? How thick should the glass be? Like, engineering results this good takes a long time. And what that means is that in Rome, people were doing something that we would recognize today as material science. And then that was lost. Other stuff happens. Like in the Byzantine Empire, they had flamethrowers, and not like little dinky things. They had giant pressurized vessels in the bellies of ships that shot out a napalm-like substance out of metal tubes that they would use to incinerate neighboring vessels. It was napalm-like in the sense that like water would not put this fire out, right? It was a very serious weapon. It was a state secret of the Byzantine Empire. They used it to defend Constantinople over and over again for hundreds of years until one day they couldn't really do that anymore for whatever reason. And this military secret just faded from knowledge. Nobody knows how to do it now, right? Obviously, we've reinvented flamethrowers, but they're different. This is the Antikythera mechanism, which is named after an island in Greece where this was found on a sunken ship. It was just a corroded hunk of metal, or a number of corroded hunks of metal, but it was very clear when they originally discovered that gears were involved. And over time, people analyzed this. They realized it's a mechanical calendar that was used to say things like, what year is it? What are the phases of the moon? Where are the planets going to be right now? When is the next Olympic Games, right? And people have run scans on what is left of this and managed to deduce what all the gears were in this mechanism. And it's very different from what I thought. When I first heard news about this, I thought, like, oh, they must have had some cute little gear things in Greece. That's surprising. But let me just show you the scale of the generally agreed upon reconstruction of what this device actually was. That seems like a lot of gears, right? But wait, there's more. So ancient Greece had that, but that is not the picture that we have today of ancient Greece, right? And the thing to realize is you don't just get here from nothing. It's not like one day there weren't any gears and then the next day some guy makes this, right? You need a whole process of science to create something that sophisticated. And we don't know anything about that today, right? All of that was lost. And I could go on and on with examples. There's a whole bunch of things from history that are like this, but we don't have time. I just want to restate that right now we live in a very privileged time where technology has been in a good shape for a long time. We see it getting better, and so we imagine that the natural course of history is that technology always improves, and that these moments in history are just like little blips or something that we heard about. But they're not just little blips. It's actually sort of the regular course of world history that great achievements in technology just get completely lost because the civilizations that made those achievements fell or had a sort of a soft fall where they failed to propagate the knowledge into the future, right? Technology goes backward all the time, and not just in ancient history, also in the modern day, right? We lose knowledge all the time. So I'm going to read an excerpt from an interview with Bob Colwell, who was the chief microprocessor architect at Intel for a while. But this interview was from before that. It was from the booming days of Silicon Valley when he worked at a startup called Multiflow. They were trying to make a very large instruction word processor when that was a new experimental idea. And they were having a lot of problems. Like when you try to design the chip, you're using components from other manufacturers, and he just couldn't get anything to work reliably. And he was like, what the hell, right? So he says, Rich Lefton and I made a pilgrimage down to Texas Instruments in Richardson, Texas, and we said, as best as we can tell, many of your chips don't work properly. And does this come as a surprise to you? I half expected them to say, what, you're out of your mind, you've done something wrong? Come on, you don't know what you're doing, go use somebody else's chips. But no, they said, yeah, we know, let me see your list. And they looked at the list and said, well, here's some more that you don't know about. And by the way, it wasn't just TI. Their parts were no worse than anybody else's. Motorola's were no good, Fairchilds were no good, they all had this problem. And so I asked TI, how did the entire industry fall on its face at the same time? We are killing ourselves trying to work around the shortcomings in your silicon. And the guy said, the first generation of transistor logic was done by the old graybeard guys who really knew what they were doing. The new generation was done by kids who are straight out of school who didn't know to ask what the change in packaging would do to inductive spikes, right? So when you change the voltage in places on a chip, it generates a magnetic field because that's just what happens. And when those fields interact across the chip, it's bad, right? And the new people designing these chips didn't know to take that seriously.
And that's why technology degrades, or it's at least one reason, right? It takes a lot of energy and effort to communicate from generation to generation these important things that you need to know in order to do a competent job making the technology. And there are losses in that communication process, almost inevitably. And without this generational transfer of knowledge, civilizations can die because the technology that those civilizations depend on degrades and fails. So let's talk about a civilization that fell, actually a whole group of civilizations. The diagrams I'm going to show here are from a lecture you can find on YouTube called 1177 BC, The Year Civilization Collapsed by Eric Klein. And we're talking about the Late Bronze Age, which was the time of a number of civilizations you've heard of probably, like the Egyptians, or the Mycenaean Greeks, right, or the Hittites, the Babylonians. So the civilization, or this network of civilizations, was sort of spanning Mesopotamia and the Mediterranean Sea, and they had developed quite a sophisticated network of trade. So in this graph here, each of these points is one of the civilizations, and the lines are established communication and trade routes between those civilizations. And whereas not all of them were connected to all of the other ones, they were interconnected enough that you could relatively efficiently route things from one place to another if you needed to. And that was very important. Because bronze, which the civilization depended on for things like defense, was hard to make back then. You had to do it by combining copper and tin, and copper was relatively hard to find and was found in places like the island of Cyprus, and tin was also really hard to find and was found very far away from those copper places like in Afghanistan. And you somehow had to persistently ship these things around in order to make your bronze and the other things that your society depended on. And nobody's sure exactly what happened in this collapse, but people believe there was some kind of environmental stressor to kick it off, like there was a huge drought, possibly also some floods are theorized, and this led to some people attacking some other people, and maybe you need to start using your ships for defense instead of trading, and basically you went from all these flourishing civilizations to 100 years later, none of them were left. And by none of them were left, I don't even mean that like the nation states were gone. Like many of the cities were burned to the ground, and the languages and cultures don't survive. Even though they wrote by pressing things into stone, like nobody was able to translate those languages. Even today, we still can't translate a lot of them. So like so much knowledge was lost here in this collapse. We'll get back to it later. But so I want to bridge this to the modern day in some way. And my thesis for the rest of this talk is that software is actually in decline right now. It's in maybe a soft decline that just makes things really inconvenient for us, but it could lead to a hard decline later on because our civilization depends on software. We put it everywhere. All our communication systems are software. Our vehicles are software. So we now have airplanes that kill hundreds of people due to bad software and bad software only. Right? There was no other problem with those airplanes. Now, I don't think most people would believe me if I say software is in decline. It sure seems like it's flourishing. So I have to convince you at least that this is a plausible perspective, and that's my goal for the rest of this talk. And what I'll say about that is these collapses like we're talking about, that Bronze Age collapse was massive. Like all these civilizations were destroyed, but it took 100 years. So if you're at the beginning of that collapse in the first 20 years, you might think, well, things aren't as good as they were 20 years ago, but it's fine. We're basically the same, right? But then you keep thinking that, every 20 years another couple cities get burned to the ground, and then eventually there's like nothing, right? Fall of the Roman Empire was about 300 years. So if you're in the middle of a very slow collapse like that, would you recognize it? Would you know what it looked like from the inside? So of course I expect the reply to what I'm saying to be, you're crazy, software is doing great. Look at all these internet companies that are making all this money and changing the way that we live, and I would say, yes, that is all happening. But what is really happening is that software has been free riding on hardware. For the past many decades, we've had amazing advances in hardware technology. Computers keep getting faster and faster. It's really one of the greatest accomplishments in human history that we somehow managed to do that. And software gets better, in air quotes, because it has better hardware to run on. That's the main reason. Software technology itself has not improved in quite a while, I claim, right? And you can say, but look at all these examples of cool stuff we can do, even in the past couple of years. So like AlphaGo was an AI that'll beat human players at Go. And you can go on like Instagram or whatever app and like make your face look like somebody else's face. That's crazy. We didn't used to be able to do that. And that's true. But one, most of these, again, are products of hardware being fast. Most of these cool things that we do now are due to machine learning algorithms, and it's, those really are relying on quantity of computation right now to produce impressive results. It's hard to imagine being able to train AlphaGo 20 years ago on the computers we had at that time, right? So it's not there are software technology improvements here, right? Machine learning algorithms have legitimately gotten better, but there's two things to say about that. Well, the main thing to say about it, I will say, is just that it's a minority of actual software technology, right? So of the volume of things that we run, the thing that runs the machine learning algorithm that produces the actual impressive result is a very small piece of the program. It's actually really simple once you understand the math, and especially if you don't have to train it, if you just have to use it, right? And so when you take an app on your phone like that does something funny with your picture, the part of it that does the thing that we think is cool and really value, that piece of software is tremendously simple compared to all the stuff about like loading the bitmap for your face or responding to user input events, right? That part of the software is huge and complicated and is the part that's kind of falling apart. So I would characterize software as having small local technological improvements like machine learning with overall inertia or degradation in the rest of the field. And we're very impressed by the improvements though, right? And let me illustrate the degradation part as best I can. And it's to say that we simply don't expect software to work anymore. And I'm not sure when this happened. Computers always had a reputation for being a little bit funny, but if you go back many decades ago, it was generally due to like not being user-friendly or hard to understand how to use it. But today, if you're using a program and it does something wrong, you're just like, yeah, software, restart it, whatever. And that didn't used to be. And if our standards are shrinking over time, how low can they shrink before it becomes unsustainable? So I decided to say, I want to quantify or illustrate how much I put up with this from day to day. So from now on, I'm just going to take a screenshot every time any piece of software that I use has an obvious bug or unintuitive or incorrect piece of behavior. And well, right when I decided that, I was working on my compiler in the command line, and the console that I use after a while just starts saying attempt to index a nil value in the prompt because it's written in Lua for some reason. Then I go to Emacs and I'm working on my code, and Emacs is set to reload files that have been modified, and that used to work fine, but at some point they broke it so that it reloads the file too early and doesn't get the whole thing and half of it is cut off, and I have to like manually reset that every time it happens. Then I go to Gmail, and I'm going to send an email to the rest of the team about some graphics stuff, making decisions about what to do, and I copy a line of a previous email and paste it into the reply box, and then I start typing my reply, and it goes into like a 3-character wide column over here because somehow they've managed to reproduce all the kinds of stupid Microsoft Word formatting bugs that everyone was frustrated with in the 90s and 2000s. Now those are in Gmail, and I don't know how to fix it. Like you fight with it for a while to get it to stop happening. You have to like delete something invisible. I don't know. Very annoying. So then I say, okay, I'm going to get some real programming done. I go to Visual Studio, and I say, I'm going to type in my command line arguments up there. And as soon as I do that, we get this box that says, hey, collection was modified, enumeration operation may not execute. Why? I don't exactly know why that's a problem. Like I'm just telling it a string. We're not going to try to do anything with the string. It's just like save this for later for when we want to run the program. But apparently that's too hard, right? And this is far from the only problem with Visual Studio. Visual Studio has many, many bugs, but this is the funniest one because it's so simple what I'm trying to do, and it can't do it all the time. I don't know what percentage of the time this happens. It's probably like 5%. I don't know, 4%. So then I decided to blow off some steam and play some games. So let me download a game on the Epic Store, but we're unable to start the download for some reason. So maybe I'll go to Steam because that's a more reliable, longer-lasting store, and I'm able to actually download a game. But then when I go to the install window, it's just like a black window, and I have to restart Steam to play the game. Then I manage to play the game, and then I'll tab out for a second to check something, and then now full screen is all messed up, and the game's like up in the corner of a window, right? And then I have to restart the game to get full screen again. And then I'm watching some Counter-Strike. There was a really good match between Cloud9 and Luminosity Gaming about a month ago, and but for the entire match, there was a mysterious sixth player on the Cloud9 side called Undefined up in the corner there. Let me zoom in on that map for you Counter-Strike fans. It's Undefined is on the left. 100,000 people were watching this match, and it was there the whole time. I was thinking about a game I like called Ultima 4, so I went to this website that had a map, and the map was like screwed up because it was like wrapping into extra lines, so I opened a different browser to see it correctly. I needed to get a visa to come to the Russian Federation, so I go to the visa site, and I start typing my information, and maybe I type in my phone number, I put the +1, and it didn't like it or something. So it says phone number is invalid over here. But I couldn't fix the phone number. No matter what I put in, it wouldn't accept it, because whatever the variable was for phone number is invalid would never get reset. So I had to like stop the application, close the website, like clear my cookies, go back, and reapply in order to be able to be very careful when I was typing my phone number. There's just so many of these. All of this was within a couple days. Like, I didn't have to try hard to find these, right? I just had to stop collecting them. But then I come here, and as if to give me more examples in this talk. So here in this hotel, where I've been writing this talk for a couple days, they have this software-controlled heating and lighting system where it's like you kind of push the non-button buttons and things happen. And some percentage of the time, not all the time, when I turn the air conditioning on or off, the phone rings. It's not a full ring even. It's just like a little boop, and then it stops. But I know it's not intentional because it doesn't happen every time. And I am not making this up. This actually happens in my room right now. Okay? And then for this talk 2 hours ago, I was working at the last minute to make a diagram, and I downloaded fully legitimate licensed Creative Cloud Photoshop to my machine. The first thing I do is go file new document. Bam! The new document extension could not be loaded because of a program error, right? And so my whole point though is we are not surprised by any of this. My other point is that it's getting worse over time. So try this every day yourself, because we've gotten used to it. I didn't even think it would be as much when I had the idea to record this. I didn't think it would be as much as it was. Try counting for yourself just every day. Just make a little list of all these things, and I think you'll be surprised how many there are. I don't know if anyone knows what this phrase means, 5 nines. I'm sure a lot of people don't. This used to be a very common phrase in the 1990s and 2000s when people wanted to sell you software or a hardware system. What it means is this system is up and working and available 99.999% of the time, right? 4 nines would be 99.99, whatever. And we don't use this anymore. I think in part because the number of nines would be going down and we can't make it go up again. And nobody, well, certain parties don't seem to care. So I was working on this speech for about the past week, and twice, once when I was asleep on the airplane and once the other night in the room, my laptop just rebooted while it was in sleep mode and just killed all my programs and stuff, I guess, because it was an update. Maybe it wasn't an update. Maybe it was just operating system failing, but I think it was an update. So that automatically takes my laptop down to like 3 nines, or less than 3 nines. And if a laptop is less than 3 nines, nothing running on it could be 3 or 4 or 5 nines, right? So we've even lost the rhetoric of quality that we used to have, right? And so if you say this kind of thing, that software is buggy, then people like web programmers or hacker news people or whatever will say, yeah, we know, but the market won't pay for it, right? Like, we could make software better, but that takes time and money to fix the bugs and all that stuff, and our client won't pay for it, or the market punishes that because you take longer to get to market. And that's true to some extent. I could definitely argue with some parts of it. But here's the thing that I'm thinking today. If you haven't seen an entire industry produce robust software for decades, what makes you think they actually can, right? They're saying we could do it if we wanted to, but we're just totally not. But why would I believe that they actually can do it, right? Because, like we said, there's this generational transmission of knowledge factor that I don't think is being passed along, right? So I think the knowledge of how to make things less buggy is lost. And even the knowledge of a technology company has changed. And again, this illustrates the difference between software and hardware. A hardware technology company used to be a place that makes advanced materials or designs new radar or like does something that you didn't used to be able to do before, right? So now in Silicon Valley, and as nearly as I can tell around the world, a software, quote, tech company is just a company that does stuff with computers and is then hoping to stumble into a market niche that it can exploit. And the point is the market niche. The point isn't the software. And the point is especially not designing higher tech software that pushes the threshold of technology forward, which is what hardware companies always used to do. And so we've even corrupted the words tech company, right? Okay, so now I want to bring a little closer to what we do. There's been a sequence of abstraction that we've gone through as programmers over the decades, right? Originally, you had to program your computer in machine language. Then there was assembly language. And then we had the sequence of higher level languages like Fortran and C or C++. And nowadays we have stuff like C# or Haskell or JavaScript that are even further away from the machine. And the justification for this is like, look, we're working at a higher level of abstraction. The higher your level of abstraction, the more work you get done because you don't have to worry about scheduling machine instructions and stuff. So we're really being smart and we're saving effort. And I think that's actually true. Like, I don't think we want to program things in assembly language. That's a waste of time. But somewhere through this chain, it becomes wrong. And that's how people are wrong a lot of the times, right? Like, you start out by being right, and then you extrapolate it too far into wrong territory. But the important thing to all of this is that we only see one side of it. We see that we're being smart and saving effort, and we don't see the flip side of all of these things, which is that there's a corresponding loss of capability, right? Because I don't program in assembly anymore, I no longer am able to program in assembly, right? If I don't, if I use languages that are too high level, and I'm a little bit lazy, as people often are, I don't know where my variables live in memory or what they look like or even how remotely how big they are, right? I certainly don't know what the CPU is doing in response to the code that I've written. I may be scared to use non-managed languages because the very idea of memory allocation just seems too hard and scary. Or even if I'm a person who programs in a non-managed language, maybe I'm afraid of pointers and start generating this cult of being afraid of pointers and what to do about that, like the modern C++ people do, right? And so the rhetoric that we have is, I'm being smart, I shouldn't have to do the low-level stuff, right? But part of the reality is the loss of capability that corresponds to those choices. And both of those things can be true at the same time. I'm not saying that we're not being smart by going up somewhat, well, a little bit. I mean, there's a problem, which is that the point of going up all these levels is supposed to be to make everybody more productive. But programmers are not more productive now than they used to be. In fact, it looks to me like productivity per programmer is approaching 0, and if that's true, then where's the proof that going up this ladder of abstraction further and further is really helping? So the way to at least get a feel for this is you look at a company like Twitter or Facebook, it employs a lot of people, and you look at their product and you say, how much does that product change from year to year, right? How much functionality is added to Twitter year after year? How much functionality is added to Facebook? It's not that much, right? And then just divide by the number of engineers at the company, right? Which is thousands or tens of thousands sometimes. That's a very small number when you do that division, right? It's going to be pretty close to 0. So what's going on, right? And to illustrate again the difference in productivity, and that it's not just me that thinks this, I'm going to show an excerpt from an interview with Ken Thompson, who is the original author of the Unix operating system, and he's talking about the time at Bell Laboratories when he first started making Unix on a computer that by modern standards had like no software at all, right?
At some point, I realized, without knowing it up until that point, that I was 3 weeks from an operating system with 3 programs, 1 a week. An editor, I needed an editor to write code. I needed an assembler to turn the code into language I could run, and I needed a little kernel kind of overlay, call it an operating system. And luckily, right at that moment, my wife went on a 3-week vacation to take my 1-year-old, roughly, to visit my in-laws who were in California. Disappeared all alone, and one week, and we had Unix.
Yeah, I think programmers aren't quite as productive these days.
Yeah, he says programmers aren't productive these days like that, and everybody laughs. But it's funny, but it's not funny, right? It's really not funny when you consider like how much waste there must be in the difference between how productive people are and how productive they could be if everything wasn't so messed up, right? So I've made a case that robustness of software is declining, productivity of programmers is declining. So if you're going to say that actual technology of software is somehow advancing, it seems contrary to those two facts, right? So I think the argument that software is advancing is clearly false, except again maybe in tiny local bubble-like areas. So now why is it so bad? Why is it so hard to write programs? Why are we so miserable when we try to write programs today? It's because we're adding too much complication to everything, right? And I have a way that I think about this called you can't just, right? Where there's all kinds of things that you used to be able to do on a computer that you can't do today, right? So today you can't just copy a program from one computer to another and have it work, right? You need to have an installer or like a Flatpak on Linux or like containers if you're a server hacker news guy, right? And so people think this is cool. Oh, now we have containers. That's an advantage, or it's an advancement of software technology. All containers are doing is get us back to the 1960s when we didn't have to do any of this stuff, except it's actually not, because it's adding all these steps that you have to do, right? And things you have to maintain. So now let's think about it for a second, like, why do you need an installer to install software? Is it because of the CPU? Not really. Like, imagine you have, well, imagine you have some x64 machine code, and don't worry about how you got it into a computer's memory, but you just got it there, and you just jump to it. You set the program counter to that code. That code is going to do the same thing on a Windows PC as it does on a Mac, as it does on a Linux machine, as it does on an Xbox, as it does on a PlayStation 4, all right? Because all of those systems use compatible CPUs. So what's the installer for? The installer is to get around the incompatibilities that we added at the OS layer, which is this immensely complex thing that we mostly don't want, actually. And so we tend to think about operating systems as adding capabilities to a system, to the system of the hardware and the software, but they also remove capabilities like compatibility, right? And it's often very arbitrary. And it doesn't get any worse than I think it does for us today when it comes to shading languages. Anyone who ships 3D engines is going to know what I'm talking about. So it used to be that if you wanted to compile a program from many platforms, you could write it in some portable language like C or C++, and you might have to do some little if-defs to modify it for the different platforms, but you could do that, and it's mostly the same program. Today, you can't do that because we've decided if you're running a shader, it needs to be in a different programming language on every single platform, even if the hardware is the same, right? So if you have an x86 CPU and an NVIDIA GPU, then on one OS you need to write your shader in metal shading language, and on another OS you need to write it in HLSL, right? And they're different even though they're the same. And so you either have to rewrite everything n times, where n is large, or you have to start using auto translation systems to rewrite your shaders, and those come with a lot of complexity and annoyance and bugs. And why, though? A shader is a simpler program than the old programs that we used to write. But why have we made it harder to build a simpler program? It doesn't make any sense. We don't care, right? So the list of things you can't just do. You can't just copy a program. You can't just statically link. You can't just draw pixels to the screen. Oh my god, the number of steps you have to do to draw a pixel today is crazy. You can't just write a shader. You can't just compile a program on Windows without a manifest and stuff. And on these new closed platforms, you can't just run Xcubal unless it's signed through this like whole process, right? And all of these things and many more that are not on this list add friction, bugs, time, engineering time, and headspace that keeps us from thinking about interesting things to actually do. There are a couple of examples of this that illustrate this isn't going to end anytime soon have entered my own life. So one of my side projects is a compiler, and to compile programs, you need to link them against libraries on people's machine, like for example, the Windows SDK and the C runtime library. And now different versions of things install those in different places on the machine, and so you have to like be able to find them to do the linking.
And rather than make this easy, today Microsoft gives you a program called VSware, which you can find on GitHub. And the job of VSware is just to tell you where these libraries are installed. It is more than 7,000 lines of source code in 70 files. Okay, and they didn't even try to bundle it as a library. It's a standalone program. So what they're thinking now is you can't just make a compiler that's a standalone program. It's obviously going to be a suite of applications. And once you have a suite of applications, what's one more? What's like a little VSware hanging out in there, right? They're not even thinking that this would be bad. It's crazy. I made my own version of this based on some other people's work and got it down to like 500 lines of code, which is still way too many to basically ask 2 questions that should be 2 lines of code, right? It's a multiplier of 250. And then also in the programming language world, there's this thing called language server protocol that is pretty much the worst thing I've ever heard of. And there are just proponents of this. They're building systems for this right now. They're going to be living on your computer tomorrow or today. Already maybe. And as far as I can tell, it's basically a more complicated, slower way to do libraries. So say you've got an editor for some programming language and you want to be able to do stuff that we've been doing for decades already, like look up the declaration of an identifier by clicking on it, or have tooltips that say like what type is this value, right? Well, they say the way you should do that is you have your editor, and then it's a hassle to make plugins. This is the made-up problem. It's a hassle to make plugins for all these different things. So in order to standardize, you're going to run a server on your machine, and then your editor talks over a socket to the server, and the server talks back and gives you the answer, right? Which has now turned your single program into a distributed system. But the flaw in this whole line of thinking that none of these people seems to actually think about at all is that there's nothing special about like looking up the location of an identifier. That's just an API like we have all the time for everything. So the obvious next step, if you're saying that we should architect our APIs like this, is to do this for other tasks, right? So now your editors or whatever program is going to be talking to multiple of these things. And now if you ever want to author anything for this, you now have to author and debug components of a distributed system where state is not located in any central place. And we all know how fun that is, right? But of course, libraries are not that simple, right? Libraries use other libraries. So what happens at that point is you're running all these servers on your system, and who knows, some of them are going to like go down and like have to restart, and people are synchronizing with each other. No, this is a disaster, right? And people are actively building this right now. And meanwhile, while we're spending all this time overcomplicating stuff that we used to be able to do in 1960, in the games industry, we're not even able to do the things that we've needed to do forever. So like today, games can't run consistently in full screen, as you see from the screenshot. And I don't wish to bag on that particular game, because we all put a lot of engineering work into trying to make our game run in full screen. It's kind of embarrassing. Like, why, right? Also, it's actually impossible on a PC right now to render at a smooth frame rate. It is simply not possible no matter what you do. Alan Ladavats of Protein has a talk at GDC and a paper about what you actually would need to do this. We just don't even have that capability, which is insane, right? And yet we're spending all this effort on other things. And so this complication that's introduced into all of our systems, it not only makes our lives difficult in the present when we're trying to build something, it accelerates the loss of knowledge over time, right? So first of all, there's more to know when things are more complicated. And so if you talk about a job spread among many people, each individual person knows a smaller percent of what they need to do. They have a less global view, which makes it harder to do good work, right? And harder to transmit their knowledge on people in the future. Another thing that happens is that deep knowledge becomes replaced by trivia. So deep knowledge might be a general concept, like here's how cache coherency works, and that enables software to run fast on like different processors and stuff. And trivia is something like, well, this sprite in Unity doesn't display properly for some reason, but we know we can fix it if you open this panel and toggle this boolean, and that fixes it for a while, but then some weeks later, for random reasons, the boolean mysteriously untoggles. So just make sure to check that before you ship, and it'll be fine, right? And the reason that's trivial is not only because it doesn't apply to anything else in the world, but it's also going to be outdated in 6 months when the next Unity comes out. And it's just offensive that we're spending our brainpower on these things. Okay? And the third thing that happens is good information is drowned by noise. So if something is really hard to understand, the percentage of people who put the effort into understanding it is going to be small. And the harder it is, the smaller that percentage. And so if you ask people or you learn at a school or you search on the web, your probability of getting a bad answer to the problem is much higher for more complicated things than it is for less complicated things. And so the complication propagates and magnifies. So let's get back to this collapse of civilization stuff, right? The more complexity we put in our system, the less likely we are to survive a disaster, right? Because we have to maintain all that complexity. We're acting right now like we believe that the upper limit of what we can handle is infinity amount of complexity, right? But I don't think that makes any sense. So what's the upper limit? How would we decide how much complexity we can handle? And that's different from what people today actually can handle. So if you have an engineer who can hold a whole system in his head that's really complicated and work on it, when that guy quits and needs to pass on his job to somebody new, he's not necessarily going to be able to communicate all that, right? So the amount of complexity we can sustain over time is less than the amount of complexity that individuals can do today, right? So why am I talking about this at a games conference, right? Like everybody knows that games aren't serious and whatever, right? But video games at least used to be about maximizing what the machine can do and like really impressing the people playing the game. And maximizing the machine means you have to understand the machine very well, and that correlates with robust software, because if you understand the machine well, you're less likely to make the kind of bugs that come from misunderstanding. There's anti-correlations with robust software too. But anyway, now we're not really about that so much, especially talking about independent developers. People are shifting to Unity and Unreal and Mouse, right? Not very many people write their own engines anymore. So we have entire generations of programmers who have grown up learning the program by making little C# snippets that just plug into other parts of Unity or something, and they've never written something systemic, and they've never written something low level. Which on the one hand is fine. Like I'm not saying we shouldn't do that, because there's a degree to which it's smart. It reduces development time, right? It helps you ship your game sooner. But like I said before, there's a flip side. That flip side is giving up the capability of doing the other thing, giving up the knowledge of how to do the other thing. So I don't think it's bad in isolation if a lot of people make games where they just put snippets into Unity, right? But if everybody does that, then nobody knows how to do anything but that. And then after a while, what's going to happen? Because we're assuming that we'll just be able to use these engines forever. But Unity and Unreal were created in an environment where there were lots of people at games companies making engines all the time, right? And that's where they hired people from. And when there's no longer a natural way to learn how to make engines because nobody does it, where are Unity and Unreal going to hire employees from to maintain those engines that everybody's using, right? And to the extent that they can hire people, is the quality of people going to go down because they have less experience? It just takes a long time to ramp up, right? So then maybe at some point, well, certainly at some point, there's not enough people to make a new competing engine. But maybe even at some point, you can't really maintain the old ones, and they just keep decaying over time. That can happen. And so the way I used to think about game developers is kind of like the foundation in the Asimov books, where we kind of knew how to really program computers. And also some other kinds of programmers, like embedded systems people and high-performance computing people, all sort of knew what was going on with computers. And after the rest of software just kind of decays and falls apart, we still have the knowledge, and we can bring it back and give it to people. But I'm not really sure that that's going to happen now, because I just don't know. I mean, I don't know if there'll be enough of us doing low-level work, or even people doing high-level work who understand what's happening at the low level while they do the high level, right? So maybe there needs to be a second foundation. Spoiler alert for anyone who hasn't read the book. So back in the Bronze Age, right, one of the reasons those civilizations disappeared is that the way things were set up was that reading and writing was only done by a small elite class who went to school for years, and this was protected. The public couldn't know how to do this. They probably mostly didn't want to know. And because those skills weren't widespread, they were fragile, so when the society was disrupted, they weren't continued because not enough people could carry it forward. Today, almost nobody knows what's happening on a CPU, right? That skill is not widespread, so it's fragile. And so do we think that this immensely complicated thing that we've built today is somehow more robust than what they had in the Bronze Age with just making bronze? Because that didn't survive. If that didn't survive, why do we think what we're doing now is going to survive, right? And we might have some similar stressors. We might have some climate change issues, right? Or we might have some new stuff. Like what happens if there's so many cyber attacks that countries just start cutting each other off the internet, right? Now, lots of people in lots of countries can't get to Stack Overflow to figure out how to copy and paste their code, so their code production is impacted, right? Or what happens if China just says, you know what, we're just going to keep all the CPUs now. We don't want to sell you any. What's going to happen, right? None of these things in isolation I don't think will bring down civilization, but it can certainly hit the system with a big shock, and if the system is too complex, it may not survive that shock very well. And so I'm just trying to say, like Elon Musk was saying, the technology by itself will degrade, and we need to, as soon as we can, start working against this, right, at every level that we have access to. We have to simplify the hardware we're running on, we have to simplify the operating systems we use, the libraries we use, the application code we write, the communication systems we do this over, like the internet. We have to simplify how we compile, debug, and distribute software, and we have to simplify how people interface with software. And that sounds like really a lot of stuff to do, but the good news is that all of these things are so ridiculously complicated right now that it's very easy to find things to improve. Simplifying any of these systems only requires the will to do it, rather than and a taste. You have to have a taste to recognize how complicated things are, and how they would be better if they weren't so complicated. Okay, now a lot of people are probably like, okay, whatever, software is complicated, but I don't believe civilization is going to collapse or anything. And so, you know, maybe, but I would say if you're a programmer, you should care about this anyway, because even just your own personal future. Like, programmers are not that happy today. We're often very grumpy, and the reason we're grumpy is because we're doing stupid things all the time instead of interesting things. And that's not going to get better if we keep doing things the way that we do them, right? So you personally will be happier if we change the way we do things. And if we do things the way they are now, maybe the future is deeply mediocre in the way that America's space future was going to be deeply mediocre. Now, even if you just want to survive as just an individual game developer, like you're thinking, look, I just want to get my game done, I want to ship it, I want it to succeed financially, even if you just want to have a very limited scope of concern like that, removing complexity is still the right short-term play, even if it doesn't seem like it. I'm sure we all are very familiar with cases like, well, we're going to ship in 5 months, and we're having a lot of problems with this particular system. It's really buggy, you know, it loses people's work all the time, whatever. But we just have to stick with it for 5 months, and it'll be past, it'll be history. And that's good because rewriting it would be a lot of effort, it might delay shipping. And so we're going to stick with it. We're going to stick out the 5 months. And that's always wrong, because always what happens is it takes 2 years to ship instead of 5 months. And so the amount that we suffered from the system is way worse than it otherwise would have been. And maybe, in fact, that system was a large ingredient in why it took so long to ship. So simplify. And in simplifying your own code, to solve your own local problems, you're also building institutional knowledge about how to simplify, which sounds really basic, but I would claim we don't even really have that anymore. Here's some references of videos you can watch if you're interested in this kind of topic. Casey Muratori's video, The 30 Million Line Problem, Sam O'Buria's video, Civilizations, Institutions, Knowledge in the Future, and then Eric Klein's video, which I showed snapshots of earlier, 1177 BC, the year civilization collapsed. And that's all I have to say for now. Thank you for your time.
Wow. Very impressive. Don't you think that the collapse will happen when we reach the point of technological singularity? Because simplifying is, I think, some kind of way to prevent it.
You know, once you start saying singularity, it's too hard. The point of singularity is you can't predict what's going to happen.
Sure, yeah. Maybe the bad may be good.
Yeah, I don't believe in singularity the way a lot of people do. It doesn't seem realistic to me. But as you get close to that kind of situation, things move faster. And if things are moving fast, they break easily.
Okay. Yeah, it's all about foundation, by the way, right?
Yeah. Well, one of the objections, because I'm always criticizing my own, like, what is the counterpoint to this? And what if we just let software get really complicated and then just make an AI that understands it? And that's fine. And it's like, okay, maybe, but you really want human beings to not be able to understand software. It doesn't seem good.
Okay, we have about 5-10 minutes for questions, so if you have one, you can ask. Yeah, come here and ask.
Thank you very much for this beautiful speech and beautiful mind. Welcome to Russia, by the way.
Thank you.
And I've been doing games in GameMaker for 17 years, and we spent 1 year doing 3D in GameMaker. And I was asking myself the question why we did this, and actually now I know the answer. And I have another thought about it. Friedrich Nietzsche, when he was already an old man, he started to lose his sight, and he couldn't write anymore, couldn't think actually, because he would think while writing. And so he started using Hansen's writing ball. And this was the first typewriter to use. But his style changed. And when I switched from GameMaker to Unreal, as a game designer, saw that my style, my way of thinking changed. Don't you think that tools, they somehow force us to think in a certain type of way, and for you making a new language is somehow to break through this and start thinking wider, broader?
I think I would agree with that, and I would also say, though, you know, because we think with tools often, unnecessary complications or bugs in the tools interfere with the thought process, right? Like you're in flow, you're doing stuff, and then something bad happens, and you're like, now I have to go fix this thing, and you can't do what you were doing. So I definitely think that's important. You know, when I'm making my new language, I'm trying as best I can to get rid of all these complications that don't make sense, but there's so many of them, and some of them are baked into our assumptions because, you know, I learned to program by using these complicated systems. So what I see as simpler may be very far from the actual simplicity that we could achieve because my thinking has been trained on those tools. So we'll see how it comes out.
Thank you. Thank you.
Thank you.
Hi. So let's say I'm an indie developer and I'm sold on your ideas. I don't like Unity either, and I want to put pixels on screen with Redis, but I'm not yet ready to write my own engine as you do.
Well, you have to write your own operating system to put pixels on screen.
So what is the set of currently existing tools I can use, or like?
Well, I don't know, because part of the problem is everything is this way. So really what needs to happen is not about specific tools that you use. It's about developing the aesthetics for things that are not a giant, horrible mess. And whatever tool looks like that to you, just use that instead of whatever you're using. And then maybe we could migrate everybody slowly over time.
Yeah, the problem is when I look for ways to like get to the lower level things, I find is like Visual Studio and C++, and it doesn't like help very much. It's super complex and it breaks every time and whatever.
Yeah, I don't know, man.
Thank you very much for your talk. My question is, in 1968, 30 years after the concept of the computer was invented, Edgar Dijkstra said that programming where the mainframes were having 2 megabytes of memory, even then, Edgar Dijkstra said that the programming is just too hard by its concept to be done by human beings. Are you sure that simplification will help to any extent?
Well, it'll help. Whether it makes them completely understandable by us, I don't know. I mean, I think you could. I haven't read the Dijkstra piece that you're talking about.
It's called Humble Programmer.
Okay. I think you could rate it by what problem are you trying to solve, right? And how complicated. Like, there's an inherent complexity to a problem, first of all. And so there may be problems that are so complicated it may be hard to understand what the software looks like to solve that. But then there's also added complication because we're solving this with existing systems, and those systems already prevent us from doing certain things. And so there's a difference between ideal complexity and actual complexity, and I just want to get closer to ideal complexity. Whether that's good enough, I don't know.
I think I agree with a lot of things he was saying there. I'm not sure if TypeScript classifies as more complications in his point of view, but I also feel that a lot of times people complicate things just for the sake of complicating them, when it isn't necessary. But I also don't have all of the experience that this guy has, so I might be agreeing with him for the wrong reasons. And also pretty sure that this guy streams on Twitch as well. He seems very intelligent.
Function. I know it's probably not making sense to you, but
I think I'm gonna study Redis, and maybe I'm not gonna be able to study Bash scripting. Or maybe I should stop here. I think I'm gonna do a few of these. Maybe try to do everything depending on how big the videos are. And if I can go through them relatively fast, then I finish today. If not, I continue tomorrow. I think tomorrow the first thing that I'm gonna do is watch all these other videos on Node.js, so maybe after I stream, and then do the test on Turing. And after that, I'm gonna study the other stuff that is remaining. And I also have to finish a book that I'm reading about networking, programming, networking with Python. And there's still 200 pages relatively. I want to finish that book because I have another book that is about the computer, how the computer operational system works. And I'm very anxious to read the other book, so I want to finish this one fast. So I think I might spend, after I study this stuff, I might spend a lot of time reading before I even start the getting data from the blockchain. Just so I can finish this other book fast and I can start the other one.
Between the request by informing the operating system. In this video, we're going to take a look at Redis transactions. Redis transactions allow you to group a collection of commands into a single step, and they give you a couple of guarantees. One of those is that all your commands will be executed sequentially. That means the first command will be executed, then the second one, then the third one, and so on. This guarantees that commands are executed as a single isolated operation. The second is that either all of your commands or none of them will be processed. And what this means is that Redis transactions are atomic. And what this means in practice is that if you're in a transaction and you're running a couple of commands, and then the client loses connection to the server, none of those commands will be run. However, if you call the exec command, which we'll discover in a moment, all of those commands will be performed. Now we understand a bit about transactions, let's dive in and have a look at the examples. Just going to go ahead and do an mget on name and language to show you that we don't currently have any of those. To start a transaction in Redis, you use the multi command, which will go ahead and create a transaction, and go back and OK. And you can see here that we are in a transaction, we have this TX on the left hand side here, just signifying that we're in a transaction. I'm going to go ahead and set the name to be Tim. You'll see that is now queued, so that means it's not been run, it's not been performed yet, but it's been queued to be performed once we end the transaction. I'm going to go ahead and set language to be Python, and you'll see that's also queued. And then to end the transaction and to run all the commands we have queued up, we use the exec command. And you'll see we get OK, and then if we run the mget name and language command, we will see we get back Tim and Python. Now we've seen a simple example of how a transaction works successfully. I'm going to go ahead and clear all the data within our Redis database. Let's do an mget of name and language to confirm that's all deleted. And we can see that they're both nil. We're now going to go ahead and create a transaction with an error within that transaction. So we're going to do some syntax that isn't correct and see what happens there. I'm going to go ahead and create our transaction with the multi-keyword. You can see we're now in the transaction. Let's set name to be Dave. Let's set age to be 47. You'll see they've both been queued successfully. If we then go and do a command that is going to break, so let's use the lpop command and let's try and lpop the name, and that won't work because we can't list pop a string, which is what name currently is. You'll see that's now queued. Nothing's run yet, it's still in the queue. If we then set language to be Java, again, that's now been queued. And if we run the exec command, we will end our transaction and see what happens when the lpop command causes an error. We can see that the first command succeeded, the second command also succeeded, but the third command failed with the wrong type operation against a key holding the wrong kind of value. And then you see that the fourth command also succeeded. And what this means is that even if you have an error, commands after it and commands before that error will be successful. If you're familiar with SQL, where transactions will roll back if there's any error within that transaction, that doesn't happen in Redis. If you go ahead and do an mget of name, age, and language, you will see that Dave, 47, and Java all exist. So all of those have been successful, and even with the error, the transaction has succeeded. Let's take a look at how you discard stuff within a transaction. So we've still got Dave, 47, Java, name, age, and language set. Let's create a new transaction with a multi-command. We're going to go ahead and set language to equal Rust, and that has been queued. And let's say we made a mistake here, don't want to set language to Rust. We can easily discard this with the discard command, which will just end our transaction and not run any of the commands within that transaction. If we run discard, if we then do mget again, we will see that we still have Dave, 47, and Java. So we haven't set language to be Rust because we discarded that transaction. So with the discard command, you can essentially reject everything within your transaction. The final command we're going to have a look at is the watch command. Now the watch command that we're in.
Didn't pay
I'm going to go ahead
attention or
and set the
anything.
name to be Tim.
you'll see that is now queued. So that means it's not been run, it's not been performed yet, but it's been queued to be performed once we end the transaction. I'm going to go ahead and set language to be Python, and you'll see that's also queued. And then to end the transaction and to run all the commands that we have queued up, we use the exec command. And you'll see we get OK, and then if we run the get name and language command, we will see we get back Tim and Python. Now we've seen a simple example of how a transaction works successfully. I'm going to go ahead and clear all the data within our Redis database. Let's do an mget of name and language to confirm that's all deleted. You can see that they're both nil. We're now going to go ahead and create a transaction with an error within that transaction. So we're going to do some syntax that isn't correct and see what happens there. I'm going to go ahead and create our transaction with a multi-keyword. You can see we're now in the transaction. Let's set name to be Dave. Let's set age to be 47. You'll see they've both been queued successfully. If we then go and do a command that is going to break, so let's use the lpop command and let's try and lpop the name, and that won't work because we can't list pop a string, which is what name currently is. You'll see that's now queued. Nothing's run yet, it's still in the queue. If we then set language to be Java, again, that's now been queued. And if we run the exec command, we will end our transaction and see what happens when the lpop command causes an error. We can see that the first command succeeded, the second command also succeeded, but the third command failed with wrong type, operation against a key holding the wrong kind of value. And then you see that the fourth command also succeeded. And what it means is that even if you have an error, commands after it and commands before that error will be successful. If you're familiar with SQL, where transactions will roll back if there's any error within that transaction, that doesn't happen in Redis. If you go ahead and do an mget of name, age, and language, you will see that Dave, 47, and Java all exist. So all of those have been successful, and even with the error, the transaction has succeeded. Let's take a look at how you discard stuff within a transaction. So we've still got Dave, 47, Java, name, age, and language set. Let's create a new transaction with a multi-command. We're going to go ahead and set language to equal Rust, and that has been queued. And let's say we made a mistake here, don't want to set language to Rust. We can easily discard this with the discard command, which will just end our transaction and not run any of the commands within that transaction. Run discard. If we then do mget again, we will see we still have Dave, 47, and Java. So we haven't set the language to be Rust because we discarded that transaction. So with the discard command, you can essentially reject everything within your transaction. The final command we're going to have a look at is the watch command. Now, the watch command allows you to optimistically lock a value. And what this means is that you can lock the value so that if another client changes that value and you're currently editing it within a transaction, your transaction will not change that value. It might be a bit complicated, but we'll see it in the example and it'll make absolute sense. What I'm going to do is I'm going to set a count to equal 1. And if we do get count, we can see it is 1 in the top terminal. And if we do get count, you can see it's also 1 in the bottom terminal. I'm then going to watch the count. And we get OK, that's worked correctly. Let's go ahead and create our transaction with a multi-keyword. Within this transaction, I'm going to set count to be 100. And you'll see that is currently queued. I'm going to leave this transaction open, while in the other terminal, we go ahead and get our count. We can see it's still 1, because our transaction that's changed it to 100 hasn't been executed yet. We're then going to go ahead and set our count to be 5. And if we get our count again in the second terminal, we can see it is indeed 5. Now, because we've got the watch keyword on the count, when we execute this transaction, nothing will change, because count has actually been changed underneath us. Another client has got hold of it and changed the value, so us setting the count to 100 in our transaction isn't actually correct, because something else has gone ahead and changed it. If we exec this transaction, you'll see we get back nil, which means that nothing has happened with this transaction. And if we do get count, you'll see the count is actually 5. Not 100 that we set to in that transaction. So what it means is that if you have the watch command on a particular key and you edit it in a transaction and something else edits it at exactly the same time while you're in that transaction,
Hi everyone, this video will be talking about what caching is and how we can use it to design systems. So at the end of this video, you should be able to tell what a cache is and the situations where a cache can be used, and of course, how you'll be using it. So what is a cache? Imagine you have this server and you have a database from which you pull out results. So whenever there's a user request to your server, you actually pull out results from the database. There are two scenarios where you might want to use a cache. The first use case is when you're calling for some commonly used data. For example, you have your profile and that is stored in the database. The same user is asking for the profile multiple times, and had you saved it in this box, then you will save a lot of computation. So within this box, maybe you can keep a cache, an in-memory cache, which is in your memory. It stores the profile per user, so you have a key and a value. And so that is the first reason why you want a cache, to save network calls. The second use case is when you want to be avoiding computations. For example, you want to find the average of all users, the average age of all users that you have in your system. In this case, one of the ways that you can do this is every time a person asks you for the average age, you go to the database, get all the users, find the average of the age, and then return that. Now this is very expensive, of course. So instead, what you can do is you can do this once, find the average age, and then store it in the cache. So that's the key and the value. So average, and then 26, 28, whatever will be the thing, the key value, store it in the cache. The final scenario when you want to be using a cache is when you want to avoid load on the database. So if you have a lot of servers and they're all hitting the database to get information, it's going to be putting a lot of load. Instead, you can get some caches, maybe 2 or 3, distributed system, after all, and then you can keep that information in the cache. You can hit the caches, avoid hitting the database. But the first 2 points are the key ideas of a cache, which is either avoiding a network call or avoiding computations. And both of them are designed to help you speed up responses to your clients. So a client makes a call and you immediately give a response if you have it in cache instead of making a query to the database. So now that you know the benefits of a cache, your first instinct might be to just store everything in the cache, like cram it up with all the information, because the response times are much faster when you're pulling data from the cache. You can't do that for multiple reasons. Firstly, the hardware on which cache runs is usually much more expensive than that of a normal database. The reason being that this cache usually runs on SSDs, which is expensive compared to commodity hardware that a database runs on. The second thing is that if you store a ton of data in the cache, then the search times will increase. And as the search times keep on increasing, it makes less and less sense to use the cache while you just go into the database. Yeah. So you'll be saving on the network call, yes, but a ton of data on the cache is not just expensive but also counterproductive. So our problem becomes storing information in cache such that the database has almost infinite information, while a cache needs to have the most relevant information according to the requests that are going to come in future. So we need to predict something. To predict things, we need to ask ourselves just 2 important questions. When do I make an entry in the cache, which is when do I load data into the cache, and when do I evict data out of the cache? The way in which you decide for loading or evicting data is called a policy. And because this video is on caching, this is called a cache policy.
So your cache performance almost entirely depends on your cache policy. There's multiple policies you can have. LRU is probably the most popular, least recently used. What it says is that whenever you're pulling in entries to the cache, keep it on the top, and whenever you need to kick out people, kick out the bottommost entries, which means the least recently used entries in the cache. So the top entries are going to be maybe seconds ago, and then you keep going down the list, minutes ago, hours ago, years ago, and then you kick out the last entries when you do need to. Okay, for example, if there's a celebrity who's made a post, made a comment, and everyone wants to pull that comment, so you keep that on top of the cache, and while it's hot, while everyone wants to read that comment, it's on top of the cache, performing really well, and when it gets cooler, when people stop asking for that comment, it keeps getting pushed to the end of the cache and then it's kicked out. Alright, so that's the LRU policy. The LFU policy, least frequently used, is not frequently used in the real world, so you can read on it, of course, in the description below. And some policies have started to perform really good, even better than LRU. So they are sliding window-based policies. One of the Google developers who made Caffeine has implemented this in the caches. Now imagine you have a really poor efficient policy, which means that hitting the cache is of no use, and you ask the cache for some data, it always responds that I don't have it, and then you have to go to the database again. The first problem over here, which is with the poor efficient policy, is that it's actually harmful to have a cache because you're making that call, that extra call, which is completely useless if you have a poor efficient policy. So the second problem can occur if you have a very small cache. So users X and Y need their profiles, and this is a profile cache. So X asks for their profile, you get it from the database, you put X in this cache, and let's say it can just store one entry. Y asks for their profile, you have a cache miss, you go and hit the database, get that entry, populate it in the cache, and now X makes another call, which means they need X. So there's a problem here. So this concept is called trashing, where you're constantly inputting and outputting into the cache without ever using the results. So it's again hurting you more than helping you. The final line of data consistency. It's really not that. All servers are hitting this global. Yeah. So this scale the Redis caches independently while keeping the services as containers running on these boxes. So and it's also rather simpler to implement. But the benefits of having it separate are going to be seen now. You can have something like a global cache. And since we always work with distributed systems, it's going to be a distributed global cache, and I'm just drawing one over here. The benefit of this is that all servers are hitting this global cache. It's limited in size, so if there's a miss, it's going to be quelling the database. Otherwise, it's going to be returning. What's the possible benefit? Well, you're avoiding queries on the database and increasing queries on the cache. But more than anything, actually, this is a faster disk read. So it's going to be something like Redis. I think a lot of people are actually asking me what this is. What is Redis? And this is one of the common use cases of Redis. It's like persistent storage, which is like a cache. Yeah, so this is a cache. Basically, you can keep a few boxes which are just going to be storing memory, and whenever a person asks for a key, you return a value. In this case, what happens with S2 caches? Nothing really, because everyone is going to be querying this global cache anyway. And because it is distributed and it's going to be maintaining that data consistency, we can offload all that information, all that headache to this guy over here. Although it is slightly slower, it's more accurate. In this choice range of placing the cache, I would rather place it somewhere over here as a global cache. The main reason for this is there's higher accuracy in the sense that if a server crashes, it doesn't take its data to its grave. Yeah, it's more resilient in that way. The second reason is that you can scale this independently. Yeah, you can scale the Redis caches independently while keeping the services as containers running on these boxes. So there's certain boxes which are just running services which don't have their data being eaten up by a cache. So my preference would be a global cache. However, for simplicity and for extremely fast response times, you can keep it in the local memory. We are now onto the final important characteristic of a cache, which decides how consistent the data in this is, and that is whether it's a write through or a write back cache. A write through cache means that when you need to make an update to the data that you have, let's say you're making an update to the profile X, you hit the cache, you see that there is profile X in this, and so there's going to be some data inconsistency if you make an update directly to the database. Remember that person X has changed the password. So I'll make an update to the entry for user X, make that update, and then push it to the database. So that's a write through cache. I wrote on the cache before going through it and hitting the database. The second option, of course, is to hit the database directly. And once you have hit the database, make sure to make an entry in the cache. So either the database can tell the cache that this entry is no longer valid, or you hit the cache, you see that there's an entry for X, just take it out, evict it, delete that entry. Once it's deleted, update the database. When there will be a query on the cache, it's going to come here, it's going to see that X does not exist, and so it's going to pull from the database and then send back to you. Okay, so this is the write through mechanism. I mean, the original one where you hit the cache, make the update, and then send it to the database. And the write back is where you hit the database and then make sure that the cache is having a null entry. What is the possible problem in the write through cache? Well, you do the write over here, you go and write it on the database, but what if there are other servers having this cache in memory? Yeah, the profile entry for X is on S1, and the profile entry for X is also on S2. So there's an in-memory cache, and you're doing write through, so you actually update this entry, but what about these guys? So in that case, basically your write through is a little silly, so you can't implement this algorithm, you have to go for write back. However, there's one issue in the write back, and that is performance. When you update the store, the real store, the one source of truth that you have, and keep updating the cache based on that, what's going to happen is there's going to be lots of entries in the cache which are fine. I mean, your consistency is not so important. So invalidating them is going to be expensive because when there's a request, you have to send a response from the database and then update the cache. So this is like the trashing thing that we have again. So write back is expensive. How can we do better? As usual, just use a hybrid sort of mechanism. Write through and write back are both giving you advantages and disadvantages. What you can do is, whenever there's an entry that has to be updated on the database, don't write back immediately. Write on the cache. If it's not a critical entry, if it's something like the person has their comment changed, edited, just write on the passwords you can't before the system is review.
Are you planning out your next application architecture and don't know if you want to try something new? As cloud native developers, we often have to make decisions about what to use on our front end, back end, and that middle tier, which must include some choices around databases here. For today's topic, I want to talk through Redis as your next pick for your database technology here. Hello, my name is Jamil Spain. I'm a brand technical specialist in the U.S. financial services market. When I made my decisions on how to solution Redis in my architectures, I used 3 simple categories to categorize their importance and how it rates for me. And they were the flexibility that it offers me, the implementation, how easy is it to implement, and of course the deployment, the most important thing. The one thing to keep top of mind about Redis is that it is an in-memory data store. That's to say that everything you put in sits in memory, so it has very, very quick and easy access to it. But the role that it plays great is as a cache, and it can also function as a full-fledged data store if you would like to. And of course, if you want to dig even deeper, there are certainly some messaging capabilities there as well. Now, when we talk about cache, what exactly do you mean? Well, that can be any type of structures from strings to hashes to list. I think we all get the picture about what can fit definitely into this database there in the architecture. And when I think about it, as a mobile developer, web developer myself in practice, I know there's sometimes when I want to just put a set of data somewhere quickly to access it later, and this is really where this shines. And so it really helped me to know, categorize it when I needed a quick place to cache something. Very, very easy. Redis was a strong check mark there as well. Let's actually put a check mark there. Now, implementation. There are certainly all types of SDKs are available from C to JavaScript, NodeJS to Java to Python. Be sure to check Redis.io for all the SDKs that are available, but that was a very important factor to me. Depending on the language of choice that I want to develop with, how easy is it to actually integrate and implement the infrastructure there, the data structures that I want to save. Also, one thing that was a big bonus for me is that Redis is compatible with a lot of IoT architectures, whether that's the Raspberry Pi, I'll just an abbreviation here, and also any other ARM-based solutions there as well. It also means that it's really relatively easy to implement as a supporting program to a lot of architectures that I want to do. And then finally, how does this work for deployment? Well, I make my decisions in dev. How easy is it for me to make single instances to prove out my case, of course, and see how it works and how it functions. But definitely, as I get something more mature and I want to advance up to my production or more production level instances here, it works off the traditional main node and secondary node model. One thing of note here is that what I did like about this is that as you publish to the main node, it will do automatic caching replication to the secondaries. That's not something that I really have to worry about, and I can scale out adding more and more replicas, secondary nodes there as I need to ensure the resiliency and that it will always be available. As we know, we want to make sure if we leverage this as a strong component of my architecture for caching, I want to make sure it's going to be resilient and be up from there. Check mark there. Now this is just an entry conversation into Redis as your database choice. Feel free to check redis.io for more. Thank you for your time. If you have questions, please drop us a line below, and if you want to see more videos
in Redis database. So in order to perform transactions, we use a command called, or you can say keyword called multi. So let's first get into Redis prompt by typing redis-query. Now that we are on Redis prompt, simply type in multi keyword. Once you type it in, next thing is to keep adding a set of queries that you want Redis to perform. For example, I want to set, let's say, my key and value pair as set code Java. It will be queued. Now I want to get code. Okay. Now again, I want to set something else. Let's say code Python. Now I want to perform code again. All these set of instructions, or you can say set of queries, are queued. So they are going to be executed only when you use the command called exec or execute. So this command has keyword exec. Hit enter and your commands will be executed. As you can see, it is posting OK for set command, then it is returning Java for first get, then we rewrote that key with new value Python, so it is returning Python. This was a simple introduction to transactions in Redis database. In this tutorial, we are going to see Redis transactions. You have already seen that we are executing single commands in Redis CLI to get the job done. Okay, but what if we need to execute multiple commands? What if we need to execute a bunch of commands in a single go, in a single file? Considering the advantage of Redis, which is an atomicity, all the transactions, all the commands which we are executing should be atomic. If any error is there, then all the commands should not be executed. So that can be achieved using Redis transaction. To start a Redis transaction, you need to specify a multi command. Once you enter this command, you are in a transaction mode. So all the commands which you enter from now will be in the queue state, and it won't execute until you specify a execute command. Okay, let's check it out. We started a transaction. We are giving a bunch of commands like set name as Shabir. Okay, it's been queued. Then you can see get name. That has also been queued. We'll do set a as 1, set b as 2. You can see all the commands are being queued. Now all this command will be executed in a single transaction when we specify execute command, which is exec. Once we fire this command, all the commands will be executed. You can see that all the commands have been executed. So this way a transaction has been created and has been executed within a single flow. Suppose you have created a transaction, right? You are adding some commands, get a, get c, get b, any different commands you have been executing. Okay. By the meantime, you want to discard the transaction, you don't want to execute. Okay. So for that, the command is discard. If you specify discard, then all the transactions, all the commands that you have been added to the transaction, all will be nullified. Okay. Your transactions will be cancelled out. So this way you can execute a transaction or discard a transaction based on the requirements. Now there is a special command.
Hello everyone, welcome to another video in our Redis series. So in this one, we are going to be talking about a distributed locker. A distributed locker is a way of locking the block of a code from execution, so it prevents your application to execute it, meaning that if you have multiple instances of your application, only one instance gets to execute that code. If there's something that you need and might have use for, stick with us, and in this video we're going to explain you how to build one and how to use it. So let's take a look at what we have here. For this implementation, I have built a service called distributed locker, which has this Redis value operations. This enables us to insert some values in the Redis. We have also created a lock method, which has a couple of properties. It has the key property, which will be the key in Redis cache. Also has this integer value, meaning that how long a lock should be acquired in seconds. That is the time that you want to retry to acquire the lock. So if you already locked it and you try to execute the task again and you figure out it's locked, this tells you for how long should you try that. And this property here tells you how long this lock should be kept in Redis, meaning that if after some certain amount of time, so this time here, the lock has not been, so the task has not been finished, you automatically release it or you remove it from Redis. Next, we have a try catch block where we try to execute some part of the code, and if we have an exception, we log it, and we also return this lock execution result with the build lock acquired with exception. So here, lock execution result is just an object that I created, which has three properties: lock acquired, result if lock acquired, meaning that this is the result of the task, but you will only get it if you acquire the lock, and also an exception. Here we have just a few methods to help us. Infinite loop absent method. Set if absent enables us simply that amount of time on the application startup also. So as you can see, we have second and then execute. First, we'll take 3 seconds to finish, but the other two will try only for a second and then just say
think I'm gonna stop here and continue this tomorrow. Like I said before. Yeah, so first thing that I'm gonna do tomorrow before, I'm not even sure if I'm gonna stream or not, but I'm gonna watch these videos on Node.js, then do the test, then study bash scripting, do the test, and study all of these other ones. And if I have time, then I'm gonna read the book, finish the book that I have. And hopefully after all that, then I can start to study how to extract data and also how to implement data analysis on or get user data from the website. So yeah, I'm not sure if I'm gonna stream tomorrow, but I'll be back sometime. So see you then.